Yeah, so in this particular module, we are going to be first of all discussing about the advantages of REST. Let's have the quick overview about REST before moving ahead. Also, we haven't discussed much about the REST. So all of that also we are going to be covering here in this module. So when you talk about REST, so this actually stands for representational state transfer. Okay. Now in this particular one, like what is representational, how it is actually going to be there. So all of that we are going to be covering along with discussing the advantages for the same. So with the advantage, we are going to be seeing how this is actually coming into the picture, how we can say this is better than so. Okay. So the first advantage of REST is lightweight. So when you talk about REST, so it is generally using your JSON. So when you talk about JSON, there your data is compact. Here you are only going to be including the relevant information. It is not going to be including your extra metadata like your XML was using. So when you talk about REST, so this is going to be quite efficient and faster whenever we will have to send some data on the network. Okay. The next advantage of REST is performance. You can actually say faster performance. So when you talk about serialization and deserialization, so here also if you want any of two application to interact, here we are going to be if this is on C sharp, if this is on Python, and if they both want to interact, what we will do, this application is going to be making use of some JSON format. And when we will have to send it over the network, you cannot send it directly. You're going to be converting it out in the form, in the byte stream of your zeros and ones. And in order to do that, if you will see in the form of JSON, here we are going to be having some less amount of data. Like you cannot say less, you can say compact amount of data. We are having only relevant things. So when you are going to be performing some serialization, when you are going to be converting that data in the format which you are going to be using to send it over the network, so that is going to be lesser. Similarly, when you talk about deserialization, whenever you are going to be converting a byte stream back in the usable format, so that is also going to get quicker because here your data is compact. So when you are going to be comparing this serialization and deserialization with respect to when you are going to be comparing it, when you are going to be doing it with the help of JSON as compared to when you were doing it with the help of XML. So in the JSON, you're actually going to be having a faster communication because here you are only having some compact data. Okay. Now, the next advantage of using REST is flexibility. So when you talk about REST, here the services are more flexible because they do not depend on rigid message format. So when you talk about SOAP, that had a strict XML structure. REST, on the other side, when you talk about REST, so REST allows different formats for data exchange with like JSON being the most common one. You can also make use of other formats like your XML, Avro, and even the plain text you can use to send the data across. Okay. The other advantage of the same is ease of use. So when you talk about JSON, so it is easy to read, easy to write, and that is going to be reducing the chances of making mistakes. Also, if it is easy to read and easy to write, so it is also going to become more developer friendly. You can also go ahead and integrate it with the modern web technologies like your JavaScript, and you can also you can see that, whenever you are going to be having a communication, that is going to be very faster. So since it integrates well with a lot of modern technology, so it makes it ideal for web applications and mobile applications to make use of REST. Because here, like, when you talk about mobile phones or your web applications, so when you talk about all of those things like your mobile apps and all, so there, if you will see, we need a lot of situation when we have to send and receive data from the servers. So it becomes easy for us to make use of the same. Now the next one is statelessness. Now what it is? So when you talk about REST services, those are REST stateless. Now, what do we mean by that? It means whenever you are going to be having any request from the client to the server, that is going to be independent. The server is not going to store any information about what your previous request was, and that is how it is going to make it very easy to scale and maintain. Now, the next advantage of REST is wide adoption. So, like we discussed, JSON is very simple. It is very fast. It is very flexible. So, because of its simplicity, speed, and flexibility, REST has become the default standard for web services today. So, if we talk about any of the modern APIs, so almost all of them are making use of JSON. And if we talk about all of those modern APIs, especially like, whatever we are going to be making use for the web and mobile application, they all are built using REST. So like, the companies and developers worldwide, they are making use of RESTful APIs so that they can handle communication between your front end and back end and your data sources in your SOA. And what is SOA? That is a service oriented architecture. Now we are going to be seeing like, since I am saying that it is important, now we will also be seeing how it is actually important in your modern software architecture. So like, initially the moment REST was introduced in the market, people started preferring it over SOAP for building the service oriented architectures. And if you will see, today REST is the default standard. Companies all around the world, they all are using REST to connect to your front end applications, to the backend system and the databases. So today, whether you are developing a web application or the mobile application or the microservices architecture, REST APIs are the go-to solution for enabling the communication between the different systems. We are also going to be seeing like, how any application is actually going to be connected, okay, using the REST. Yeah. So like, if you talk about any of the modern application, you are basically going to be having three major components. You will be having a front end, you will be having a back end, and you will be having your data storage. So these are the three major components which any of your application is going to be having. When you talk about front end, so this is going to be the one where all the interaction is going to be there. So whenever any user is going to be using any of the application with the help of some website or mobile application, they are going to be interacting with the front end. When you talk about back end, so like, we are going to be showing some of the results on the screen, be it like, after login we will be showing the profile page or anything. So backend is that server side part of the application which is going to be handling the request, and it is also going to be processing the business logic, and it will also be seeing like how to connect with the database. Then this is your data storage. So this data storage is the one where we are going to be storing our data, where if we will be needing the need of retrieving the data, so this is from where we are going to be taking it out. So when a user is going to be interacting with the front end, they are going to be making a request. For example, you are clicking on a button, or let us say you are submitting a form. So these requests are forwarded to the backend. which may need to interact with the data source to fetch or store the data. Now to enable smooth communication between your front end, back end and data source, we are going to be making use of REST APIs. So REST APIs are going to be used at each of these levels in order to send and receive data in some standard and efficient manner. And this is also going to be allowing different parts of the system to work together seamlessly. Now we will be seeing how data flows in some RESTful architecture. So I have mentioned we are having some front end, back end and data source. So we will first of all see how the data is going to flow between your front end to back end, how it is actually going to be there. So when you talk about this, the front end is going to be making a HTTP request. Okay, and this HTTP request is going to be there either you are going to be making some get request, you are going to be making some put request, or you are going to be making some post request or delete. So these are the different requests which you can make using HTTP. So your front end is going to make a HTTP request to the back end, and how it will do with the help of a RESTful API. Now we will see how your backend is connected to your data source. So the backend may need to query a database, and this database can actually be there in the form of some SQL or NoSQL. So we are going to be making use of SQL or NoSQL so that we can retrieve or modify our data. So this data is typically returned back to the backend as your Java object or your Python dictionary or any other programming language constructs. Now we will be seeing how your backend is connected to your front end. So your front end, after it receives some requests, so what it will do, it will convert this data into a format which is suitable for your front end. Of course, at the back end, we are going to be performing some data processing. But if you will see on the front end, we would be wanting it in some format. We are going to be beautifying it. We are going to be applying a lot of styles to that. So all of those things are going to be taken care. So before sending it to the front end, we are going to be needing to update that information with some images, graphs, or some other visual elements. Now, here when we talk about REST, so we say here it stands for Representational State Transfer. Correct? Now, what does representational word here mean? So many people will remember the full form, but they may not be fully understand what is the meaning of the term representational. In REST, the word representational refers to how data is presented, how data is transformed at different stages of the request and the response cycle. When we talk about representation in the context of REST, so we mean how our data is shown or structured when it is sent between the front end, back end and the data sources. So at all of these steps in the process, the data might be represented in different formats depending upon the stage it is. So let's say you have your database, correct? So when you talk about your database, so data will be stored in some raw structures. How? You are going to be having some tables. That is how your data is going to be represented. When you talk about backend, so here your data is going to be there in the form of some JSON or XML. So we are going to be putting it in these formats before sending it to the front end. When we talk about front end, here the data is going to be presented in the form of some user interface. And let us say you're fetching some data. So it can be represented to you in the form of some text, or it can be represented to you in the form of some images, or they can also make certain charts or certain graphs in order to show, if you talk about some stock market and also they are going to be showing how the stock has performed. So all of that is actually going to be represented in the form of some charts. So when you talk about representational, so representational in REST means that data is represented in different forms depending upon where it is and how it needs to be used. And this data is also going to be allowing different systems to interact with this data efficiently. So how it is actually going to be working. So let's take example of some web application. In this web application, how it is actually going to be there. So you being the user here, this is going to be the front end, this is going to be the back end, this is going to be the data storage. Correct? That is how it will be there. So what exactly is going to be happening? This user is going to be interacting with the front end. Now, in order to process, like let us say this user is saying, I want to see how this stock performed in last 1 week. That request, let us say on the interface, he had the option of 7 days, 15 days, something like that. And he clicked on 7 days. He made a click on the front end. Now what will happen? That request will get sent to the backend. So backend is the place where the entire logic is going to be there and where we are actually going to be crunching and munching our data based upon the request we have made here. So we are going to be writing all our logic to extract last 7 days performance for that stock in this case. But in order to get the data, we are not going to be having it in the backend. Backend is only going to be having some algorithm which is going to be processing the request, right? In order to get the data, this backend is going to be making a request to the database. But it is here if you will see, this database is going to be providing it back some of the data that will go back to the backend, and this backend is going to be sending that response back to the front end. So that is how it is going to be there. So how the data representation is working here. So if you will see, like at all of these places, we are having data and we are seeing how data is represented in all of those places. So if you talk about database, so the database is actually going to be having the table. So whatever data we have, so all of that is going to be stored in some table. So which is a logical representation of your data. If you talk about backend, here this backend is going to be interacting with the database. So data is going to get fetched and transferred as the objects. So here we are going to be having some JavaScript objects. We are also going to be having some of let us say some Python classes, or we can also have some libraries here which is going to be helping us in performing the operation. So these objects are going to be in the memory representation of the data. Now when you talk about sending the data to the front end, so when your backend sends the data to the front end, it is typically transformed in the form of JSON, which is a compact and transportable representation of your data. So this is the most common format which we use in the REST APIs in our today's world. Now, when you talk about your front end, this is the place where we are going to be representing all our data in the form of some visuals. So here your data, your JSON data is going to be rendering some of the images, some graphs, some tables, or some other UI elements. So this is another representation of the same underlying data, but it is now in the form that is easy for the end user to understand and interact with. So if you will see, the entire communication is happening. We came to the database, it sent back the response, the backend sent the response back to the front end, and then the user is able to see, like in the front end only, he is able to see some images or some graphs or something. So that is how it is happening. So if you are going to be seeing here, the data is represented in different forms at all of these places. All right. So now, why it is actually called as representational state transfer? That is because when you talk about REST, it focuses upon the idea that your data is represented differently at each layers of the application. If you will see at the database, here we had all our data represented in the form of some tables. At the back end, we had some JavaScript object. At front end, we had some images and graphs. So if you will see, your entire data is represented differently at each of these layers. So whether it is there in the database, as an object in the memory, or as a JSON on the front end, the data is being transferred in its representational form. The state refers here to the specific condition or the data at any point in the time. So when a user is going to request some of the information, the system is going to send the current state of the data, which we are going to be transforming it into a different representation, like based upon the requirement. Sometimes we are going to be converting it in the form of JSON. Sometimes we are going to be converting it in the XML. So howsoever we want the communication, we are going to be representing it out. Here, the transfer word means moving that representation of the data from one system to the another, one layer to the another. So whether it is from the backend to the front end or from front end to the server. So we are actually going to be moving that representation. So when you talk about REST, which is your representational state transfer, so that is all about transferring the representation of your data between different systems. At each stage of this process, the data is going to look different in the different forms, sometimes in JSON, sometimes in XML or any other format. But the same data is moving across the different systems. So that is how it is going to be there. Now we are going to be taking care of some of the examples so that you can understand how it will be actually working there. So for that, we are going to be making use of some movie booking application. So like if you talk about movie booking application, so here what we will be having, we are going to be having some of the entities, and these entities we call it as noun. So anything which you can represent in the form of noun, those ones we go ahead and call as entities. Apart from that, we are going to be having some of the resources. So these resources means how you are going to be having your data, like with the help of that. So all of these things are going to be there with you, right? Now, what are the examples of your resources? So it could be something like you will be having your movie, you will be having a theater, you will be having city, and so on. So now we are just like, we will be understanding what REST is, what are the resources, how we can go ahead and perform some CRUD operations on that. So like, whenever we talk about REST, we are going to be referring to the resources. So these resources represent your data or services that your application is going to be interacting with. These resources can be anything from the user profiles, products, articles, or any other complex entity like your order, your customer record, anything. In REST, resources are the entities that are going to be representing your data or the services that we can interact with. But these resources are not some abstract data. They are the data that your application is going to be working with. And when we will be working with these resources in REST, we are going to be manipulating our data. And when we perform some manipulations on the data, that we go ahead and call as CRUD operations. So now what is CRUD? So here every letter stands for something. So here C stands for create, R stands for read, U stands for update, and D stands for delete. All right. Now, what do we mean by create? So here, if you want to add some new data to the system, you are going to be making use of create. And let us say you want to add some new user or some product. So that means you are creating a new user, you are creating a new product. And here with the corresponding to HTTP. So what is the HTTP method you are going to be using? So that is going to be post. The next one which we have is read. So what read is going to do, it is going to retrieve the existing data. Let us say you have some user profile, or if you have some listing of all the products, if you want to fetch all of that, you are going to be making use of read. And what is the corresponding HTTP method? So that we have get. The next one which we have is update. So update we use whenever we want to modify some existing data. Like there is some website and a user has already registered to that. Now after some time the user wants to update the email address. So in order to perform that updation, we are going to be modifying the existing data, correct? Also, what could be the another example? If you talk about any e-commerce website, so there a product is, let us say today it is costing 100 rupees. Tomorrow, if it is costing 120, so what we have done, we have changed the price of that product. And what is the corresponding HTTP operation for that? So that is your put or patch. Now the next one is delete. So if you want to remove some data from the system, if you want to delete a user, sometimes we'll be having option like delete the profile, something like that. Or let us say some product is there and after a while you will even if from the order history, if you will try to locate, you will not see any results. So what we must have done there, we have deleted the product. So for that, what is the corresponding HTTP method? That is your delete. Okay, so these are the different operations. So REST is going to be having resources. On those resources, you are going to be performing some CRUD operations. So in order to perform any CRUD operations on a resource in REST, the first thing we need is going to be the address of that resource. So it's if you talk about anyone in the real life, so if you want to locate some person, if you want to let us say you need some help from some of your friends, so the first thing which you need is going to be the address of that person. So similarly here also we are going to be needing address of the resource. In the terms of real life, we are going to be letting the address this is the street name, this is the lane, this is the city, this is the state. That is how we are going to be providing, correct? When you talk about providing the address of the resource, so that is where we are going to be making use of URI. So URI stands for Uniform Resource Identifier. So what does that mean? But this one is going to be doing. So the URI is going to access or manipulate the resources in a standard form. So this URI is your unique address that will identify a specific resource on the network, and how you are actually going to be putting the how you are actually going to be composing it out. So if you talk about a normal address, how do we provide? We initially provide some lane info, firstly we provide some house number, then we provide some lane information, lane or street information, then we provide city, then we provide state, then we provide some pin code. So this is the format which we follow whenever we want to put some address, correct? In the same way, every resource in the RESTful system has a unique URI that help us locate or access and perform some operations on this. So anything and everything, when it is about running, it is going to be running on the computer only, right? And for that, we will be needing a starting point. So for a human, the starting point is going to be the earth. Like if I want to reach out to a person, what is the starting point? Like where it is actually going to be there. Like let us say I want to locate me. So firstly, I am going to be there on this earth. After that, I am going to be there in some city, in some continent, let us say Asia. After that, I'm going to be there in some country, let us say India. After that, I'm going to be there in some city, let us say Delhi. Inside Delhi, I am going to be there, like, inside Delhi, we will be having a lot of other sub locations. So out of that, let us say I'm there in XYZ location and I'll have to provide my house number. So let us say ABC is my house number. So that is how I can go ahead and provide my address. All right. But when I'm going to be talking about a machine, what is going to be the starting point? The starting point is always going to be the IP address. So that is going to be the unique identifier. So if you have a resource and if you want to get the address for that, you are going to be using URI, your unique resource identifier. So the first one which is going to be there is going to be the IP address. Now we have to see what can be the second one. So if you will see in any computer, we have multiple processes for the application running and every process is tied to a port number, correct? So when let me actually take example and for that only come up with a we will come up with the location for that. So like let us say you talk about the movie booking application. Okay, here let us say I have a movie, name is ABC. Now I want to find out address of this movie. So how it will happen? So when we talk about the movie ABC, which is running on our movie booking application, so first of all, we should be knowing that on which machine this movie application is running. Then we need to understand that we will be having a port number on which this movie booking application is going to be running. So this is going to be the second part in the address. IP address is going to be your machine locator. This is going to be acting as your machine locator, right? And you're going to be having a port number. And what this port number is going to be doing, this is going to be acting as your application identifier. Okay, so just how physical addresses help us find specific places in the real world, digital addresses help us find applications running on the machine. So these digital addresses are going to be consisting of two main parts, and that is your IP address and port number. So IP address is going to be the machine locator and your port number is going to be the application identifier. So we are going to be making use of the IP address. In the digital world, an IP address, IP stands for your internet protocol. So your IP address is going to be used to identify a machine. It is going to be telling us that where your application is going to be located on the network. And just how your address is going to be telling about a building is located on a street. So for example, let us say a movie booking application is hosted on a server. Like let's take the IP for the same is something like 192.168.1.100. So this is going to be the location of the machine where we are going to be running the application on the network. Now we need to see the port number. So since IP address is helping us in locating the machine, the port number is going to be helping us in identifying the specific application which is running on that machine. A single machine can run multiple applications at the same time, like you can have take the example of the web server, database, etc. So each application is going to be listening to request which is going to be there on a different port number. This port number is going to be acting like the suite number in the building. Like you are going to be having some house number, right? So similarly, this port number is going to be acting the same. This is going to be helping us in identifying the specific application on the machine. And some of some of the port numbers are already assigned based upon some of the requirements. Like you can say these are some reserved ports. So if you talk about some port number 80, so this one is basically going to be used for your HTTP web applications. If you talk about your port number 443, so if you want to access some secure web, what you are going to be making use of HTTP. So if you want to make use of some secure web applications like your banking and all, you're going to be making use of this port number. The next one is port number 3306. So this is going to be used for the MySQL database. So if they want to make use of a port, they're going to be making use of port number 3306. For that mobile booking application, let us say that our application is running on port number 8080. All right. Now what will happen? Like I told you, you are going to be providing two things. The first one is going to be the IP address. So first you are going to go ahead and provide the IP address. The second one, you are going to go ahead and provide the port number. When you talk about the IP address, what it will do, it is going to be locating your machine, and this port number is actually going to be telling the application identifier. So for that mobile booking application, let us say this is the IP address on which we have hosted it, and for this, let us say we are using 8080 port number. So that is how we are going to be putting our information. Once we have identified the machine or the server where we are running our application, the next step is going to be specifying where our application is going to be running on that machine. So this is typically done by providing the name of the application. And next to the name, we also have to provide the version name. Now, why versioning is important? Like, if you must have seen in the softwares, like which you get on your computers or your phones, you often go through some of the updates. So these updates are going to be bringing some new features. They are also going to be fixing some bugs, or they are going to be improving the performance. So it is essential for us to keep a track of which version of the application you are using. So just think of it like some example, like, let us say you have moved to a new house. So when you will change your address, you will need to update it everywhere with your bank, with your online stores or your friends and family. And why? Because this is going to ensure that any mail, any package or any document that is going to get sent on the correct address. So similarly, when an application gets updated, whenever you are going to get a new version, it is important to update the version number in the URL. So this is going to let both the users and the developer know which version of the application is running, and they will also ensure that you are interacting with the most up-to-date version. So by providing the correct version number, you are providing a clear identification, because that is going to tell which version of the application you are using or you are interacting with. Plus, it is also going to avoid compatibility issue. So sometimes what happens, if an application is changing over the period of time, and certain cases your older versions may not work with the newer versions. So if you are providing a version number, that is going to help in preventing such of the issues. Next one is why versioning is important. This one is also going to be tracking updates. So as your application is evolving, you're going to get new versions. So when you will specify the version number, you can also track which version is live, and this will ensure that you are getting the most recent updates. So after providing this information, like your 192, 168, 100, 8080. So once you have done that, you have to provide the root URI. And how you will do, like let us say I'm using the short form for my application, MBA moving booking application, and next to that I have to provide a version number. So I'm providing V1. So this is going to be the root URI that is going to help us in locating where, like which version you are going to be using. Now, the next important part is naming your resources. So when you talk about RESTful APIs, your resources are going to represent the entities which with the with which you are going to be interacting with. So when you define a resource, it is a best practice to make use of plural nouns. So this is a common standard in RESTful designs, and this helps in maintaining the consistency. Like it is not something which is going to throw error, but this is a standard and it's good to maintain it throughout. Yeah, so when I was saying that we should be using plural names, so how it should be there. So like let us say your resource is movie. So instead of using movie, how we should be using movies. If your resource is let us say a user. So in that case, you should not be using user, you should be using users. I repeat, it's not at all going to be throwing any error or anything. It is just a good naming convention. So when why we actually use plural. So when we use plural names, so that help us clarify that the resource can represent multiple items. Even though you might be working with a single movie, the resource could eventually handle multiple movies. So it is important to keep the name consistent. So how you should be actually entering, like let us say I have a movie 123. Okay, or you can how you actually want to be representing it out. So you should be doing like movies 123. So this is the correct way of writing it down. So in this case, here if you will see, we are using movies. So what movies is actually doing, so it is representing collection of all movies resources. Okay, and here 123 is the specific movie in that collection. Now we will be talking about, we have seen like how you are going to be specifying a resource like movies. So you will also have to provide some specific details about the resource. For example, if you want to access information about a particular movie, you will be appending the movie's URI, like whatever the movie is unique identifier. Here in this case, let us say it is the movie ID tagged to the URL. So like let us say this is the movie ID. Name is ABC. So if you want to append it, how you will do? You are just going to be passing it at the back. So here 123 is specifying the specific movie in the movies collection. So how you are going to be having your entire URI? So like let us say you had something like 192, 168, 1.0.100. So this is your uh, IP address. Now you will be adding your port number. So what that is going to be 8080. After that, you're going to be specifying your application name, that is the MBA here. After that, you are going to be providing the version, that is your V1. Then you are going to be naming the resource. So what is the resource here? Movie. For that, I'm going to be using plural name. So it is going to be movies. Then you are going to be providing a movie name. So like let us say ABC. So if you will see, this is the URI which we have gotten here. Okay, this is the unique resource identifier here. Now, what is URI in RESTful API? So when you talk about RESTful API, the URI is going to be the address which we are going to be using in order to access the resources. It is going to be identifying the location of the resources, and it will also allow clients to interact with them. When you create a URI for a resource, you are going to be following certain standards so that you can ensure that you are maintaining a consistency and you are also following the best practices in your API designing. In the interviews, people will be asking you about creating a RESTful API. So now I will be telling you what are the standards for creating RESTful API, and you have to keep them in your mind whenever there will be any interview. Okay. So now, we will go through some of the important standards which we are going to be taking care whenever we will be creating some RESTful APIs. So the first one which we have here is never use verbs in URI. Now, what does it mean? So a URI is actually going to be representing a resource like movie, but it is not at all going to be representing any action. And what and all are the actions? Like your create, update, delete, all of that. When you talk about these actions, so these actions are going to be handled by the HTTP method. That is your post, get, put, delete. But URI is not at all going to be taking care of that. So what is not correct? Like let us say you want to create movies. So you will do something like create movies. Now after that, let us say you want to update a movie. So what is not correct? If you will write something like update movies. So this is not something which is correct. But if you want to perform some updates, so how it should be there? It will be something like movies. Inside the movies, you can provide something like 1, 2, 3. So what anyone will understand that, okay, you have provided a movie ID, and on the top of this movie ID, you want to perform some of the actions. And why it is not advisable to put? That is because verbs are going to be describing the actions, and actions should be handled by HTTP methods and not by the URI. Now, the next one is always use plurals. Okay, so if you want to, if we talk about movies, so it should never be like movie. This is incorrect. How it should always be there? Movies. Why? Because whenever we are naming any resource, we should always use plural nouns, because this helps us clarify that a resource is representing a collection of items. So even if you're going to be working with a single item, you are actually providing support that it is going to be in future taking care of the other movies as well. So when you talk about RESTful, right? So RESTful is not designed only to work with one entity. It is always designed so that we can work with the collections. Now we are going to be seeing, these are the two things which you should always be taking care whenever you have to design the API. All right. Now we are going to be seeing what is REST and how does it work with HTTP. So REST is a way to design the web applications that is going to be communicating over the internet. It uses HTTP, which is your standard protocol that all the websites and applications are going to use so that they can interact with each other. They can talk to each other. It is built on the top of HTTP protocol. In REST, resources are the pieces of the data or the objects like your user, your product, your message. Each of these resources are going to have a unique URI, which is like its address on the web. In order to interact with all the resources, REST uses HTTP methods. And what and all are those HTTP methods? Your get, put, post, update. So these are the different methods which we have here. So get we are going to use whenever we want to retrieve some information. Post is going to be creating new data. Put is going to be updating the existing data, and delete we will use when we have to remove the data. So if you talk about REST, what REST is like, if you have to talk about REST in the simple language, that is like you are going to be taking resources, which is your core data. On the top of that, you are going to be applying the HTTP methods, or you go ahead and call them as actions. So If you're going to be combining these two things, you're going to be getting a REST out of it. So when we talk about REST, you should always be keeping it in your mind that you are going to be using some resources, and on the top of that, you are going to be performing some actions. Now we will be taking one example so that you can see, like, if you will be giving some scenario, how you can go ahead and design a REST API for that. So the one which I'm going to be taking care is how you are going to be creating a REST API for creating movies in a movie booking application. Now, like, we are going to be, like, breaking it down in some steps so that you can understand it, like in future if you will have to do the same, how you will take care of that. So whenever we are going to be talking about creation, like here I'm saying create movie. So what we will be using for that? Post. So here we are going to be using post HTTP method. Okay. Now after this, we are going to, like, what is going to be the first step here? We will have to go ahead and identify the resource. So what is the resource here? That is going to be movie, because movie is something which we want to add to the system. Now the second one is we will have to define the URI for movie resource. So the URI is the address where the movie resource will be located. For the movie booking application, we will define the movie, like, we are going to be defining it something like movies. We are going to be taking a plural name here. So this URI is representing the collection of all movies in the system. Now we are actually going to be creating a movie. So we are going to be using a HTTP method for the creation. So to create a new movie resource, we are going to be using post HTTP method. The post method is used to send data to the server, and it is going to be creating a new resource. So when we want to add a movie, we are going to be sending a post request to the movie's URI. Now after this, we are going to be creating the request body. Here we are going to be having the JSON data. In the post request, we usually send data in the request body. For creating a movie, the data would be typically in the form of JSON. The JSON is going to be having all the details about the movie. Like, if you talk about any movie, how the JSON could be there for that. It could be something like we are going to be having a title, which is going to be having a movie name. Okay. After this, it can have something like what is the genre of that movie. Let us say we are specifying action. Then we can specify the release date for that. So it can take any date here. All right. Now after that, we can also provide some other data like the duration. We can say this movie is of 180 minutes, something like that. Similarly, we can go ahead and provide other details, whatever the information we will be needing in order to specify our movie. Now, this JSON data is going to be sent in the request body whenever we are going to be submitting a post request. So now what we will do, like, we have listed down all the components, what and all we are going to be needing here. And now what we will do, we are going to be creating the URI for that. So firstly, like we said, we are going to be using a post method. Then we are going to be specifying the URI. Let us say it is something like 0.27, 0.1. Now we are going to be specifying a port number. So let us say it is 8080. Then we have to specify the application. So that is going to be something like MBA. Inside that, we are going to be telling what version of this movie booking application we are using. So let us say this is the version 1 which we are using. Inside that, the next is going to be like, but inside this movie booking application, which resource are we talking about? So let us say that is movies. So if you will see, this is how we have created a RESTful API whenever we will have to create a movie. Now we will see one more example. Like let us say you want to search for a movie based upon the ID. So if that is the case, how you are going to be creating an REST API for that? So firstly, you should be having the URI. So this URI is going to be having a dynamic path parameter. And what is that going to be? The ID. So how it is going to be? For the movies, you are going to be talking about ID. So when you write it like this in the curly braces, what do you actually specify that what it is? This is the placeholder, and for which you are providing a placeholder for your actual movie ID. Okay. Now here we are actually talking about search. So when you talk about search, so what we are doing, we are going to be retrieving some data, right? So what HTTP method you are going to be using here? You are going to be using get. Now after this, we will have to see, like, we are going to be actually doing it with some of the request ID. So let us say we have some ID like 123. So how you are going to be writing it down? It will be something like get. And what we are doing from the movies, I want you to get me movie with the ID number 123. Now we have to even think about the response. So if you are able to locate the movie, if the movie is found, then what you will do, you have to return the movie details. And how you will be returning it down? In the form of JSON. So here what and all things are going to be there? You are going to be providing the title, you're going to be providing the duration, release date, and so on. So all of these things, like, whatever the information we have stored for our movie, we are going to be retrieving it here. If the movie is not found, you must have seen we have one error code for that. And what is that? 404. When you are going to use when movie is not found. So for such a case, you are again going to be drafting a JSON for that. And how it will be there? You will say status. And what the status you are going to provide? That it is error. After this, you are going to be providing some message as well. What that message? Like you must have seen it on the browser. You can write it something like movie with ID 123 not found. Like, this could be any error message which you want to provide. So this is going to be the JSON which is going to be returned when you are not able to find out the movie. So how you are going to be drafting the API for that? It will be like get. You have to get. After that, you will have to provide the IP address. So from this machine, from this port number, from the movie booking application which is running on your version V1, I have some movies, and from there I want you to provide me the ID which I have provided here. Now when you provide it in this curly brace, what does it mean? You are actually taking dynamic parameters here. Okay, here you are going to be this one is actually meaning you are giving path parameters. You are giving a parameter where you can provide the value in time. So this is the RESTful API which we are going to be using for searching a movie resource. So similarly, you can go ahead and create the RESTful APIs for the other resources, for the other situations as well. I hope this must be clear to you. Do practice for the same because this is something which has been asked in the interviews as well. I hope this must. Yeah, so in this module, we are going to be talking about time. So, time is something which we are going to be needing. Like, even if you talk about the real life, how do you actually use time? So, like, let us say you want to talk about this class. So you will be asking for how long this class is going to be there. What is the duration of this class? Correct? Similarly, if you talk about movie, you are going to be asking how long this movie is going to be there. What is the duration of this movie? Similarly, like, if you will see, we are having like, this classroom or any movie or any other scenario. So overall, like, in corresponding to time, you are going to be asking about the duration. So when you talk about time, so what is time? So time is a measure to time is a way to measure the duration of events. So if you are having lots of events, with the help of time, you are going to be measuring that how long that is going to be there. Also, you will be using time so that you can express in which order it is going to be there. Like, let us say I say at 8 p.m. I am going to be starting the class. At 8:30 I am going to be taking the doubts. At 8:45 I am going to be solving a question. So if you will see what I am actually doing, I am putting all the order. I am actually saying that at what time I am going to be doing what. So what I am basically doing, I am putting all of these events in some order, and I am telling that in this order I am going to be taking care of that. So like, when you talk about time, so basically here what we do, we try to understand the sequence or the order of the events. Now, if you talk about time, so how we are measuring time in the real life? So we are making use of something called as physical clocks. So in their physical clocks, like right now also, if you will see, the time is 7:11 here, right, on the top of the iPad screen. So how I got to know about it? By looking at the physical clock. So we measure time by using physical clocks. This physical clock is going to be keeping the things consistent. What does it mean by that? So if this is me sitting here and this is my other friends living in the same society, or you talk about living in the same city, I'm not talking about the same country even, because in some of the countries I have seen, within the same country we follow a different time zone. But yes, if we talk about India, if this is me, if this is my relative, or this is my friend, or if this is my student, like if we all are there in the country India, if you will see, there everyone is going to be following that standard clock only. If I am saying I am going to be starting the class at 8 p.m., so every one of you, like whenever the clock, the physical clock for all of you is going to have 8 p.m., you all will understand that this is the time when we are going to be starting the class. So this is the thing which is this is the thing which everybody is following here. Now, in order to keep everything a proper order, for an effective communication, we will be needing that all the clocks are synchronized. Like I have seen at home, if I'll talk about some people, like what people do, like even in my living room we are having a clock, and that clock, like if my room's clock is showing 8 p.m., my room's clock will show 8:05 p.m. And why Indians usually do it that way, like I'm talking about basically my home, why we do it that way? They believe that we are going to step outside the home from the living room. So if this clock is 5 minutes ahead, so that is how we all are going to be ready before time. So that is the basic psychology which we guys are following at home. But is this a correct way? Can you have an effective communication that way? This person, if somebody in my living room is sitting and if the time is 8:05 p.m., and if somebody sitting in my room, the time is 8 p.m., but this person will go and complain that class was supposed to be started at 8. Right now it is 8:05. We haven't started the class yet. So this guy is going to be disappointed because he is following a clock, even though it is a physical clock, even though that is the clock everybody is following, but this guy's time is showing something else. So is that which is going to work correctly? No. In order to have the effective communication, it is very important that all the clocks are synchronized, because that way it is going to be easier for us to compare the order of the events accurately. And because of this thing, if you will see, I'm talking about the old era, that particular time, even in the mobile phones, we used to set the time manually. But now if you will see, we have something like automatic date and time. So because of that, what will happen, you just have to select that time zone. Like for India, the plus 5:30 is your time zone, where what is actually going to happen, if this is something you have selected, so by default it is going to be synchronizing the time, like it is, the time is going to be same across all the devices. So if you have selected this time zone in your phone, if you have any other person in the same country, if they have also selected it, so they all are going to be seeing the same time. And why we all will be doing that, so that we can avoid the confusion. Previously when people were setting the time manually, so in that case this issue was something which was very common, because they all were setting it manually. So there was a lag of 1 or 2 minutes, like +1 or -1. But with this time zone, all those issues got resolved. So if you talk about it in the real life, like, we are using physical clock, and how these physical clocks are going to be working. So we have something called as latitude and longitude. So we use your physical clocks based upon the latitudes and longitudes, because there is no single global standard clock. So while each country may follow the same time zone within its border, the entire world does not have a global clock. So if you talk about India, so here what we follow something called as IST, which stands for Indian Standard Time. If you talk about US, what do we follow here? Like, in certain places we follow EST, in certain places we follow PST, based upon the region here. So when you talk about it, so this is your Eastern Standard Time, and this is your Pacific Standard Time. So based upon, like, what you have selected, like let us say you have selected PST here, like for the better clarity. So like let us say we are talking about India. So if it is 8:45 p.m. IST in India, so it is around, like the same time is going to be around 8:15 a.m. PST. Like in the US, the same time is going to be reflected like that. What does this mean? This means there is going to be a difference of 12.5 hours. If you talk about EST here, so in this EST, there is going to be a difference of 13.5 hours. So even though time zones are different, people can still coordinate across them. Like otherwise, what will happen? Like I have a class and this person is there in India. This person is there in UK. This person is there in US. This person is there in Germany. So if you will see, I have a like, and this is me. I am sitting in India. So if you talk about this example, so I am sitting here and I am taking a class, and I have a people who are in the different time zones. Still, they all will coordinate and they all will join the class on time. Yeah, so for this class, like, even though we have different time zones, people can still coordinate across them. So if I have to start the class at 8:30 p.m. IST, so this is the time which I have specified. That is why when you have to talk about the global time zone, so if you have to talk about the global time, we generally talk about it by providing the time zone. Like, we will be telling that, okay, if I talk about 8:30 p.m., so I'm going to be following the Indian Standard Time here. And what is exactly going to happen? These guys who all are sitting in the different parts of the world, they can still coordinate. If I have to start the class at 8:30 p.m., so what will happen if we have the student who is joining from UK? What he will do? He is going to be converting that time to their local time. And how? By adjusting the time difference. So why, like, how it is actually helpful, because this is going to help us with the effective communication, and we can collaborate with each other across the different time zones. When you talk about the same thing in the work life, so there we will be having different teammates sitting in the different parts of the world. Now, if we want to coordinate with all of them, how we will be able to do that? We are going to collaborate with them based upon the different time zones. Like if I want to talk to a guy who is sitting in, let us say, US. So if it is my afternoon time, It's not possible for me to talk to him around the same time. So what we can do, we can talk about a time which is going to be working for both of us. Either it is going to be in my morning or it is going to be there in my late night. So that is how, so that both person are going to be available for that. So for that effective collaboration, effective communication, this time is actually going to be helping us. So when you talk about the human activities, even for that, it is still okay to rely on physical clocks. So like let us say somebody is in India and another person is in US and somebody is there in the UK, they can still sync their times by adding or subtracting the time zone, so that they can make it possible for, like, to have a phone call, if they want to text someone, if they want to video call. So even though they are in the different time locations, they can still collaborate with either each other, they can still talk to each other. So in the real life it is still manageable. Now we are going to be seeing the same in the terms of application. So like, let us say we have a centralized system. So in that, every machine is going to be having a different time. So like let us say these are the different machines which we have here. Okay. Now every machine is going to be having its own local time, which is going to be recording the events. Like let us say we are having certain events like E1, E2, E3. Now every event is assigned a timestamp. So these are the events. We are assigning some timestamps like T1, T2, T3. These are the timestamps. Okay. Now consider that this system could be running in different time zones. This machine could be there in the UK, US or India. So if all the events are happening within the same time zone, it becomes easier to determine the order because everything is based on the same local context. So that is going to be simplifying the managing and coordinating events. Correct? Because here what we are doing, like even though, like, if we talk about all of these events, even though like if we are in the same time zone, so like let us say I am sending you a message at 8, you are receiving it at 8. So you are going to understand it, okay, this person has sent it to me at 8 and we have to, like, at 8 I'm sending that, okay, in 15 minutes you have to join the class. So because we all are in the same time zone, it is going to be easier to coordinate. Correct? Now, what I will do, like since here I have specified some events, let me also order them. So if I do it something like E1, E2, E3. So basically what I am doing here, I am ordering the events. So I am saying that these events are going to be happen in this order. So I will take care that, okay, if I'll have to execute these events, what is going to be the order for that? Now, let's think about a distributed system. So when you talk about distributed system, what happened? Instead of having one big machine, we are going to be having a machine which, like, where, like, if, instead of keeping everything at one place, what we will be doing, we are going to be making use of multiple machines which are clustered together, and here different machines are going to be working together. So for this particular one, like I'll just take that, okay, in this distributed system, what is there? So we are having one machine. So this is our machine M1. This is, let us say, our another machine M2. This is our machine M3. So these are the different time machines. These are the different machines in a distributed system. Now let us say this machine is there in India, this machine is there in UK, this machine is there in US. Now here we are going to be following certain timestamps as well. So here the timestamp 1 is going to be there, here the timestamp 2 will be there, here the timestamp 3 will be there. So that is how I have divided it out. So in this setup, if you will see, every machine is going to be having its local clock, and we are going to be setting that clock to its local time zone. However, no clock is perfect. So no clock is going to be 100% error free. No clock is completely free from accuracies. each clock has some degree of error or deviation. So just like, when you talk about chemistry lab, where we say that here we will be having some deviation. Similarly, when we will be talking about clocks, so there we are going to be having some inaccuracies. So when we will be comparing our timestamps from different machines over time, we can expect some differences. Like, there could be some difference from, like, in the timestamp from different machines, and that is because there are going to be certain errors. So when humans, like, when you talk about humans, so they might not be able to notice these small differences, but if you talk about it, these are very significant for the machines. So when you are going to be dealing with very small unit of time like nanoseconds, at that particular time, you are actually going to be understanding the difference there. Now we are going to be discussing that what are the challenges which we face with time in the distributed system. So like, let us say that we are having two events, E1 and E2. Now each event is time stamped according to the local clock of the machine where it is happening. Like, because of the inaccuracies, the timestamps may not align, which is going to cause some confusion about the order of the events. Like, let us say this E1 is happening, like, let us say something like 10. So this is your 10 hours, minutes, seconds, and milliseconds. Okay. And here we have a slight deviation. Let us say when you talk about this event 2, so this is going to be scheduled at, okay. Now if you will see, we will feel that because after looking at this timestamp that okay, timestamp 2 is going to be like, occurring after the event 1. Why? Because this has this timestamp. So first this will happen and after that this is going to be happening. So that is how it is going to be understood. But the actual timing could have been affected by the clock drift, which means the events may not have happened in the same exact order. So this lack of synchronization is a challenge in the distributed system. So when you talk about the application where order of events are going to be very important. So in that case, this challenge is going to, this lack of synchronization is going to become a challenge. So let's talk about banking system. So if transactions are processed out of order due to some time issue, so it can lead to significant errors, right? Because when you talk about banking system, you need everything very accurate. So if you like, so what you can actually do, you can ensure that all the machines in a distributed system have consistent and accurate time so that we can maintain the correct time overall, so that we can ensure that the entire system is going to work correctly, right? So if you talk about a distributed system where you want to know which event has happened first, your event 1 or event 2. So you might think that you can just compare the timestamps and then you can determine which will happen first. Like, if you talk about this scenario, so what you can do, you can just compare this timestamp with this and accordingly you can say event 1 will happen first. But if you will see, this is not going to work correctly. This approach can have some issues. What it could be. So firstly, you need to remember that each machine has its own local clock and no clock is perfectly accurate. There is always going to be some error or deviations in the clock. So if events are on the different machine, the timestamps might not be 100% reliable. Second of all, the information about event 2 might have to travel across a network so that it can reach to the another machine M2. So this is going to even introduce something which we call as network latency. What does it mean? It means the time it is going to take for the event information to send from one machine to the another one, which is going to be adding another layer of uncertainty on the exact timing. So if you try to rely on physical clock to determine which event happened first, you might not get an accurate answer. The clock inaccuracies and network delays can make it impossible to pinpoint the true order of the events. Now, what is the problem with the physical clock in the distributed system? Okay, so in the real world, physical clocks are great for measuring time, but they do not work well in the distributed system. The problem arises because clocks are there in the different machines which are not perfectly synchronized, and you will be having some events which will depend on the network communication, which is going to be adding more delays. Now let us say that we have a WhatsApp group. Okay, in that WhatsApp group we have people from different parts of the world. So like let us say here this person is there from UK, here this person is there from India, here this person is there from US. So that is how we are having people from the different countries. Let us say they all are playing a game in the group, and it matters who is going to be answering first. Now it will become a challenge for WhatsApp to figure out who sent their message first, since each person is there in a different time zone and their messages have different timestamps based on their local clocks. So if you will rely on a physical clock, the digital timestamp, you won't be able to determine the exact order of the messages because your clocks are not synchronized. For distributed system, especially when determining the order of the events across different machines in different time zones, in that case, your physical clocks are not going to be reliable. You cannot depend on the timestamp alone to accurately figure out which event has happened first because of the clock inaccuracies and the network delays. Instead, if you talk about the other methods, like what is the other methods here, you can make use of something called as logical clocks. Okay, or some people also call it as vector clocks. So if you are going to be making these things, in that case you can address these challenges. Now we are going to be discussing what is this logical clock. So, what is the solution of the problem which we had in our physical clocks on a distributed system? So, the answer for that is stop using physical clocks and you start using something which we call as logical clocks. Now, why do we actually need logical clocks? So, when you talk about a distributed system, there logical clocks are used to determine the relative order of the events without depending on the synchronized physical timestamp. Whereas if you talk about the physical clocks, they can be inaccurate and they may not be synchronized across the different machines. So logical clocks are going to be providing you a way with the help of which you can go ahead and track the events based upon the sequence in which they are occurring. So this will allow you so that you can maintain a consistent order of events even in a system where clocks can actually differ. They can vary across the different machines. And here we are going to be taking the example of something which we call as Lamport logical clock. So here we are going to be discussing something called as Lamport logical clock. So this concept of logical clock was introduced by Leslie Lamport. So what happens in the Lamport logical clock? So when you talk about a distributed system where you are going to be having different machines, let us say we are taking three machines, M1, M2, M3. Now all of these machines are going to be keeping track of events, and how they are going to be doing that using some local counter. So with the help of this local counter, they are going to be seeing how these events are actually happening. Okay, so let us say we are visualizing it like this: M1, M2, M3. Okay, so this is the timeline for all of this all of these machines. So in this system, if you will say that, let us say at this timestamp T1, event 1 has occurred. If you talk about this timestamp TS2, another event E2 has happened. Now, let us say that here at E3, we are trying to have some sent event. Now, what is that sent event? Let's discuss about the events. So, when you talk about such a system, here we are going to be having events which will be something like local event, send event, receive event. So these are the three different events which we are going to be having here. Now, first of all, let us see what is your local event. So in local event, here, like whatever the events we are going to be having, they are going to be occurring on the machine itself. So here we are going to be having a process, let us say that process is actually starting or that task is finishing. So all of those are going to be happening here. So each machine is going to be keeping a local counter that will get incremented each time a local event happened. So let us say this event 1 is starting a process 1. This event 2 is starting another process. Okay, that is how it is happening. Now the second one which we have is the send event. So send events are those events which will happen when a machine is trying to send a message to the another one. So let us say here at E3 event, we are sending a message from M1 to M2. So when machine sends a message from one machine to the another, it will be triggering a send event. Before sending the message, the sending machine increments its local counter and attaches the value of its counter as the timestamp to the message. So what will happen here, if you will see, we are actually taking care of something called as TS1. So what we are doing, before triggering that event, we are incrementing it. And later on, we are going to be attaching the value of this counter with the message. And why that is going to be helping us? So with the help of this timestamp, we are going to be telling the receiver that in which order these events are going to be happening. The next event which we have here is the receive event. So when a message is going to be received by the another machine, the machine is going to be triggering a receive event. This will be comparing the timestamp from the received message with its local counter. Later on, this local counter is going to be updated. How it will be like, if we talk about the local counter. So here what we are going to be doing, we are going to be taking max. The max of whatever your local counter is there and when you have received the timestamp. So you're going to be taking both of them, whatever the maximum is there out of that, you are going to pick that value and you will increment it by 1. So this is going to ensure that the local counter is always greater than the timestamp of the received messages, and this is also going to be telling the order in which the events are happening so that we can accurately order all of them. Now we are going to see how Lamport logical clock works. So here what will happen? Every machine in the distributed system is going to maintain a counter, or they are going to maintain a logical clock which will be incremented each time an event is occurring on that machine. If that event is happening, so we are going to be incrementing the counter by 1. When we are going to be sending a message from one machine to the another machine, then the sender machine is going to be including its current logical clock value in the message. We are going to be adding it so that we can understand the order of the events. When the receiving machine is going to get the message, it will be comparing that with its own logical clock with one with the one in the message. So whatever if it is going to be receiving some message, so there is going to be some timestamp which you will be getting as a part of that message. You are going to be taking that timestamp and you are going to be comparing it with the one which you have locally. So the receiving message machine is going to be setting the clock on the largest one. This is what we are doing here. So we are going to be taking the larger of the two values and we are going to add 1 to that so that we can make sure that the sequence is correct. Now, what is the main advantage of Lamport logical clock? The main advantage is that it is going to be helping us in ordering the events across multiple machines. So even when physical clocks are not synchronized, but by maintaining a local counter for all of each events and by adjusting the counters based upon the messages exchanged, it will become possible for us to determine that which event has occurred before the another. So even if the events are there on the different machines and even if there are going to be some network delays, still it will be possible for us to determine that which event has occurred first. So if you talk about it, what logical clocks are doing. So logical clocks are providing you a way so that you can go ahead and track the order of events in the distributed system so that you will get to know which event has happened first. Okay. And when you talk about this Lamport logical clock, so these clocks are going to be helping us so that we can go ahead and establish something called as happens before relationship. So what happens, if let us say we are having two events, if we are having event A and event B, and let us say this event A is happening before event B. So then what is expected that the timestamp of, like let us say this has a timestamp TSA and this has a timestamp TSB. So what happens, what is the meaning of that if we are having that happens before relationship here? If we say event A happens before event B, what does it mean? The timestamp of event A is going to be lesser than the timestamp of B. Okay, understood? So if two events which are occurring independently and there is no causal relationship, like here we had this happens before relationship, but if that is not there, if we do not have anything like that, so in that case, none of the event is happening before the another. Then they can have the same timestamp, which is going to be indicating that these are the concurrent events. These are the unrelated events. And they are happening just in the one after the another. Okay. Now let's take some example of the WhatsApp. So there what will happen, if I'm talking about the different people. So if we have a person who is sitting in US, if we have a person who is sitting in India, if we have a person who is sitting in US and they all are there in your WhatsApp group and they all are trying to send a message corresponding to a question. Okay. Like I'll also give some names. So let us say the person sitting here in the US is Alice. The person who is sitting there in US is Bob and the person who is sitting here in India is Charlie. So these are the different people who are sitting here and they all are playing a game on a WhatsApp group where the event is actually going to be order is actually going to be important. Now, what is happening here, if you will see, let us say Alice is sending her first message. This person is sending it first. So she is incrementing her time clock to 1. After that, Bob is sending. So when Bob is going to send, he is going to increment his logical clock to by 1. So previously it was 1. 1 plus 1, it is going to be 2. Understood? I'm talking about the local events here. Okay. After that, let us say Charlie is sending the message. So the local clock for Charlie is going to set to 3. So these are the different local events which we have here. Now, when you talk about the send event, so when Alice sends her message, she is going to include her logical clock value 1. So this logical value 1 is going to be included in that message. When Bob is going to receive the message from Alice, he is going to check the timestamp. So, the timestamp which he has received from Alice is 1. So he is going to check the timestamp and he is going to update his clock to be greater than 1. So what he will do after receiving this one, he will be doing +1 to it. He is going to update it to 2. Now, when Charlie wants to send a message, when Charlie is going to be receiving a message from Bob, like this is how the flow is there. So when Charlie is receiving, he is going to check the timestamp. So the Bob has a timestamp of 2. So what Charlie will do, he will take the timestamp and update it by 1. So the new logical clock is going to become 3. So by using logical clocks, system are going to be maintaining a consistent understanding about how the events are happening. What is going to be the order of the events. So irrespective what the physical clock is going to be there, irrespective what the network latency, whether we are going to be having some network latency or not, still we are going to be able to understand the order in which the events are happening. So this is very critical when you talk about the applications like your banking system or your messaging system. Here, the sequence of the actions are going to be mattering, right? And why it is like that? Like in a funny example, like let us say they all are talking on a WhatsApp. This person is sending some some message which is funny, but he just sent a part of it. Let us say on the top of that, he sent two message, some message, and on the top of that he wrote something like just kidding, but that just kidding has not received yet. So this, when these two persons are going to just read the first message, they will find it rude. And that is why I'm saying here the ordering is going to be important. Understood? Now we are going to be taking an example where we are going to be using two machines. With the help of that, I'm going to be basically going to be explaining you how we are actually going to be incrementing the counter. Okay. So like let us say we have your machine 1 and we are going to be having your machine 2. So like this is how we are going to be having. Let us say initially we are having a timestamp 0 here, and here also we are having a timestamp of 0. Now, what is actually happening here? Like we are going to be saying that they both are starting with a timestamp of 0. Now, let us say that look, we are having some local events which are happening on your machine 1. Because of that, the timestamp is going to increase. Okay. So what is exactly going to happen? This is some local event which is happening on your machine even. Because of that, your timestamp is going to increase from 0. Now it is going to become 1. Now let us say we are having another event happening here. Because of that, it will be taking your previous timestamp and it will increment it by 1. So your timestamp is going to become 2. After that, let us say now we want to actually have some send event. So which is happening here. So how the timestamp is going to be there? So previously we will be seeing that what the timestamp was, that was 2. Now we are going to be incrementing 1. So your timestamp is going to become 3 here. So that is how it is going to be there. So I hope it must be clear to you how we are doing it for your machine M1. All right. Now we will see for the machine M2. You can see that initially we started with a timestamp of 0. Now at the timestamp 3, your machine 2 is receiving an event from machine 1, which is going to be called as receive event. Okay. So what is exactly going to be happening? So here when it is getting received, so what we are going to call it as, this is going to be your receive event. Okay. Now what is happening, if you are going to see here, At this point, your M2 timestamp is going to update. So here we are going to be seeing what the timestamp is going to be there and how we can do it. I told you how we can evaluate it with the help of a local counter. How it is going to be there? So we are going to be taking maximum of what your latest counter is there. Correct. And when you talk about that latest counter, so we are going to be talking about M2. So for your M2, whatever your latest counter is there. And for your M1 as well, we are going to see what is the timestamp which we have received from your M1. And we are going to do +1 on that. So that is how it is going to get calculated. Now, if you will see what is your M2's latest counter. So that is your 0, right? So we will say 0. Then the next one is your M1's received timestamp. So what is that? If you will see here at timestamp 3, we are receiving an event. So we are going to do 3 here. Now what is the maximum out of 0 and 3? So that is going to become 3. So 3 plus 1, 4. So if you will see when you talk about your M2, so what is going to be the new logical clock time? That is going to become 4. So that is going to indicate that we have received a message from M1. So now if you will have to perform any on the action on your machine M2, so that is going to be happening at a timestamp 4. That is how it is going to be proceeding. Now using this, we are going to be finding it out. Like, when you talk about some complex way, like, how we are going to be ordering the events which are happening on multiple machines. And these are the events that are going to be happening using the Lamport logical clock. When I want to order the event, how it is actually going to be happening there. So everything that you see, every dot, like, these dots I'm mentioning. So every dots. So what all these dots are doing, so all of these dots are going to be acting as the event. If I want to go and find the relative ordering of the events, I may be making use of the Lamport logical clock. In this case, what we are doing, we are finding out the order of all the events, whatever we can see here. So if anybody will be asking you which event happened, like at the M2, for the first event which happened, like that is going to be happening at the timestamp 4. So if you will see in the beginning, we had like, for both of the machine, we had the timestamp which was starting at the counter 0, but still after that, the timestamp got changed. Now let's take one more example so that you can understand this even better. So in this case, I'll be taking 3 machines. Okay. Or I'll just span it later. Okay. Now, what is exactly going to happen? Like all of these machines are starting at a timestamp of 0. Now, like let us say I want to have a local event for your machine M1. So here that local event is actually going to happen. After that, if you will have to update the timestamp, how it will get calculated. So that is going to be, you have to take the current and you will have to do +1, because here we are having a local, we do not have to worry about any other send or receive event. Okay, so here the timestamp is going to become 1. Now after that, let us say I have another event happening here. Okay, now after this, if I'll have like this, there's again a local event. So if I want to see the timestamp for that, so that is going to be taking the current timestamp for this machine and incrementing it by 1. So this is going to become 2 here. Now after this, like, let us say at this particular time only, we are also be like there are also going to be having some other events, like let us say here when we are at timestamp, like, at this point, what exactly happened? We had one local event at machine M3. So here that event is going to happen, and because of that, your timestamp is now going to become 1. Okay. Now after this, like let us say this machine M3, this wants to send an event to your machine M2. This is your send event. So how you are going to be calculating it out? So let us see how we are going to be evaluating the timestamp for this. So that is actually be going like maximum of like your M3, your local timestamp, and you are going to be seeing the M2 timestamp, and on that you are going to do +1. So if you will see what is the timestamp of your machine M3, that is 1 here, right? And if you will see for the machine M2, we haven't had any other timestamp so far. So that is going to be 0. Now what is the maximum out of 1 and 0? That is going to be 1. So 1 plus 1 is going to be 2. So the timestamp which we will have here is going to be 2. So I hope this must be clear to you how the timestamp is updated here. Now after this, like let us say this machine M1 is sending an event here. So this is again a send event here. And I want to calculate what is going to be the timestamp of this particular event. So how it will be calculated? Let me mention it like T dash. This will be T double dash. So this is the calculation for your T dash. Now we will see for T double dash. So that is going to be the maximum since it is coming from M1. So we will be seeing it for M2 and we are going to be seeing the M1. So if you will see what is the maximum timestamp of M1, that is 2 here. And what is the maximum timestamp of M2? That is also 2. Since both values are same, it doesn't matter. So the maximum timestamp which we are going to be getting here is going to be 4. So here, 3. So here we are going to be having a timestamp of 4. So here if you will see both of the values are 2. So out of that, even if we are going to be taking maximum, that is going to be 2. So 2 plus 1 is 3. So that is how you can see the timestamp here is going to be of 3 value. Okay. Now let us say we are having some local event happening here. Let me actually mark it with some other color. These are the local events. Now for this local event, if I want to calculate the timestamp, how I can do? That is going to be taking the previous timestamp. On the top of that, I'm going to be incrementing it by 1. So this is going to become 4. Previously it was 3. So 3 plus 1 is 4. Now let us say that this machine M2 is sending an event to your machine M1. So now we are going to be seeing that what is going to be the timestamp of this particular event. So how it is going to be there? T triple dash. So that is going to be taking the timestamp of your machine M1 and timestamp of your machine M2. So here if you will see when we are sending it from the machine M2, the timestamp is 4. And if you will see the timestamp for M2 is 2. Correct? After that, we do not have any other value, right? So we have 2 and we have a value 4. And what is the maximum out of 2 and 4? That is going to be 4. So the overall we are getting 4 plus 1, that is 5. So if you will see here for this timestamp, the value is going to be 5. So even though the previous timestamp was at 2, like the previous event which happened here was at the timestamp 2, but now the another one is happening at timestamp 5. So you can see with the help of this Lamport how you are actually able to understand in which order these events are happening. Let us consider one more scenario, like let us say Now some local event is happening here. So when we'll have a local event, what we will do, we will take the previous one and add +1 there. So now this will become timestamp of 6. Let us say that now what is happening? Your machine M1 is sending a send event to your machine M3. And now we have to calculate the timestamp here. So how you are going to be evaluating it? So that is going to be maximum of, you will take the timestamp of your machine M1 and for your machine M3. So now what is the maximum timestamp of your machine M1? That is 6. And for your M3, what is the maximum so far? That is 1. After 1, we haven't had any events happening at your machine M3. Now what is the maximum out of 6 and 1? That is going to be 6. So 6 plus 1 is going to be 7. So here you are going to be getting a timestamp of 7. And even if, like, let us say we are going to be putting some of the event names which I haven't had here, but even if you want, you can easily be able to understand how these events are happening, right? You have seen in all of these cases, if I will have to see how we are getting the timestamp, like when this event is receiving here. So like, at the timestamp 6, we are sending event. If you will see the timestamp 6, we are receiving an event. Similarly, at timestamp 1, we are sending an event. At timestamp 2, we are receiving event. At timestamp 2, we were sending. At timestamp 3, we are receiving. At timestamp 4, we are sending. At timestamp 5, we are receiving. So that is how it is happening. So here what I have actually done, I have given a number to all of these events which are happening here. Correct? And how I have done? With the help of logical clocks. Then here what we are actually using, your Lamport logical clock. Now using this, I'm pretty sure that here, like, it will be very easy for us to see that which happened before what. And this is what is the basic principle of your Lamport logical clock, where we are actually going to be knowing that which event happened when. So here, if you will see at any moment, if we are having, like, any of the event, so you can actually see how you are going to be ordering them out. And based upon this, you will have the understanding that in future, if we are making use of the distributed machine, so how you are going to be ordering your events there. All right. So I hope this must be clear to each one of you. So using Lamport logical clock, we can actually establish a happens before relationship between the events. And how? With the help of their timestamps. So if you will be seeing, like, even if I talk about, like, let us say this one, so you can see before this, which event has happened, this one. So it is actually going to be very much clear to you. All right. Now we are going to be discussing what are the problems which we face with the Lamport logical clock. Now, when you talk about Lamport logical clock, so they can identify the casual order of events as long as the timestamps are different. But when you talk about two events which are happening concurrently, and let us say they don't even have any relationship between them. In that particular case, like, I'll be just taking example, like, let us say we are having two machines, M1 and M2. Okay. Now let us say they both want to send message to each other, and at the same time they both are also, like, let us say timestamp 0, and they both are actually aligning to the Lamport logical clock. So it is actually, like, if we are not using that, it will be difficult to determine which event has happened first. But, like, let us say we are having a chatting application as of now. So what will happen? It can happen that machine M2 is sending a message, then receiving. And at the time of receiving, it can still be sending. So you will be getting to know in which order these events are happening. And but there is one more issue which we face when you talk about the Lamport logical clock, and that is like if if you talk about this particular case, if at this point, um, yeah, so if you will see, let me just draw it properly. So let us say that here at T1 you have received an event. Let us say at the same time I am also having another local event. All right, or at the same time I am sending it back. So if you are having two machines and if they are sending a message to each other at the same time, basically before that what was happening, we were sending it after a timestamp, like we were having a timestamp difference of 1, correct? But here if you will see, if you are going to be sending it at the same time, then it will be difficult for us to determine that which event has happened first. So that is the problem which we have with the Lamport. So if two machines are sending messages at the same time, then it gets difficult to determine which event happened first. Now the solution for this is your vector clocks. Now we will be seeing how these vector clocks are helping us. So, when you talk about vector clocks, so vector clocks are an extension to your Lamport logical clock, and these can help us in solving the issue of concurrency. So, when two or more events are going to be having the same timestamp, in that case, your Lamport logical clock is not at all going to be working. In such a situation, your vector clocks are going to be helping us. So they are going to be maintaining a vector of timestamps, one for each of the process in the system. And this will also allow when we are going to be when on a above level, if we want to get the ordering, your Lamport logical clock is a great solution for that. But if you want even at more finer level, in that case, your vector clocks are going to be helping us in a better way. So each machine in a distributed system is going to be maintaining a vector clock. Here what we are exactly going to be using, this vector is something which we also use in Java. So quite similar to that. So here what we are going to do, we are going to be maintaining an array of logical clock. So each of your process is going to be keeping a track of the state of all the processes in that system. So here firstly, firstly what we are going to do, we are going to be performing the initialization. So each machine in the system is going to be maintaining a vector clock of size, which is going to be equal to the total number of machines in the system. So let us say we are having three machines here, M1, M2, M3. Like I said, we are going to be having a array of, we are going to be having an array, and that is going to be equal to the total number of machines. So how many machines we have here? 3. So here we are going to be maintaining an array of size 3. This is how it is going to be there. So initially I have kept value 0. So initially everything is whenever you are going to perform this, so initially everything it is going to be 0 only, because the initial timestamp is 0. Now the second, after initializing, let us say Now we are having some local event. So example, your M1 is having some local event. All right. After this, what exactly is going to happen? If you will see, we have this vector here. So what it is going to do, since it is a local event, so for that only it is going to increment the value by 1. So what it will do, it will increment its own position in the vector clock and it will leave rest of the values unchanged. All right. Now let's consider how send events are going to be working here. Now, if one machine wants to send a message, what it will do, like, let us say your M1 wants to send a message to the, let us say M2. Here, if we are having send event. So what it will be doing, it is going to be like, here what it will be doing, it is going to be incrementing its own vector clock and it will attach that one with the message. Since your M1 is sending a message to M2, so what it will be doing, your M1 is going to be incrementing this value by 1. We are not going to be touching the remaining values. We are only updating it because M1 is sending a message to M2. Okay. Now, when it is about receiving the values, so what will happen when your M2 is going to be receiving a message, it is going to be comparing the received vector clock with its own. And it is going to update it by taking the element wise maximum of the received vector and its own. And it is also going to be updating that out. So here, if I'll have to rephrase it better. So here, what is exactly happening? M2 is receiving it from M1. That is how it is happening, right? So if you will see how the M2's clock before receiving, it is all 0, 0, 0. And if you will see how the machine M1's vector clock was there in the message. So that was, if we had some message, so that actually had this timestamp. We have updated it after sending. Before that, this was the timestamp which was there in the message. Now what M2 is going to do, M2 is going to update its vector clock by taking the maximum element wise. So here what we are going to be doing, we are going to see, is this greater or is this greater? Of course that is greater, so we are going to update it by 1. Remaining values we are going to leave as it is. Also, if you will see here, M2 has received an event. So if M2 is receiving an event, so this value is also going to update. So now this one is 2, 0, 0 and this one is 1, 1, 0. So that is how it is there. Now we are going to be talking about the concurrent events as well. So if we are having two events and if they are having concurrently, means no event is casually affecting the other, but they are happening at the same time. So in that case, it will be difficult to compare the vector clocks because there will nothing be like less than or greater than. It means that both of the events are going to be having the same or different timestamps at the different positions in their vector clock. All right. Let's take some example, like one more example I'll be taking so that you can understand vector clocks better. So let's take another 3 machines and initially all the values are 0. Okay. Now what will happen? Like, initial setup, everything is going to be 0, 0, 0 only. Now let us say your M1 is performing a local event. Now we are going to be talking about the first event. Okay. And I will also be put it something like even. So like let us say firstly we are having a local event even and that is happening on your machine M1. So what will happen, initially the value was 0, 0. Now after the local event, value is going to become 1, 0, 0. Okay. Now let's talk about another event E2 and this is, let us say, happening on your machine M2. So what is the initial value which we had for your machine M2? That was 0, 0, 0. After local event, what it will be doing for its own machine, it is going to increment the value by 1, and it will keep remaining values as it is. Now let us say your event E3 is happening. So what is going to happen in the E3? Like, let us say your machine 1 wants to send an event to M2. So in this one, what is exactly going to happen? So here presently the M1 is 1, 0, 0, right? When it is going to be sending it, what will happen? M1 is performing a send event. So for that, M1 is going to be incrementing its value by 1. So it will become 2, 0, 0. So when we are going to be sending a message with timestamp 2, 0, 0. Okay. Now what will happen? Next event is going to be the receive event. So your M2 is receiving a message from M2. So when it is going to be receiving the value, what will happen? Now we will be seeing what is the M2's clock before receiving the message. So that is 0, 1, 0. All right. Now what will happen? Your M1 clock is also there in the message. So what is the M1's clock? That is 200. This is the one, right? So now M2's clock, after receiving the message, what it will do, it is going to be taking maximum of these two. So what is the maximum between 0 and 2? That is 2. What is the maximum between 1 and 0? 1. And third machine is anyway not yet initialized. So this is how your event 4 is going to be there. Now let us say in your event 5, what we are doing, we are having a local event on your machine M3. So in that case, like previously, the value for M3 was 0, 0, 0. After local event, it is going to become 0, 0 and 1. Now let us say we have another event, E6. So now your M1 is going to be sending a message to M3. So when it is going to be sending, what is your M1's clock right now? It is 200. Right? M1 wants to send a message. So M1, when it will be sending message, it will be incrementing its clock. So this will become 300. When we are going to be sending a message, it is going to be including a timestamp with it. So the timestamp is going to be 300. So this timestamp is going to go along with the message. Now we are going to have another event. Let us say your event 7. What is that? Your now machine M3 is receiving a message from M1. So in this case, what is the state your M3 was having initially? So before it was 0, 0, 1. Now what is the timestamp which we had in the message? So that is 300. Now what the clock M3 is going to have after receiving, so that is going to become maximum of these two. So it will be 30 and 1. So that is how it is going to get updated. So these are going to be the final clocks. So now you understood that if we will have to order the vector clocks, how you are going to be doing it. So these vector clocks are going to be helping you out in determining the casual order of the events. So Now it must be clear to you, like, how we are going to be ordering our events. And I'll also take one small example so that it will be clear to you which event happened first, like, how you can compare both of the events. So here, if you talk about the event E3, so in this particular scenario, if you are going to see how actually happened at your machine 1. So initially it was 110. After that it became 200. So it must be clear to you how the event is happening here, right? Now, like I'm actually talking about the event E3 and E5 here. So the second event is when we are having a local event. So in this one, your M3 had these values and after that it had 001. So in this case, if I will have to determine which event happened first, so what is going to be there? So if you will see, like, for your event 3, we had a timestamp of 200. And for the event 5, we have a timestamp of 001. Now we need to determine which event has happened first. So if you are going to see, this value is greater than 001 in the first two elements. Why? Because when we are comparing these two. So this is greater if we are comparing these two. Like nothing is greater, but we can still say this one is greater. But if you talk about the last one where we have 0 and 1, in that case, we can see that 1 is greater, right? So we can say that event E3 happened before E5. Why? Because in this case, we are already having the updated values. So if you talk about how this has happened, so this event 3 has happened before E5. So we are having this happened before relationship. Because in this case, like, if you talk about the majority, so in this one, the majority is greater. So that is how it is going to be there. Since in the this one, the first two elements are greater. So we can say E3 has happened before E5. So with the help of vector clocks, we can track the order of the events in the distributed system more accurately. So whenever we have a problem where we have events with the same timestamp, in that case, it is going to be helpful. Like let us say we have a timestamp of, like, one event is having this timestamp, the another one is having this timestamp. And if somebody is going to asking us which happened before, so what we will do, since this one is common between both and this one also is common between both, but in this one we have a clear difference, right? So we can say that if we'll exclude these two, if we are only going to be seeing, so we can say if this is your E1, this is your E2, so we can say event 1 happened before E2, right? So whenever we are going to be having events with the same timestamp, this is exactly going to be helpful for us in the distributed time. Now I'll be just taking one example in the distributed time so that it will be easier for you to understand what kind of problems it can create when we talk about time in the distributed system. So like, on one of the website, they had a sale time. Okay. At that particular time, like, we have something like Flipkart Big Billion Day. Similar we have on Amazon as well. So let us say that some website is having a major sales event. So generally, like, if you talk about a regular day, so generally it is going to be having something like 20 to 30 orders per second. So this is the regular day offer. But if you talk about some of the sale time, this number is going to rocket. So instead of 20 to 30, now we are going to be having something like 20,000 to 30,000 orders per second. If we are having this huge difference, if you will see, this is a huge increase from 20 to 20,000, 1,000 times more than the usual order volume. So in that case, what exactly happens? They are going to be preparing their applications so that they can work significantly in the company's sale time, because this week is extremely important for any of the organization. Like I'm specifically talking about the sale time when they are going to be shooting a lot of great discounts throughout. So they know that when we are going to be having this sale, they are going to be expecting a huge number of orders. So at that particular time, it is going to be a challenging period even for the developers of that company. So For the security reasons only, I'm not naming this company. I'm going to be naming it as ABC. And I had a friend XYZ working for this company. So what exactly happened? Like this guy was actually working in the checkout team for this company. So what happened? Like, before the sale, they actually, like, if you guys remember when we were talking about the Amazon checkout service, I told you before the checkout, one thing which they have to check is the availability. So if a product is going to be available, then only we will go ahead and proceed with the checkout. So this friend of mine, he was responsible for managing this process. So in the preparation for this critical week, developers actually stopped the development for some time period. Like if the sale is happening in November, they are going to be stopping their development from July to November. They only focus upon testing and they focus upon how they can optimize their application so that when there will be a huge increase in the order, when the orders are going to be at a large scale, when they will have a massive increase in the order. So in that case, the application should perform fine. So during this sales event, they actually flashed a sale. So there was a TV. So instead of like, it actually initially had a price of 1,20,000. So what happened in the sale time, they actually wanted to put a sale where they are going to be selling it for 60K. But instead what they did, because of some extreme sale offer going on, they were selling it at 12K. So basically, this was a marketing gimmick. So it was something like they only had some 5 pieces in their inventory. They were not having more than 5. And if you will see, like, since every second we are having a lot of orders, so these 5 pieces are going to get sold within fraction of second. So when the sale started at 12 in the night, what happened? Although we only had 5 pieces in the inventory, but in 1.5 seconds, there were 120 orders for that TV. And this issue happened only because of the distributed time. And why it all happened? Due to the synchronization problem in their system. So what exactly happened? They had basically 3 services: your inventory, checkout, and reservation. And these all services are actually located in the different geographical location. And unfortunately, the clocks and all these servers were not synchronized. So initially, when TV was sold, the inventory service should have reduced the count by 1. However, due to 1 second delay in the reservation service, which clocked by because of the clock mismatch, the inventory service count, like the inventory service could not update the count right away. So as a result, while the inventory still showed 5 TVs, the checkout service still continued to sell them. This timing issue led to the accidental sale of 120 TVs instead of just 5. So this incident highlights how crucial synchronization is going to be there in the distributed system, and this also shows what is the importance of managing time effectively. If you will see, 1 second is nothing, like, you don't even realize the value of 1 second. But because of that, although they were planning to sell only 5 TV, like in the sale also they mentioned clearly we are only going to be selling 5 TVs. But you can say because of a delay of 1 second, instead of 5 TVs, they sold out 120 TVs. So that is how the synchronization issue is actually going to be there. So I hope you must be very clear about how crucial your time is going to be there in the distributed system. And that's all we had for the time in the system design. Now in the next module, we are going to be talking about scalability. So till then, happy learning. Bye bye. Hello everyone. So in this module, we are going to be talking about database. So we are going to be even talking about what is the significance of having this databases in the distributed world. So like, when we look back the history, it is remarkable to consider that 90% of the data, like, from the beginning. All right. So if we will be seeing that, if you talk about the time period from the human civilization, so 90% of the data in the existence today is something which has been generated over, like, if initially it was just 10%, so this remaining 90%, so this has been generated in the last couple of years only. So previously we were not having a lot of data, but you can see in today's world, this data is growing at an exponential rate. And that is also because of the technological advancements. So because of this rise in the internet and this increase in the digitalization of your everyday life, so this data is increasing massively. Now we have massive amount of data. And if you remember, like, in the beginning also we discussed, whenever you are going to be talking about data, you're going to be concerned about two things. So the first one is going to be the storage. The second one is going to be compute. So these are the primary challenges we started facing with the data. So when you talk about storage, so as the volume started growing, we needed more efficient ways to store it. And if you talk about the distributed system, in that case, it is something like, it should, like, whenever you talk about the distributed system, so we also have to ensure that it is easily accessible and manageable. I'll take one example, Google Photos. So you are having that application in your phone, correct? Now, if you will see on the back side, you do not actually know that how the data has been stored. It can also happen that, like, you will be having some 15 GB free storage. It can also happen that your 100 MB is there on one machine. Your 2 GB is there on your machine number 2. Your 10 GB is there on machine number 3. Again, 100 MB is there on your machine number 4, and so on. So if you will see, your entire data is actually available at different machines, but when you are going to look at it, you are only going to be seeing your data. So how you want it as for your data as a user perspective, you want something which is easily accessible and manageable. But if what if Google Photos would have told that I am having 4 machines here, M1, M2, M3, M4. And what if Google Photos would have said that you go ahead and locate your data in all of those machines? Would it be something which you are going to be preferring? Answer is no. As a user, you want something which is easy to access, easy to manage. All right. So it must be clear to you like how you are going to be performing storage. Like we have massive amount of data and we want to store it in such a way that it is easy to access and manage. Now, the another one is compute. So when you talk about compute, so when we are having more data, at that time, we even had the need of greater computational power to process that data, to analyze that data in the real time. So how it is exactly going to be there? So like, let us say I am having some photos in my Google Photos, which are spreaded over a timestamp. Okay. So I'll be having, let us say, some pictures from 2020, some pictures from 21, some pictures from 22, some pictures from 23, something like that. Okay. Now, what I want when I am scrolling, let us say I just scroll to the 2021 and here I want to see all the pictures which I have taken in that time frame. So what exactly is happening at the back end? So they are performing some computation so that they can only show you the photos which you have clicked and backed up in 2021. So what is exactly here happening here? We are performing some computation. And after computing, it is showing you the results. So these are the basically two challenges which we face when we are going to be having huge data, like how you are going to be storing that huge amount of data and how you are going to be performing computation on the top of that. Okay, because like when you are going to be having a lot of data, you are going to be concerned about all of these things, and with these issues you are actually getting some database. So this database is acting as the solution which is going to be providing you the storage, and it is also going to be providing you the computational engine. How computational engine? You can go ahead and write the queries and it is going to be providing you the results based upon the requirement. So that is how it is going to be working. Now, when you talk about your data, this data is extremely huge, correct? So having data is crucial, but it is also equally important that what is going to be the role of database in managing and utilizing the data. So we are also going to be seeing that how database is relevant in your today's world. So when you talk about data in the today's world, you are actually dealing with the big data. You are having vast amount of information which cannot actually be stored on a single machine. And in order to handle such massive volume of data, we rely on something which we call as distributed system. So when we talk about such a scenario, in this case, your database is essential because they not just helping us in storing our data, but they are also helping in managing our data, so that whenever we want to access it, it is going to be easily accessible and we can even manage it according to the information. So what basically your database is doing, so your database is collecting the information, it is capturing the information, and later on what it is doing, it is storing it. And what is going to be the major purpose about storing all of that data? If tomorrow if we want to use it, just I took the example of Google Photos. So if you are uploading some pictures there, what is the reason of backing up your photos there? So that if you want them tomorrow, you will still have the option of using it later. So major purpose which database is serving us is providing us the option of using it later. So capturing and storing information for future is not something which we are doing only today. So this is something which we have been doing since the starting of human civilization. So even before computers, even before we had the education, even before people could read and write, humans still had the option. They still found out some ways so that they can store the information and they can share it with others. So previously, when we were not having digital system, so memory actually played a crucial role. People relied on oral traditions to pass the knowledge down from one generation to another generation. In those scenarios, elders were actually sharing the information, like whatever they knew, they were sharing it with the younger member of the family so that they can ensure that the information is preserved and it can be recalled later. So this was the earliest method of data storage. They were storing it, they were capturing it in the human mind so that they can use it later. Now, when the civilization progressed, humans started using physical objects to store the information. In the ancient times, people were using stones and they were carving some inscription on them. Even if you talk about today, so today also archaeologists are studying those inscriptions so that they can learn about the ancient civilization. They are deciphering the languages and they are trying to understand what historical context they have recorded on those stones. So back then, when they came up with the advent of writing, when people started thinking that we can also write down and preserve the information through that. So what people did, people started using papyrus. They started using clay tablets. They even started using paper as a medium of storing the knowledge. So paper became the dominant tool for recording and reading information, and which can be something which can be preserved for centuries. And a large collection of documents were stored in the files and archives. This practice of storing and retrieving information did not appear only in the modern era. Previously also it was there. It has always been a part of the human history, but in the different forms. So however, as technology is advancing, computers introduced a whole new world of digital storage, which is making it easier and more efficient and more reliable to store the large amount of data. In the earlier times, paper storage also had its limitation. Paper could be damaged over the period of time, it could tear off, ink could fade, it could be eaten by the insects. Also, previously when you were writing down something on a piece of paper, Then if you want to modify some information, if you want to update some information, so that was also a difficult process. You have to physically rewrite or correct the mistakes. And organizing such large volume of data was also messy. It was not that easy. With the rise of the digital storage, these issues were also largely solved when we came up with the computers, which actually enabled the electronic storage of data, and that also reduced the risk of degradation. This helped us for the easy updates. Like if you are writing something on some text editor, it's easy for you to edit the information. So they also allow us for easy updates, edits, and retrieval of information. Initially, people started using floppy disks, and when they were using it, this was the one of the first digital storage medium. Although if you talk about the floppy disk, the capacity was limited as compared to the modern standards. The when you talk about the floppy disk, so they were hardly storing some of the MBs there. But if you talk about today, even TVs are sometimes looking lesser because of the huge amount of data which we are having today. So when you talk about the late 1950s, at that particular time, we started making use of something which we call as file-based storage system. And as the name is starting, so here what we were doing, we were storing all our informations in the files, and those were stored on the magnetic tapes. And as the name is there, file based, so if you will talk about how previously you were storing all that information, so you were having certain folders. Inside that you were keeping individual documents so that you can bundle them up together. Now, if you will see with the advancements in the modern era, now you have some digital folders, and inside that you can go ahead and store your information like one.txt, two.doc, or anything that is how you can go ahead and store your information. And the reason why it got this name file based storage system, that is because they took the inspiration from how people before computers, how people are storing information. So when they thought of doing it in the digital era, they thought of using the same idea there, so they copied the same idea there. And the first prototype of digital storage was based on the file based storage system only. They have actually took the inspiration from the real world only. Like if you talk about this file, how you can actually locate it, let us say in the users, we have a user named Anjali. Inside that I have a folder docs. Inside that I have a folder named one.txt. So that is how I can go ahead and provide a path. So here it must be similar, it must be clear to you what we are doing. We are following a hierarchy structure. And that is one of the easiest way of representing how you can go ahead and store your data. So, initially when file-based storage systems were introduced, these were the big deals because before this, this was actually introduced in 1990s. So, when it was introduced, it was a big deal because before this, people only knew if they want to store some of the information, how they can do it. They can store it on some paper. But when they started storing the information on the data, so that way they felt it is incredible. They were feeling that now no more losing paper or forgetting things. Now everything can be saved digitally. It was if you talk about a huge improvement, like previously if you talk about the example of kids, so when we are a kid we will use pencil to write down something. When we write with a pencil, it is little slow and it's little messy. On the other side, when you talk about pen, so with the pen it is more fast and it is more permanent. So as a kid also, it is a great advancement to switch from pencil to pen. Similarly, here also it was a huge improvement and people were extremely excited to use it. In the early days, computers were mostly used for the things like performing some mathematical operations, some statistical operations, some scientific problems. And for all of these things, your file based storage system worked well. But this IT sector, this doesn't spare anyone. It affects everyone. So as the technology grew, we started using computers for almost everything. So at first, everything worked fine. But over the period of time, people started to facing some of the issues. And it was like, when we meet anyone new, we do not notice their flaws right away. But as we get to know them, even like, their weaknesses become clearer to us. So similar thing happened even with the software. So when file-based storage system was first introduced in the programming, people were excited about it. But as they got used to it, they started noticing the limitations. As the technology grew, like they started seeing that what and all are the limitations for the file-based storage system. So the first limitation which they observed that it is hard for non-programmers. So file-based storage system is going to work great for those people who knew how to code, but it wasn't easy for the regular people to use. If they want to store something, if they want to search something, if they want to organize something. So all of those things were requiring some programming skills. So it was not easy for non-programmers to use. The second one was data duplication, or you can say data redundancy. So like, let's talk about some file, text file. So there, even if you are going to be writing like, some word repeatedly, there is not going to be any way to check if that data is already stored or not. So like, let us say here you are maintaining a list of all the students. So even if you are going to duplicate a student name, there is going to be no way to figure out if that name has been already stored or not. So because of that, people will have this duplicate entries. So this, because like, some information is going to be stored at different places. So this is what we call as redundancy as well. Now with this, with the data duplication, we started facing the issues. So the first one was deleting data. So deleting data was difficult. How? Since it is available at more than one place. So if you want to delete something, you can only, like, let us say a student name is actually available at 5 places. You was successfully able to leave 4, one accidentally left. And that is something which is going to be there, right? Because you're not managing it out with the help of any other advancement. It is just a plain text file. So deleting a data is going to be difficult. The second one is inconsistent data. Now, what does it mean? So like, let us say you have that student name at 5 places. If you want to change the name of that person, let us say at 4 places you were able to do. But keeping it updated at all the places is going to be difficult. Even if you're accidentally missing one, you're not going to be maintaining consistency in your data. So these are the issues which you have. So basically with the redundancy, you have 3 kinds of issues. So the first one is going to be delete. The second one is going to be update. And the last one is going to be related to insert. And the issues which we face because of delete is actually called as deletion anomaly. The one which is related to update is called as update anomaly. And the one which is related to insert is going to be insert anomaly. So what exactly happened in the file-based storage system? If you talk about the deletion, we have already discussed. If you are accidentally skipping some of the entries, so that is going to create the deletion anomaly. If you have to update values and if you are accidentally skipping at one place, so what will happen? At 4 places you will have updated value, at one place you will have old value. So this is something which we call as update anomaly. Now the last one is insertion anomaly. So if you want to add any of the value and if you're not checking if it already exists, you may end up adding a duplicate entry. So that is what we call as insertion anomaly. So these issues occur mainly because of the redundancy only. Also, if you talk about the old times, so back in that time when your file-based storage system was introduced, people didn't even think about the security, because back then, nobody actually thought that something called as hacking can also done. People can rob you online. If you talk about today, this thing is very common here, but back then people thought that security threats are something which can only be physical. Only what can happen if somebody is coming down the street, and if you are wearing a necklace, they can just snatch it and run away from there, or they can just come to your home at the gunpoint, they can steal your valuables. So those were the only robberies which were happening back then. But that idea that somebody can rob you online, some e-frauds, so all of those things were unimaginable at that time. But if you talk about today, e-frauds are something which are happening every day. Every day a new idea is coming up, right? So with the time, as file-based storage systems were widely adopted, it became clear that these systems have weak security. In this one, we cannot also be take care of the security. So the security approach back then was simple. So if we have a file, we can lock it at the file level. We can provide a basic username and password. This was the basic layer of security which we can provide there. So when security concern became to grew over the period of time, it became clear for everyone that this model is not going to be sufficient. So these problems ultimately led people to ask that why not we try something new? Why not we develop a better solution? So as a result, they came up with a new solution, and that is something which we call as DBMS. So this DBMS is the solution which came to solve all the issues which your file-based storage system had. And here your DBMS stands for your database management system. Now, when you talk about DBMS, so what it did, it solved the problem of redundancy, it solved the problem of security, and it also solved the problem of usability. Now, let's talk about Oracle and MySQL. So are they even database? So technical speaking, they are not just database, but they are actually database management system. However, if you talk about everyday language, so I'll give you one example here. So what was the first brand for the photocopy machine? So that was Xerox. So that brand became so famous that even today people go and say that we want to get a Xerox done. Similarly, if you talk about a detergent powder, so one of the first widely used detergent powder was Surf, and that became so popular that Surf is now often used as a synonym for your detergent powder. So similar way, when you talk about Oracle or the MySQL, so these are these actually became so common that people calling them as databases. But what these are? So these are the DBMS. So I'll just tell you about what a DBMS is and how it is different from database. Also, we are going to be seeing that when I'm saying it overcame the problems which we had with the file-based storage system. So we will also see how it overcame all those problems. So if you have ever used MySQL or Oracle, you will know that how it is actually going to be there. So firstly, you will download a software, you will run the executable, and after that you will have it installed in your machine. Now, when you talk about this database, so here you are actually having DBMS. So here you are having two parts. So the first part, which we go ahead and call as database, and the second part, which we call as management system. So it is actually comprising of these two parts. So when you talk about database, so this is the physical layer where you are going to be storing all your data. And when you talk about management system, so this is the software which you are going to be using for performing all of the operations. This is your software layer. Here you are going to be performing all of your operations like data retrieval, organization, security, and anything. So when you talk about database, so we are going to be making use of these two layers. The database where your actual data is going to be stored, and the management system which will help you in interacting with the data. So how you can actually visualize it. So this is how you have your database. So this is your database. This is your physical layer. This is where you are actually going to be store your data. Around this, there is going to be another layer. And this layer we generally call as management system. This can actually be like, that place where we are going to be performing all the operations on your data. So that is how basically you should be visualizing how your DBMS is going to be there. So you will be having your database, which is going to be surrounded by the management system. So this DBMS came into the picture to solve all the problems which we had in the file-based storage system. So the main issue which we had there was the redundancy. So there in the file-based storage system, people could not keep a track of that. Correct? So that was something which was there. In order to solve this, DBMS designers came up with a system which is this, where we are having a database at the middle and the management system surrounding it. You can, if you want to visualize it in the real life, you can visualize it something like this is the PM of the country, and he cannot be just standing alone. There are going to be a lot of people who is going to be safeguarding him. So there are going to be several bureaucrats, there are going to be other high level officers. So that is how it is going to be there, and everyone is going to be playing some of the role there. So this is how you can be linking both of these two things together. Okay. So now what is exactly going to happen? Since we are saying that this prime minister is surrounded by a lot of top officers. So what these officers are actually going to do? So do you actually think this prime minister is actually going to be coming up with all these schemes and all the budgets on his own? No, it's the bureaucrats. It's the mind of all these people who are surrounding him who is going to be bringing all the ideas to the table. So similarly, when you talk about DBMS, so whenever you will have to add any data, whenever you will have to manage any data, so this management system is going to be playing the main role. So this one is going to be seeing that, this management system is actually going to be taking care whenever you are going to be adding some data, whenever you are going to be updating some data, whenever you are going to be deleting some data. This is something which is going to be taking care of the problem which we have with the redundancy. So that is how it is going to be there. So in the earlier file-based storage system, only programmers could interact with the database. I can actually say back then it was only possible for the programmers to go ahead and store the data. But if you talk about the today's world, or if you want to just continue this analogy of this prime minister only. So what will happen, let us say this prime minister, he only knows two languages, English and Hindi. But he is the prime minister of the country. It's not like we will expect him to understand everything, but it is not feasible that everyone can, all the peoples all across the India or all across the world are coming up and meeting to him and they want to have the conversation. So they cannot go ahead and do the conversations directly because of the language barrier. So in that case, what we can have, we are going to be having some mediator in middle. So what will happen? Regular people are going to come to this mediator, and this mediator is going to make the information reach there. So similarly, when you talk about the same in the world of DBMS only, this management system is going to be acting as the mediator between the user and the database. So this will ensure that doesn't matter how the user's technical skills are or how you are writing the format of the system, we are still going to be processing it out, and in order to provide the support for that, like, you do not actually be needing to know all the complex programming languages like the Java, C Sharp, C++. Instead, they came up with a language which is SQL. The SQL stands for your structured query language. Now, when they came up with this was simple to learn and it was simple to use. It was not at all complex. So you do not need to know any complex programming language if you want to communicate to the database. This SQL is designed to be English-like language so that it will be easier for anyone to understand and to use. So even if they do not have a background in the programming, they can still go ahead and use SQL. And since I am saying that SQL is easy to understand and it is very much similar to English, so we can say that with this help, with the help of with the help of SQL, we also resolved the issue of complexity. Now it became easy for anyone to use it. So people started, like, after understanding how the use case is going to be there for the DBMS, so they started transitioning from file-based storage system to database. So this shift was a significant change. But as we progressed to the year 2000, there were something which we call as internet. With the rise of the internet, people started moving their online real world activities to the online world. Like, if they want to, like, previously, if you will ask someone that, okay, can you go ahead and buy a mobile phone online? That is something which nobody will understand, right? Or if you will say, like, can we go ahead and buy a TV online? No, previously we were going to the stores, we were looking at the item, we were placing some advance amount, and that is how we were buying it. But thanks to the internet, buying things online is now a normal part of the day. No matter what the cost is there, we can go ahead and place the order online. So when we talk about solving real world problems in the world of software development, we need to know how we can represent the entities and the relationship in the world of programming. And in order to do that, the object-oriented programming came into the picture. So in the software development, when we work with the data, we need a way to show how different pieces of data are going to be related to each other. We need to know how the relationship is going to be there. So although your DBMS was helping to manage the data, but they also had one of the issue. That is, when you talk about DBMS, so they cannot represent a relationship between the data at the storage level. And in order to solve that problem, we came up with something which we call as RDBMS. So what is that? That is your relational database management system. So here, if you will see, just R, this R stands for your relational. So this came to solve the problems, like what the core problem we had, that we are not able to represent the relations here. So this allowed database to not just store the data, but also to represent relationship between the different pieces of the data, that too in a structured way. So when we moved from DBMS to RDBMS, we got more powerful tools for managing our data. And with the help of that, we can store the relational data also in our system. So the popular examples of your RDBMS are Oracle, MySQL. So with the help of this, we can store our data in the form of tables. So, like, before the RDBMS, data was actually stored in less organized and isolated way. And that is why it was difficult for us to manage complex relationship between different pieces of the data, between pieces of data which is available to us. As your system grew, as your businesses grew, it became clear that we needed a better way to store and manage data which can reflect the real world relationships between the entities. And that is where your RDBMS came into the picture. It helped everyone to organize the data in the form of tables. So here we are storing our data in the form of tables, and we are also establishing some relationships between them. So here, what exactly we are going to be doing? We are going, like, when you talk about building a relationship between the tables, so how do we do it? So we are able to do it with the help of foreign key. So what is the meaning of that? So if you are having some table, so like some table 1 and here we are having a table 2. Let us say here we have some ID TID and here we have something like EID. This TID is your primary key for this table. But if we want to link both of these tables together, what we will do, we are going to be using this TID here as well. And when this TID is going to be used here, what is that? This is something which is not local to this table, right? This is something which is foreign for this table. So that is why we go ahead and call this as foreign key. So this one is here primary key, but when it will come to the different table, it will become a foreign key. And with the help of foreign keys, it will be easier for us to represent a relationship. This foreign key is going to be helping us to establish a relationship between the two tables. All right. So when your DBMS was introduced, it actually solved a lot of challenges. So the challenge number 1 was to provide a structured storage of data. We are doing it in the form of tables here. Also, it provided us a way to model the relationship. How we are having some entities like person and car and how we can build a relationship between them. So all of that, like to build a relationship. So that was solved by RDBMS. And here we are also ensuring data integrity. And that is possible with the help of foreign keys. So with the help of foreign key, it is going to be easier for us to represent a data integrity and to represent a relationship between the two tables. Now, when you talk about RDBMS, so one more thing which you will have to keep it in your mind that you can use RDBMS only when you will have a fixed schema. What is the meaning of fixed schema? It means if you have fixed number of rows and columns. If that is fixed, in that case, we can say it is a fixed schema. And that is where you can say that data RDBMS is going to be a good choice. So if you will have such form of data, then only you should go ahead and use the RDBMS. Now I'll take one example here. Let's take the example of your bank storage. So let us say that we are talking about a bank, ICICI. All right. Now here we have a user A. Now when this user A is going to be opening his account, so we are going to be asking him for certain information like your name, DOB, your Aadhaar number, your address, something like this. Now these details are something which any user, like, not just this user, whenever any customer is coming, so that customer needs to provide this information. And if this information is available to us, then only we can open their account. So here we have fixed attributes, that too of the fixed type. Like if we talk about name, so it is always be of string type. Date of birth is always be having some integers. The Aadhaar number will always have integers. This address is going to be having some string. So these are the basic information. So here we can actually go ahead and have a fixed schema. So for this situation, we can go ahead and use RDBMS, right? But let's take example of some e-commerce website. Some e-commerce website wants to have the product. Now, what will happen? Like, let us say we have two categories of a product. The first one is groceries. The second one is some cosmetics. So when you talk about groceries, we will have some different set of attributes. Here we will be having some expiry date. Here we are also going to be having something like ingredients. Here we are also going to be having something like brand. We are also going to be having something like shelf life. But if you talk about cosmetics, here the attributes are going to be different. Let us say here we are having some attributes like name. Here we are having something like color. Or if you just want to change it entirely, let us say we are talking about electronics. So for the electronics, we are going to be having something like warranty. We will be having something like model number. We are also going to be having something like voltage supply. We are also going to be having something like compatible types. So if you will see, although these both products are going to be listed on the same e-commerce platform, but here for both of these cases, we are having different set of parameters. So we will have variety of products there, and every product is going to be having its different set of attributes. So for such a case, you cannot go ahead and apply RDBMS because it's not going to have a fixed schema. Here we cannot have a fixed schema in this case. Now, when you will have such a situation where you cannot use RDBMS, so that is where your NoSQL is going to be coming into the picture. So NoSQL databases like your MongoDB is something which is going to offer some help here. So when you talk about your NoSQL databases, so these are actually having dynamic schema. So here you will be having the flexibility on how you are going to be having attributes. So here you do not require a fixed schema. You can have different set of attributes in the same database. So that is how your NoSQL database is going to be there. What you do in the MongoDB, you go ahead and store your information in the form of some document. And that document is going to be having any set of attributes. So how you will be doing? You're going to be doing it just how you define a JSON. So if you talk about a mobile phone, so how you can do? You can write it down something like, what is my product type? Let us say that is phone. Then I will ask something like model number. Then you can probably give something like iPhone 16. Then let us say we are asking something like, what is the battery life? So you can go ahead and write something like, I'm not sure, I'm just using some values, 5000 mAh. Similarly, you can go ahead and provide the parameters. So this is how you're going to be storing that information in the form of some document. Similarly, you can go ahead and create it for the grocery item, for the cosmetics, for the for some apparel like clothes, shoes, anything. So if you will see, this is providing you a easiest way of using a NoSQL. Now, with even though if you talk about NoSQL databases, so even though they are more flexible when you talk about the dynamic data, but still RDBMS has a strong place where to use it. So if you talk about RDBMS, so even though when MongoDB came into the picture, a lot of people started thinking that now nobody is going to use relational database. But no, RDBMS is still having one most important selling point, and that is the provide for transaction. Now, what is the meaning of providing the transaction support? So here we are going to be performing some series of operation, and those operations should be executed as a single unit. Also, when we are going to be performing transaction, they should also go ahead and adhere to your asset properties. Okay, let me take one example here. Like let us say we have two persons. Now person A wants to send person B some 1,000 rupees. Now what are the steps which are going to happen here? So the first one is the money will get deduct here. Correct? After that we are going to be making use of the wire. Like this is the first step, this is the second. The third one is the money is getting received here. So these are the steps which we are going to be following here. Now let us say this is you only. If you are sending 1,000 rupees, if will it be okay if any of these steps are going to get crashed? What if this step got crashed? Will it be okay for you? Of course no. Like will it be okay if money is getting deducted, it is getting sent somewhere on the wire, and you are not even receiving, like your friend is not at all receiving it? So if you will see any of these steps, if it is failing here, so that is something which you are not going to accept. So what is going to be your requirement in such a case? You will want either all should be executed or none. So that is something which we say that here we have a support for transaction. So either all the steps are going to get executed as a single unit or none will execute it. So here we provide all or nothing. So as long as we are going to be needing the use of transaction support, so till that time we are still going to be making use of RDBMS. And where and all we are going to be making use of this? First one is banking. The second one is order processing system. If you are placing some order, you have to ensure that the orders are completed correctly. So for that you will be needing it. Second one is inventory. I took one of the example in the time like a module. So there I explained because of the inventory thing, just to check the availability. If it is not complying correctly, in that case, it's not at all going to be working correct. So we still need the support of RDBMS there. Now, in order to maintain this ability is going to be using asset property, which will ensure that your data is consistent even when you will have some unexpected issues like your system failures and all. So most of your NoSQL databases do not provide strong transactional support. So now we will see what asset principles are. So here your A stands for atomicity. Your C stands for consistency. Your I stands for isolation. And your D stands for durability. So this is the full form of asset. Now we will quickly see all of them one by one. Now we will be talking about atomicity. So like what atomicity says, it says that all the steps in the transaction that should be treated as one unit. So if any one of the step is failing, so we would want the whole transaction to roll back. If you must have seen when you talk about any banking sector, or if you talk about any order placement or transferring the money through these wallets like phone pay and all, so what exactly happened there? Sometimes you must have seen you will be having facing some of the failed transactions where the money is getting deducted. But if you would have seen after a while that money rolls back, like that transaction rolls back and you get that money back. So that is something where this atomicity comes into the picture. I hope this atomicity must be clear to all of you. The second one which we have here is consistency. So we say that the system must remain in the consistent state before and after the transaction. Now let's take this example. In when you are performing this transaction, we are having other people also in the bank, right? What if they wanted to send the 1,000 rupees and they are deducting money even from these your bank accounts as well? So is that something which you are going to be okay with? At least I'm not going to be okay with. So what I want, so if any transaction is happening, so if these two person are involved in that transaction, so only they should be impacted by that. Remaining ones should remain in the consistent state before and after the transaction. So that is what is the meaning of the word consistency. The next one is isolation. Like I said, I'll just take one example of isolation. Let us say you are outside, you went outside and you have to pay the payment through Google Pay. Let us say it is some eatery or any place, Google Pay you are using. Now there can happen that multiple customers are trying to make the payment for their orders. So multiple transactions can happen, but they should not interfere with each other. They should not result in the conflict. So that is what is the meaning of the isolation. So like I said, if 10 people are making the, it doesn't happen that that guy will say that, okay, you all pay payment one by one. But what happens? Everyone scans and they pay that money. So what exactly happens? Every transaction is happening isolated. That has no dependency of any other thing. So transaction should be independent of each other. And this is only possible because of this isolation. The next one which we have here is durability. So once a transaction is successfully completed, it is permanent, even if it is a system failure. This means committed transactions are preserved. Example, if you are sending a money to someone, it is going to show today the money got deducted. To your friend, it will show money got received. So even if tomorrow there is some issue with the bank, then also what you want that once the issue is fixed, once I'm able to see my login to my internet banking, I should still be able to see that transaction. Nobody would want anyone to undo that transaction. So that is what is the meaning of this durability. So if a system is following ACID principle, it can provide the reliable transaction support. All right. And this is very important when it using the database in the banking, where the payment processing must be secure and accurate. So that is why even though many NoSQL systems are already available, even though they are gaining a lot of popularity, but still RDBMS is still going to be widely used. And their major advantage is reliable transactional support. So that's all we had for the database. Now we are going to be meeting in the next module where we are going to be talking about scalability. Till then, happy learning. Bye-bye. Hello everyone. In this module, we are going to be talking about the most popular word, and that is the scalability. So when you talk about scalability, so this is such a term which people is using in almost all the speeches left and right. So now let's understand that what it is. Is it really cool? Is it really complex? And what it takes to build a scalable application. So all of that we are going to be looking in this module. So when you talk about scalability, so what does it mean? So scalability means whenever we will be having any application, so we will see that initially, for any of the application, initially we are going to be having less users. Eventually, when app is going to gain the popularity, in that case, we are going to be having more users, right? So when you talk about scalability, so what we actually see that, is this application having the ability to handle an increased number of users or transactions? Okay, so that is what we talk about it. Also, when we talk about dealing there, so we also see that for this application, we are also going to be having some of its performance, right? So when we talk about the performance, so what we actually expect, if you are having example, I'll take example of Zomato. So if you talk about Zomato, if today it is working with 100 users, what you expect, you as a user, what you are going to be expecting, that I don't care if tomorrow you're going to be having some 1,000 customers, 1,000 people using your application, but I want my experience to be working in the same state. So that is what is your real requirement, right? So if you talk about Instagram, so initially when Instagram came, not a lot of people were switching to that because Facebook was already having a great boom back then, right? But if you will see, slowly people started moving to it. But if you have been using it from the beginning itself, like I have been using it from the beginning itself, I can clearly see that the performance has not been degraded. The performance has always improved. They have improved the application in the various factors. They have added a lot of features there. But if you will see, the overall experience is still the same. So when we talk about increased number of users and transactions, so what we expect out of it, that performance should not be affected. So we can say that What is your scalability? That is your ability to handle increased number of users or transactions without dropping the performance. Okay, so that is what we mean by scalability. Many people, like, they think that they understand the concept and they use this word left and right. So they use this word scalability without knowing its meaning. Like, I remember when I was a student, so scalability was such a word which I was using everywhere. Like, if you have to talk about any software, okay, we are going to make it scalable. We are going to make it scalable. But to be honest, I never knew the exact meaning of that. Like, if I talk about scalable, how in depth it is going to be working. I only got to know when I was learning the system design. So, like, let us say that you are building any application. Okay. So initially you're going to be having some customers only. Okay. Now in this case, like, let us say you are having a response time. Response time means if you are clicking on some place, like, if that application is having something like profile. So if you are moving to profile, so how much time it is going to take to respond for your request. So that is what we call as response time. So initially, let us say the response time was 5 milliseconds. Now, as the application gained popularity, so what happened after that? We saw that your customers, like, let us say initially we had only 3 customers. Now what happened? After it gained popularity, so customer count became, let us say, 3 million. Okay. And now what happened? We have a bigger question here. Like, you guys can also pause your video and you can also think that after gaining so many customers, is the page going to load in the same time? Is the user experience going to remain unaffected? Is it still going to have a response time of 3 milliseconds, 5 milliseconds? So just like, you guys pause the video and think about it. Now, if your application can maintain the same response time, even if we have increased number of users, so we will say that it is scalable. If after having 3 million users, if the response time is still same, if it is still 5 milliseconds, in that case, we say it is scalable because irrespective of the user count, it is still working in the same manner. So that is when we call that we have a scalable application. In order to improve the performance, it is okay to put more machines. However, the key point is the performance. Your output, your SLA. Your SLA means service level agreement. Your latency of the system. So all of these things should remain consistent. It should not be impacted because of the load. So when you talk about any application, so what are the factors which you should always be considering about its performance, about the output which you are getting out of it, about the SLA, like, your service level agreement. Also, if you talk about the latency of the system, so if your application is not impacted regardless of the load, so in that case, like, if your application is still remaining consistent, so we will go ahead and call this application as a scalable application. So that is what is the meaning of scalable. So any application is going to be scalable if its performance remains stable when the load is increasing or decreasing. So whether they are few users or more users, the application should function smoothly. So if my application is meeting this criteria, I will label it as scalable. Like, I'll give you one small example as well. So, like, there was one series on physics wala that was there on Amazon Mini TV. So if you guys have seen it, like, I'll tell you what actually happened in that case. So that guy created a platform where he was delivering the video lectures. He didn't actually expect that he will gain a lot of users. He will gain a lot of students for his class. So what happened when he was starting his class, at that time his application got crashed. So as a spectator of that series, you guys must have not noticed that what actually impacted there. But the actual thing why that application was not working, that is because he didn't plan his application to take that much of load. When he was designing the application, he considered that maybe he'll get some 50 students, maybe he'll get some 60 students, but he actually ended up getting some 300 students or more than that. I don't remember the exact count, but that is what happened. So in that case, what we can say, his application was not scalable. That is why when the load increased, his application was not able to take that load. I hope it must be clear to all of you. Now we are going to be taking some more examples so that you can understand this concept even more. Okay. So I'll be taking the example of IRCTC. So you all must have used IRCTC application at least once in your lifetime. Or if you have not used, let me tell you what IRCTC is. You use this application if you want to book some train tickets. So when you talk about IRCTC, like, if you guys have already used, so you will have the fair idea about how it works. So if I had to talk about it, yeah, so if I have to talk about my opinion, IRCTC is not scalable application. So if you talk about me, especially if you have to talk about the Tatkal bookings. So what exactly happened, if you know about the Tatkal booking, it is like they will be initially there will be certain seats for that train. After that, some people at the last minute, they will be canceling their tickets and all. So they are going to be opening a Tatkal window where you can go ahead and book those available seats. So generally that happens at 10 a.m. in the morning. So if you guys must have seen, whenever you try to book any Tatkal booking, so in that case, the site slows down and the user is actually experiencing a poor performance there. Also, in such case, you will also see that transactions are frequently failing. So I'll take my own example. So last year, I was booking a train ticket to Vishakhapatnam. So at that time, what happened? Me and one of my friend, we both were booking, and we thought that we were four people traveling there. So we thought that we both will book two tickets each, so that we will get lucky in booking the tickets. What happened for my friend, it actually happened by 1 second only. My friend was able to book two tickets, but when it came my turn, I could see transaction pending. After a while, I could see the booking did not complete, because as long as transaction is not complete, these seats are going to be still available and anybody else can come and book those. So that is what happened with us. So that is something which I can say, that its transactions fail whenever it is going to be experiencing more load. So this clearly indicates that IRCTC struggles to maintain performance when it will be under heavy load. On the other side, if we talk about the other timings, like apart from the Tatkal window, so at that particular time, it is going to operate smoothly. The performance is actually going to suffer significantly at the peak times, which shows that it cannot handle the high demand effectively. So scalability means that application's performance should remain consistent, whether the load is high or low. So in that case, I can go ahead and say IRCTC is not scalable, especially in the Tatkal window. Now I'll take another example. So I'm specifically talking about CBSE and your college websites. So I have done my schooling using CBSE, and when it was the board results timing. So at that particular time, what used to happen, that when we were logging in to the websites, it was showing even when the results are released. So at that particular time, I was not able to see the results. The application the website was not loading. I have also seen some of the cases where people if they have logged into the application in the early times, let us say the result got declared at 10 a.m. in the morning. So those guys who logged in around this time, they were still able to see the results. But if we talk about, let us say 10:05, at that time, the website became slow. And as a result, I can say these websites are not scalable. And same exactly happened even with the college website. So, for my college, like I have done my BTech from Maharishi Dayanand University. So at that particular time, what exactly happened? Our results got announced around 5:30 in the evening. At that time, I was at one of my friend's place and we were having some high-speed internet. So the moment I got to know about the results, I immediately logged in and I was able to see the results. After a while, after 15 minutes, when everybody got to know that results are out, so they all were trying to logging into the website and they were not able to see. Then I got to know from the other fellow friends that they were able to see the results in the midnight. And why they were able to see it around that time? That is because around midnight, a lot of people will actually give up. They will feel that, okay, now let's sleep and we'll see it tomorrow. So at that time, the load decreased on the website, and as a result, they were able to see the results. So it's not about your internet is speed or slow, but it is about how many users are trying to access that portal. So that is how we can say your CBSE website is not scalable. I'll take another example for the scalable application. Okay, so that apart from this, so that you can understand that how you are actually going to be considering the performance there. So okay, let's take some application. Now, one thing is there, even if no matter how much good system design you are going to be using, one thing which you should always be keeping in your mind is no application is 100% scalable. There will always be challenges. So when you talk about scalability, so 100% scalable application is a myth. But one very good example of scalable application is Twitter. If you talk about traffic on Twitter, so what exactly is going to be there? So a lot of people are going to be using it, right? So if you talk about the traffic on Twitter, so that fluctuate dramatically due to the dynamic events. However, despite of these challenges, Twitter generally maintains a load performance. They maintain a stable performance throughout. So they may be only experiencing some slowdowns during the peak loads. So this flexibility in handling varying loads, so that we can go ahead and call that Twitter is a scalable application. Because in extreme peak cases only it is going to slow down. So little bit of slowness is still okay, but if it is more, that is something which is concerning, and we should be considering that in our mind, that if we face some of scalability issues, then how are we going to be addressing them out? Okay, the next one which we are going to be seeing is how can we achieve scalability. So we are going to see that if we have our machine, how can we go ahead and achieve it? So in order to achieve scalability, we have two ways. So the first one is your vertical scaling, and the other one is your horizontal scaling. So these are the two ways in which we can go ahead and achieve scaling. I will be explaining both of these to you so that you can understand that if you face some of the scenarios while working on any of the project, how you are going to be taking any action on the top of that. Or if in the interview, if people are going to give you some scenario and if they will ask you, how can we go ahead and improve our application? So you can tell that, okay, scaling is something which we can apply here. Now we are going to be discussing about vertical scaling. So, I'll be taking one example here so that you can understand it better. So let us consider a scenario in the industry. Let us say we have a machine here. Okay, and let us say that this machine is having a storage of 500 GB. Now, initially, this application had a small number of users, and for that, 500 GB is more than sufficient. So now this is working for you, right? Because less users, good amount of storage, so everything is working fine. Now let us say that you have is let us say that this application is gaining popularity now. Let us say that you have cracked a way to the person's heart. So everybody is loving and liking the application. So what has happened? More and more people have started using the application. So as your application became popular, more users are going to start using it, right? So the amount of data generated is naturally going to increase, correct? So now let us say that out of this 500 GB, you have consumed the 80% of your storage capacity. So based on the current trends and calculation, you will realize that if you are not going to make any changes, your database is going to get full in the next 2 weeks. So clearly you need to find out a solution to increase your storage capacity. So what you will do, you can also take the example of your phone. Okay, if you have your phone, if you will see the storage is getting full and you do not have the option of clearing it off, what we do, we take the backup of the pictures and then we clear off that storage so that your phone can have more storage. What you will do, or your laptop is running out of storage, so what you will do in the real life, what you are going to be doing for your laptop, you are going to put external hard disk, you are going to be putting some external storage there so that you can divide the data, correct? So that is what you are going to be doing in such a situation. Now if you talk about this application, so implementing a distributed system can be an option where you can put some of your data, if you talk about that phone thing, so instead of putting everything on one phone, what you can do, you can go ahead and put it across the different phones, right? So this is one of the solution. But if you will see, in such case, initially, if you were managing one phone, let us say one phone is costing you somewhere around 30K. If you are buying five more phones, that is going to charge you more, right? So still that is an option. But for that, what you will have to do, you will actually be spending more money. Secondly, you will have to change the entire application. So that is something which is not practical in this case, right? So for this application, straight away going for the distributed system is something which is not practical, right? What is the immediate solution? So immediate solution, like I said, for the laptop, what we can do, we can add more memory. So here also for this machine, what we will be doing, we are going to add more storage, correct? This is the option which you are going to be following here. So in the existing machine, you will go ahead and add more memory. So how you can solve this problem? How this problem got solved? By adding extra storage here. By increasing the capacity, you are still able to make this work. So here initially, if your application was having 500 GB, and now what you can do, in the laptops as well, we have the option of putting some external hard disk and some memory chips and all. So what you have done, like even in the phones, you have the option of putting some memory cards. So what you have done, initially it had 500 GB, now you have added another 500 GB here. So if you add another 500 GB to your current setup, this method is called as vertical scaling. So when you are going to be adding it like this, we will say that we have vertically scaled our system. We are vertically scaling here, okay? Because you are scaling up in the vertical direction. So by enhancing the existing resource, what we have achieved here, we have achieved vertical scaling here. So initially your machine had a storage of 500 GB. Now on the top of that, I have added another 500 GB. So overall, how much storage you have here? 1000 GB. So what you have achieved here? Vertical scaling, correct? So when you try to maintain the performance of the system by increasing the capacity or configuration of the same system, So this way of scaling is called as vertical scaling. So overall, the major intent of performing these things is to scale the performance. What we want, even if more users are going to be using our application, we are still be able to take that load. Now, if we are if we have consumed 80% of this storage, we still have another 500 GB added there. So we have increased the capacity, we have increased the configuration of the same system. So this way of scaling is called as vertical scaling. Now, the another question is, can we continue vertical scaling indefinitely? Like, if what will exactly happen, now what I have done, I thought that okay, I'll add another 500 GB to my machine, but is this going to be the solution for a longer run? If today I have some 500 users, if tomorrow I'll have 5 million users, can I continue doing the same? Are there going to be any constraints of achieving vertical scaling there? So the answer is no, and there are two main reasons for this. What is the first reason? The first one is hardware limitation. I'll take the example of phone here first. So if you have your phone, for that, let us say you have two slots for memory card. Just consider this scenario, okay? So now what you have done initially, when you ran out of storage, you added one memory card here. Eventually, when you saw it again got full. So what you have done, you have added one more there. So that is how you can do it, but it has limitation here that after two memory cards, I cannot go ahead and put another memory card here because we do not have option of putting that. So that is the limitation which I have at the hardware level. So similarly, when you talk about this application, so there we have a limit for your RAM and for your CPU. So up to that limit only, we can go ahead and increase these things. There is going to be a limit to which your RAM and CPU can be increased. And this you can be this is something which is actually limiting based upon the hardware capabilities. So if you have a machine, you can just put the storage up to some extent only. Like I have a machine. After that, I even bought a hard disk of 5 TB. And let us say I always plug into my machine and that's how I use it. But I have a limitation here that I can only be having some two USB ports. So I can maximum put two USBs there, right? So that is how I have that problem here. And how that problem is there because of the hardware capabilities. So similarly, when you talk about the same, if you have any application, so there is going to be a limit up to which only you can go ahead and increase your RAM and CPU. Now, the next one which we have here is your cost considerations. So when you talk about cost consideration, like what exactly is there? So if you talk about any of the company, so what is the ultimate goal for any of the company? If you are a shopkeeper, if you are selling some goods, what is your ultimate goal? To make profit. Similarly, if you talk about any of the companies, so what is the wholesome purpose of any of the companies? That they go ahead and make profit. So if we are making any investment by adding some extra infrastructure, this investment should help the company from the perspective of making more profit, right? Now, as a part of any company, your goal is going to be making the profit here. And if you talk about the studies which we have done for the vertical scaling, that initially it can be effective. Let us say that you have a small startup. In that case, of course, there is going to be a cost limitation also. If you think about putting it on the distributed system, that is not at all going to be a feasible solution, right? So for a startup, it's going to be a wise decision, and it is even going to be effective if you are performing vertical scaling, if you are adding up some memory there. So that is going to allow you for the increased computation, and that is also going to be helping you in improved performance. But as the load is going to increase, this approach is also going to having some limitation. So eventually the benefits of vertical scaling diminish as we increase the cost and when hardware limitations are reached. So what do I mean? Like, for any of the application, how it is actually going to be there. You are going to be having some load. On the top of that, you are also going to be having some configuration. Correct? Now what will happen? Initially, when the load has increased and when you have increased the configuration, so your performance is also going to increase. But eventually after that, it will also slow down. So initially, when you go ahead and implement vertical scaling, so what happens? The performance remain the same. But eventually, like, what will happen? Over the period of time, you will notice that here also the performance fails. So if you will see, this is not like, this is the peak point till which we can see we have experienced high performance. After that, the performance is falling. So what is happening here? Your performance is falling gradually. So while this is still fine, this gradient is still okay. If you will see, the gradient is not huge. It is very less only. So when that gradient is still going to be less, the situation is still going to be manageable. But the problem is that if you do the vertical scaling and if you try to compare the performance and cost economics, then in the beginning it is linear. It means that if you are investing more in the vertical scaling, you will see that eventually, like, you will see that there is a proportional improvement in the performance, but eventually after a period of time it will start curving. So after a certain point, the performance gain diminishes in correspond to the increased cost, and that is going to lead to less efficient scaling approach. So if what do I exactly mean, like, I'll just draw it for a better clarity. So when we are, like, here we are considering the cost and here we are considering the performance. So what I am saying that initially with the increase in cost, the performance is also going to be there. So here we are talking about the delta in cost, the difference in the cost which is happening. And here if you will talk, here we are talking about the performance. So here we are going to be talking about the change in the performance. So initially your change in performance is your change in the performance is going to be directly proportional to the change in the cost. But after a point, if you will see that when you are increasing the cost of the vertical scaling, your delta C is going to be proportional to the increase in the performance. So if your performance is increasing, your cost will also increase. So initially it is going to be proportional, correct? But after a while, you will see that, like, as long as this happens, as long as with increase in performance, you are getting, like, when you are increasing the cost, your performance is also increasing. So as long as you are getting this, you will still say that it is beneficial for me to keep it doing. In the other words, what we can exactly say that your change in performance is directly proportional to your change in cost. It means that your performance improvement is proportional to the cost involved. How much money you are putting in the terms of cost, that is going to be helping you in the increased performance. So as long as you are getting some profit out of it, then it is okay to scale it vertically because you're putting some money and you are getting some profit out of it. Similarly, like, if you talk about any of the business, if you are putting some money there, if you are going to get some profit out of it, you are still going to be okay, right? But when it is not at all going to be okay, like, let us say after this point, what exactly happened? Now you are increasing more cost. But if you will see, there is a dip in the performance, like we are not getting that much of performance out of the cost which we are doing here. So after a point, we will see that the increase in performance becomes minimal as compared to the rising cost. So like, initially what will happen if you are increasing, like, let us say you are increasing the cost by 100, so you are going to get a profit of 100. So you can say that it is directly proportional. Like when I am increasing the cost, I am increasing the profit as well. So the overall performance is also increased. But after a while, what you have seen, if I am putting 100 for my cost, I am getting only 30 as the profit. So is it still going to be beneficial? No, right? So what you have is seen here, with the increase in the cost, there is less increase in performance. And this is something which we are not going to be considering, because overall we just want to make more profit. So if you are like, if you're talking about some of the business which you have set up, so if you will see that you are investing more money but you are getting less returns in the performance, so this situation is not at all going to be a wise decision, right? If we are having some company, so what we will feel that we can be changing our methods, we should be seeing how we can improve our profit here, right? So in that case, what you will have to do a trade-off between cost and performance. You will have to decide what you want to do here. Either you are going to be considering the cost or you are going to be considering the performance. Okay. So I hope this must be clear to you what exactly happened. When initially you were increasing the cost, the performance was also increasing. After a while, what happened? You were putting more money in order to improve the infrastructure, but you were getting less performance out of it. So that is not a wise decision. Now, there is one more reason to avoid vertical scaling. And what is that? Like, people say that, like, even if you talk about stocks and all, people say that don't put all your eggs in the same basket. Correct? They say that if you want to perform some investment, instead of putting all your money on one stock, it's better if you will split it across different stocks, because you are not going to be risking your entire money on one thing. Instead, you are going to be seeing how individually everything is performing, right? The same logic applies even here as well. So when you do vertical scaling on just one system, you have, like, if you talk about your application here, you have one system here, right? That is what your vertical scaling is. So what you have done, you have taken one system here, you have added all your money here, correct? You have put all your expertise here, right? All your data, like whatever data you have, all of that you have put on one machine, right? So we cannot take guarantee of anything, right? This machine, like, if we have a machine, this machine can still go down. What does it mean? There can be some power failure, right? Your machine can also crash. All of these things can happen. Since you are putting everything in one place, it means that what is exactly happening here? Here we have single point of failure. I'll take another example here so that you can understand this situation better. Let us say that you are on a vacation. You have one phone with you. Now in that phone, what you have done, you have installed. Yeah. So I was saying that, let us say you are on a vacation. You have one phone with you. Now what you have done, in this phone, you have added all for that country. Let us say you have added all food applications there. You have added all, like, cab booking applications there. You have also put your translator there. Now what can happen, like, if you are having everything in one phone, what will happen? There could be a situation of failure for this phone. What are the possible failures for this phone? Battery, no battery, correct? Another one is, let us say, there is no network. What could be another failure for this phone? Let us say phone broke. So now what will happen if you will put everything in one phone? If any of these things are happening, so what will happen? You have a single point of failure here. Means if your phone is not working, let us say your phone broke on your trip and you are in a group of two people, what you have done, now phone is broken. Now if you want to communicate to someone, so the translator app was also there in that phone only, that application will not work, right? Instead, what you would have done, instead of putting everything in one place, if you would have done it in two phones, would that have worked? That would have worked, right? Because if one machine is not up, if one phone is not working for any XYZ reason, still you have the option of another phone, correct? So I hope with the help of this example, it must be clear to you. So if you will keep on doing, like, in this phone, let us say initially it had a 256 GB of storage. What you have done, you have added another 256 GB, and you thought that instead of carrying two phones, I'll be only carrying one phone. And because now it is having additional storage as well, so it will be easier for me to click all the pictures and all, and I will be all sorted in my trip. But if you will see here, even after having all these things, you still have a single point of failure. So similarly, when you talk about this, when you perform vertical scaling, so it can be beneficial in a short term, like, this thing could have worked if you are just doing it for 1 hour or 2 hour, like, right? So similarly, when you talk about the vertical scaling, that can be beneficial in the short term, but over the period of time we should be thinking something beyond this. Everyone clear how we perform scalability? Okay, now there is one more thing which I really want to discuss out here, that is scalability a good problem or bad? Everyone just pause and try to think about it. I am saying that I have scalability problem. So is it even a good problem or bad problem, even for the companies to solve? I hope you guys must have thought about it and now you have resumed the video. So, when you talk about scalability, so what exactly we mean by scalability? I told you, right? So if you are having any application, if today you have less users, tomorrow if you are having more users, so overall the performance should remain same. That is what we mean by scalability, right? Now if our application initially had 30 users, now if it is having 300 users and we are facing some performance issue, so is it a good problem or bad? Of course it is a good problem. Why? Because it's good, right, for us, for our application, that initially it had 30 users, now it is having 300 users. Similarly, for any of the applications, scalability is always a good problem to solve, because it's good that we are having more users for our application. It indicates that more users are engaging with our application. So this is a positive sign of growth. Correct? Right? So this means we are growing. So since vertical scaling is not helpful always, it has some limitation. Then we should move from the centralized system. We should be moving to the centralized system, from the centralized system, and we should be moving towards the distributed system. And that is what we call as horizontal scaling. Like I said, instead of keeping everything in one phone, what if you are two people? So what you are saying that I am going to be installing same set of apps. Here you will be having cab apps, you will be having food, you will be having translator. Here also you will be having cab, food, translator. So all of those things you are putting in both of the phones. So what you have done, instead of putting everything in one machine, instead of having a centralized system, now what you are doing, you are putting it in a distributed system. You are distributing it out. Instead of putting everything in one machine, you distribute it out. So this is what we go ahead and call it as horizontal scaling. So what is horizontal scaling? So here what we do, instead of one machine, we make use of multiple machines. So instead of one machine, we will make use of multiple machines to increase the scalability. Correct? So previously what we were doing, on one machine we were adding more memory. Here what we will be doing, if we are having initially a system of 500 GB and let us say that now we require a storage of 2000 GB. So what we will be doing, instead of putting everything on one machine, now we are going to be splitting it across different machines. Now what we are doing, at every machine, I am going to be putting some 400 GB. And we are going to be connecting all of these devices together. How can I connect? We can connect all of these devices over the network. So this is how all the machines are going to get connected to each other. So here what we do, when we have this kind of setup, we say that we are having cluster of machines. We go ahead and call as a distributed system. So I hope this must be clear to you what we are doing. Instead of putting everything in one machine, now I am making use of multiple machines to store the data. And then when we follow this kind of strategy, what we do, we go ahead and call it as horizontal scaling. Now let's see what are the benefits of using horizontal scaling. So when you talk about horizontal scaling, what is the best part about horizontal scaling? Can you guys think of it? The best part about horizontal scaling is that here we have flexibility. Correct? If my current load is 200, let us say I have a current load of 200 requests per second. Yeah. So now let us say that we have a current load of 200 requests per second. And let us say that this load has increased to 400 requests per second. So I can easily add more machines to handle the increased demand, right? Also, if tomorrow load is going to decrease, then I can remove some of the machines accordingly. So depending upon the load, if you have more load, so what you can do, you can increase machines, correct? If you are having decreased load, then you can decrease the count of machines, correct? So depending upon the load, we can actually see how we should be taking up the action. If load is more, we can use more machines. If it is less, then we can use less machines. But overall, which one thing which we always have to consider, that is performance should remain same. Correct? We should not be impacting the performance. So when we have this ability to scale up or down based upon the load, then we say that we are performing horizontal scaling. Our ultimate goal is to maintain consistent performance regardless of the fluctuations which we are going to be having based upon the demand. So when we are going to be adding or removing the machines automatically, we are going to be setting up our systems in such a way that based upon the load, what I will, what generally happens, if there is some application, we are going to be having some set of machines. and based upon the loads, we will decide how many machines to use. Accordingly, there are going to be certain machines available and we are going to be adding or removing based upon the load. So when we go ahead and use such a system, we say that we have elastically scale them. So when you talk about elastic scaling, what does it mean? It means that such machines are going to be able to handle such of the situation when you have to add or remove machines. That too automatically. Correct? This feature is generally offered by some of the cloud providers. What and all are offering this? So if you talk like about your AWS, if you talk about Azure, if you talk about Google Cloud, so all of these are actually providing you this flexibility. So here, if you have seen what we are doing based upon the requirement, we are going ahead and we are performing scaling, scaling here. Based upon the load, we are going to be adding or removing the machines. But overall, what is our ultimate goal? What is the key feature which we expect out of it? That the performance should remain same, right? So now let me just brief down the scalability and then we will be winding up the module. So whenever you want to achieve scalability in any of your application, so how you can do? You are going to be achieving it at the code level and at the infrastructure level. These are the two ways of achieving it, right? Correct. These are the two ways in which you can go ahead and scale down your application, scale up your application. Now, when you talk about code level, what are the two ways of achieving it? So that is something which we do by taking care of the time complexity and your space complexity. Correct? These are the two ways of achieving scalability at the code level. When you talk about infrastructure level, at that time we can achieve it in two ways. What and all those are? So we have seen first one which we have seen is your vertical scaling, and the other one which we have is your horizontal scaling. So these are the two ways in which at the infrastructure level you can go ahead and perform the vertical scaling. And you perform the scaling at the infrastructure level. Okay. Now, when you talk about horizontal scaling, what is the one thing which we always take care here? So in the horizontal, if you talk about vertical scaling, so there what we are doing, we are putting all our eggs at one place. So what we are doing there, we are actually having one machine where we are going to be putting everything. So if that machine is going to go down, the entire system will go down, right? On the other side, when you talk about horizontal scaling, so this one is fault tolerant. Here, if there is going to be any fault, it is going to handle it down. And how it will be able to achieve that? With the help of replication. This replication is something which we are going to be covering in our next module, but I hope it must be clear to you that if we are going to be encountering any performance related issue, in that case, how can we go ahead and optimize your system? How you can scale your system, right? Now I will be seeing you in the next module. Till then, happy learning. Bye bye. Hello everyone. In this module, we are going to be talking about optimization. So you guys must have heard of this word optimization. Correct? Now how it is exactly going to be working, what we are going to be doing here. So all of that we are going to be looking in this module. So first of all, I'm going to be taking one example. I'm going to be considering a scenario. Okay, I'll be putting one issue here so that you can understand it better with the help of that example. So like, let us say you are someone who started working for a company. So when you will be working for any of the company, there you are going to be building any some of the application, right? So this is you working on the application. Now this application is going to be interacting with the database, correct? Now, in this one, like let us say here we are having a users table. So in this table, we are going to be having all the different attributes, like, let us say for this user, we have some of the information which we have stored. So let us say your name, age, address, correct? So these are the informations which we are storing in our user table, correct? Now, when this application was first created, so we had small amount of data. So let us say initially we had, let us say, some 100 rows of data, correct? Now, when the users who were using these applications, they were getting data very fast. It was a very fast application. It was very responsive. And how it was very responsive, if less data is there, if you are going to be performing any query on this user table, you're going to be getting results in a lesser time, correct? So in this case, if I'm going to be performing any search, the results are going to return almost instantly. The search will be very fast, correct? Because in the beginning we have less data. So whenever you will be talking about beginning of the application, that time it is going to be very fast. It is going to be very optimal. However, when with the time period, that application is going to grow its user base. When the application will grow, the data is also going to grow. Initially, if you had some 100 rows, now if it is increasing to your 1000 rows. So what will happen, like, with more rows, the load on your database is also going to increase, right? You are going to be inputting more data there. And let us say after this, now we are having 1 million rows. So now you are having a lot of data with you. Now, with the significant increase in data, the customers will talk about the slowness. The same application that initially returned results in about 5 milliseconds is now taking several seconds for the same query to complete. So what will happen? Like, let us say you are using some application. Example, let's take example of Amazon only. If initially, let us say you want to buy a mobile. So what you will do in the search bar, if you are saying putting phone and then you are doing enter, let us say initially you are getting result in 1 millisecond. With the more users who will start using this application, now let us say the same query is taking 1 minute. As a user, will you be very okay with that? No, right? You will start complaining that now it is slow. It is very slow. Not just slow, it is very slow, because in order to fetch the results, if previously I was able to do the same in 1 millisecond, now I am able to do that in 1 minute, which is a lot of time. We guys, like, I remember when we started the mobiles, having internet and all. I remember previously, like, we, even if we wanted to download a song, it used to take roughly around 3 to 4 minutes, because back then the speed of internet was also slow. But now if you will see, I can download the same in 1 second, 2 second. But now, like, since you are habitual of doing that in 1 second, 2 second, now if I will put you in a situation that if you want to download that same song, and for that you will have to wait for 5 minutes, are you going to be okay? Not at all. You are going to complain that I'm not going to use this application. This is taking a lot of time. Similarly, like, if you are putting phone and you are doing enter, after that, if it will take 1 minute to fetch the results, to display it on your screen, are you going to be okay? No. You will start complaining about it that I am not going to use this application. This is slow. You will be complaining about its slowness. Trust me, this slowness of the application over the period of time is one of the most common thing which you will be seeing in the industry. So if you were in this situation, what will you identify? What do you think is the cause of the issue? What can we apply here in order to speed up the performance? Can we apply scaling here? So sometimes scaling can help, whether you apply vertical scaling or the horizontal scaling. So when you are applying scaling, it can help you, and it can actually help you in the scenario when you need more storage or when you need more computing power. In such a case, scaling is going to help you out. For instance, if our current system is, let us say I am having a system and it is of 500 GB, correct? And if we need to increase the storage, then what can I do? I can go ahead and apply scaling there. But in this case, if we will look closer, but if we will see, we are having a database and this is of 500 GB. If we will look close, we will see that, since it is slow, we will assume that it is completely filled. But if we will see that 200 GB is still free. Now, what will happen? We will see that we have consumed only 300 GB of the data. We are still having 200 GB of free space. What we should be doing in these situations? So in this situation, if you will see, scaling is not the solution. Why it is not the solution? Because you will go ahead and apply it when you have some storage issue. And if you will see here, we do not have storage issue. We still have 200 GB of free data, correct? Now, if you will see, we still have 200 GB free, but still customers are complaining about it. They are still saying that performance is degrading. They will say that 2 months ago, it was taking roughly 5 milliseconds. Now the same query is taking 2 seconds. So customers are going to experience performance issue, right? So what is the problem and what can you do about it? So one major issue of this is improper database indexing. And why I am pointing it out? Because as your database is going to grow, if they are not indexed correctly, in that case, your query performance will degrade. A poorly indexed database is going to be one of the reason for your slow query. Now, what is an index and why do we need it? So when you talk about your database index, so what exactly we do here? In this one, we are going to be using a database index, which is going to be significantly improving the system performance. Now, what exactly happened? If you will see that your queries are slowing down over the period of time, then that is going to be happening because of the improper indexing. If you are not going to index your database, in that case, it is going to get slow down if you will try to fetch the results. Now we will see what an index is and how it actually helps. So if you talk about the same user database, user table. So there, what and all we had name, age, address, let us say, we have other fields as well. So that is how we are having our database. And here we are having some data available here, right? So now let's assume that, what query we are running mostly here, some select query. So let us say we are running some select query, something like select star from users. And then we are putting some condition there where let us say name is ABC. Let us say this is the query which you run, correct? Now, if let us say most of your queries are going to be using the name column in the where clause. So normally when you hit this kind of query, what will happen is that your query execution engine, what it tries to do is that it will go to each of the rows, and for every row, it will check if the name matches or not, right? So if I'm saying ABC here, let us say I have fields like XYZ, and let us say A1, A2. Lastly, we have ABC. But in order to execute this query, what it will be doing, it will go to first, it will match. Is it matching ABC? No. It will go to the next one. It will say, is it matching with the ABC? No. It will go to the next one. It will see, is it matching? No. It will go to the next one. Is it matching? Yes. If it is matching, it will end. Otherwise, it will keep on moving to the next row. It will keep on repeating the process until the end of the table. And this type of search resembles like the linear search in an array. What we do in the linear search of the array, if we are having some set of values with us, if I am locating 3, what I will be doing in the linear search, I'll go and match. Is it equal to 3? No. 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 Is it equal to 3? Yes. What I am doing here, I am going to each one of the value and I am matching if it is going to be equal to the value which I am looking for. So here, if you will see what is the time complexity here, that is going to be order of n, where n is the number of elements. Similarly, if you talk about this scenario, what is the time complexity? So that is going to be equal to order of n, and here n is going to be the number of rows. All right, everyone clear with this? So here, as the number of rows are going to increase, the search time is also going to increase, correct? Because initially, if you have only 5 rows, searching for that value is easy, even if that value lies in the last of that table, in the last row of that table, right? But eventually, if you have, let us say, some 500 or 5 million, in that case, you can see you are searching through the entire values in order to locate if it is there or not. So in such case, if you are not using any specialized strategy to handle this, you will end up performing a linear scan. If always the value is going to be in the last, or let us say the value is not at all there, in that case, you are performing a linear scan, you are going to be going through all of the rows available to you. So the more number of rows you have, the slower it will get eventually. And if the time complexity is order of n, the execution time will keep growing with the data size. So I hope the main issue identified, you have identified what the problem is there. What the problem is that you are going through all of the rows one by one. And why you are going it in that manner, like, I'll give you one more example here before jumping into the indexing. Like, let us say I have a book. In this book, I have certain topics. So topic A, topic B, topic D, topic C, like it's not at all even organized, something like that. And let us say I am locating a topic C. If there is no index here, I'm just saying that, okay, these are the different topics which are going to be there. So how you are going to be locating it out? You are going to be flipping all the pages of your book and you will stop when you will find that value, when you will find that topic. Correct? That is how you are going to be doing, right? Let us say you are going through a pictures album. You are trying to find out a particular picture. So what you will do, if you do not know on which page number it is going to be there, you will flip all the pages unless you reach to the picture which you were looking for. Correct? That is how we guys are going to be working, right? On the other side, let us say here I have kept certain index like page 1, topic A, page 2, topic B, page 3, topic D, page 4, topic 4. If all of these are going to be properly indexed, so you will understand that on page 4 you are going to be locating that topic, correct? It will be going to be easier for you. So I'll give you one funny example here. So me and one of my friend, we went to one restaurant, and that restaurant had enormously big menu, like lots of pages. So generally, like how we do, like we will flip all the pages and then we'll tell, okay, on this page you will see pastas, you will see this item, that item. But on that menu, what was the funny part, every page had a page number. So it was very easy for me to communicate it to him that, okay, now you go to the page number 5, there you will find the item which I am looking for. So like you can see, even it is a small problem, but there with the help of indexing, it saved our time. Otherwise we have to flip all the pages one after the another in order to locate it, correct? Of course, the other option is, if I have already opened, I can show it to him. But let us say I don't want to do that. So you can consider, if you are not going to be putting an index, so what will happen, it will slow down the queries. So now how can you, like what you can do to improve the speed of the linear search? So one obvious improvement would be sorting the data. What if in this case, like one thing which I would have done, I would have sorted it down. So I have topic A first, then B, then I have C, and then I have D. So if I have it in this manner, I will understand that, okay, after this, it will be possible for me to locate just how your dictionaries work. So, after B, you are going to get all the words with C. And there also, how it is exactly going to be there, like, how dictionaries are there. So if you talk about C, so you are going to be first having all the words starting with CA, then all the words starting with CB, and so on, correct? That is how it is there, right? So one obvious improvement is going to be sorting the data. Once you have sorted your data, in that case, searching becomes easier, and you can use a binary search algorithm, like even about the array. If you already have a sorted values, in that case, applying a binary search algorithm is going to be one of the good approach, and that also has a time complexity of order of log n, which is much faster than order of n, right? Now, can we apply the same concept to database? So we will try to see, and we will try to see if we can go ahead and extend this even to the database. So when you talk about database, when we need to make our searches faster, our goal is to make read operations fast, right? If every time I am doing something like select query, in that case, we know that we are not modifying the data, but what we are doing, we are reading the values. So what we are applying here, some read operations. So first of all, you need to understand that what kind of queries your application is going to be running. For example, if majority of your queries are going to be something like you are looking for some value with the where clause like this. If most of your queries are like that, we will understand that most of my queries are going to be read. And if those queries are slow, this will give us a clue about the root cause. So before making any changes, it is always important to analyze which type of queries are most frequent and which ones are causing the performance issues. Once you have figured it out, then you should be looking into the solution for that. And one of the solution for this is indexing. So once you have identified that most of your queries are involving name column, so what you can do, you can take certain steps to optimize the search. So one of the solution is to create an index on the name column. So what you are going to be doing, like, if all of your queries are select type, so you are performing all the read operations there. Once you have identified that most of your queries are going to be involving search read operations, where you are going to be making use of something like where clause, correct? After this, you will be taking steps to optimize the search. So what you will be doing, you are going to be creating index on the name column. All right. Now, what you should be doing for that, you are going to be first of all make a copy of the name column. Okay. After maintaining a copy, what you will do, you are going to be storing this copy in a separate place. So store this copy in a separate place in hard disk. All right. After that, what you will be doing, you are going to be sorting it in such a way that searching can be done quickly. So sort the values in such a way can be faster. All right. So by doing this, my database is not actually performing a linear search across all the rows. Instead, what it is doing, it is using this index to search more efficiently. And this is also going to be improving your queries performance drastically. So I'll actually draw it so that you can understand it better. So for the user, where I have columns like name, age, address. Now from this, if I know I will always have to use this column name. So what I will do, copy this whole column, right? And what I will be doing, I'm going to be keeping it separate. So here I am going to be having a pointer. And with that pointer, I am going to be having a name. So this is how I am going to be keeping it separate. So when you go and store a copied column in a separate place, it is essential to keep it sorted. Here, what is something which we are looking for? We are aiming to have a fast search operation. Correct? Now, each entry in this index is going to contain a pointer to the original record location in the main table. And why it is important? Like let us say here I have ABC. Here I have XYZ or DEF, IJK, PTR, something like, and here I'm putting a pointer like, 1, 5, 3, 2. So what I'm exactly doing? So here we are going to be having some of the entries and I'm actually like, putting some mapping here so that it will not take a lot of time. So now when somebody is actually going to be making a query, something like this, where I have something like this name. So in this, what will happen? The query engine is going to look like, let us say here I'm providing a value ABC. So what will happen? Your query engine is going to look for ABC in the index using the binary search because this name is written down in the sorted order. So instead of performing linear search here, all the values are already sorted. So you can go ahead and apply sorting here directly. So this approach of maintaining a sorted column is going to be called as indexing, because what we are doing, firstly, we are keeping a sorted column separate. You can actually write like maintain a sorted copy of the column. All right. And later on, what we are doing, we are applying binary search there. All right. So this is actually called as indexing. All right. Now, in order to even perform the indexing, we need to choose which data structure to use. So to maintain this sorted order, since this has to be requiring to rearrange the values all the times, so we need to have a optimal data structure which can actually support the optimal insertion and deletions. So what data structures we can use here, because what we are targeting, that if you are having some set of values, so if today we are having four values, we just want all of them to be sorted. Tomorrow the fifth value can come, and what we want, that it will get added optimally. It is not going to impact the entire structure. At the same time, if we want to delete, that also should be optimal. So what can we use here? Can you guys think of it? What can be used? Can we go ahead and apply tree? A lot of you can think, yes, maybe we can apply, right? But you cannot. Why? Because if you talk about tree is not sorted, right? So if you talk about binary search tree, like a lot of you will actually think that binary search tree is something. Here we are having in order reversal, which is sorted. So you may think that here we can go ahead and apply it, right? But here if you will see, what is the time complexity for search? So that is your order of height. So based upon how many entries you are going to be having, accordingly it is going to be determining the complexity for that. In the worst case, if your height is equal to n, so that is going to make the complexity order of n. So that is not meeting our goals, because this is again when you talk about the I took the example that okay, in the linear search it is actually taking order of n. So similarly, if you are taking binary search tree, so here also it is taking order of n only. So what we are doing, like the time complexity is similar to your linear search, that is not efficient. What we are looking for, the complexity which is equal to your binary search. What is the complexity of binary search? That is order of log n. So this binary search does not meet binary search tree does not meet order of log n time complexity, right? So what is the next thing which I can use here? The next option is balanced binary search tree. So when you talk about balanced binary search tree, you can make use of something called as red black tree. So this one actually guarantees that if you want to perform search, so that you can go ahead and perform it in log n. So basically, if you are performing some search, or if you are performing some insertion, or if you are performing some deletion, so for all of that, the time complexity is going to be logarithmic. All right, so here for all these operations, you are going to be getting logarithmic complexity. So red black trees are commonly used for database indexing. Okay, why? Because of its balance structure, which ensures logarithmic time complexity for all of these operations. I'm actually seeing the latest trend in the interviews as well. People have started asking about self-balancing trees a lot. So, whenever you are going to be applying for the interviews, I'll just say that, okay, go ahead and read about it. They can also be asking you these questions as a part of the system design round as well. Like they will give you this scenario and they will ask you how you can perform indexing here, what data structure you can use. So you should be well versed that what is that which you can use, that is your balanced binary search tree. Okay, now I'll take one example of the real world, okay, so that you can even understand it better. So let's take the example of your Google Maps, or Uber, how it is exactly working. So like consider anything, okay? So when you want to track a cab driver's location in the real time, because it is constantly changing. So for the constantly changing dynamic positions, what data structures it is going to be using. So you know you are having a driver, and if you will talk about its location, if you have seen how it will actually be shown to you on your application, they will be showing that, okay, there is a car and they will show you, okay, this and that is the path which is going to follow and this is your pickup point, and they will show some 5 minutes or something like that, and after some while you will see it is showing 4 minutes. So how it is exactly working? So it is all possible, like if you will see the driver location, so the driver location is something which is constantly changing, and in order to store all of, like if you want to track your dynamic positions about, like where he is actually going to be there, so what database you are going to be using for that, sorry, what data structure you are going to be using for that? Can you guys think about it? What we can do, we can go ahead and make use of balanced binary search tree. So this is also something which people can ask you in the interview, that okay, if you are going to be designing that, tell me what data structure you are going to be picking. Okay. Now, when you talk about indexing, right? One question which is like big question, that does indexing always help? What is the problem with indexing? And in which situation will it go and create a problem? So indexing only makes sense if my application is read heavy. Now, what is the meaning of that? If you are applying only read operation, in that case, indexing is the best choice. But with this, your write operations are going to become slower. And your, like, in this one, what exactly happens? Your read operations are faster. On the other side, if you talk about your write operations, so your write operations are slower. So when you are going to be applying the indexing, so you need to see that when you should go ahead and apply. So firstly, you need to figure out what kind of operations are going to be involved. And based upon that, you should be taking a decision that whether you should apply indexing or not. Because when you talk about indexing, your indexing improves your read performance, but it can slow down your write operations. So whenever you will apply indexing, you should always be considering that where you are applying. So it should always be applied for a read heavy application. When I say read heavy, what does it mean? It means when you are going to be involving more read queries. So if you will add indexing anywhere, like, if you're not going to consider where to put it, you may be degrading your application performance instead of improving. So what you should always be considering, like you should always apply indexing only to the frequently queried columns. All right. You should not be doing indexing on all the random columns. Random indexing, if you are performing, that is going to be consuming a lot of storage and it will slow down the write operations. So you should only apply to the relevant columns. Okay. Now you should be avoiding indexing for a text heavy queries. Now, what does it mean? If you are running some query like select star, where you are using the where clause, right? So, like I'll actually give you some example. Let us say you're using something like select star from users, where name, then you are using like, and then you are providing some value. So if you talk about it, what it is, this is a text based query, correct? This is a text based search. So here, like, if you talk about this one, so the data structure which we are going to be using here is going to be the red black tree, correct? So in this, when you will go and search, you will always be doing a binary search, but it is suboptimal for handling large volume of text based data. In such case, what you should be doing, you should be using Elasticsearch database. Now, what Elasticsearch database is going to be doing? So this is like, this is optimized for your text-based queries. Okay. So whenever you are going to be performing some text-based queries, in that case, this Elasticsearch database is going to be providing you some extensive indexing support, and it will be delivering faster results. All right. I hope you guys must be clear with this. All right. Now we are going to be discussing something which we call as partitioning. So this partitioning is broadly of two types. First one is your horizontal partitioning. The second one is your vertical partitioning. Okay. So when you talk about partitioning, basically what is exactly going to be there? So you are going to be having some of your tables. They can be, let us say, in the RDBMS, or they are, let us say, in some NoSQL database or some distributed database. So in those ones, like, be it any of the database, if you will have to apply partitioning in both of the scenarios, these are the two possible ways. What is partitioning, I'm going to be discussing now. Okay. So first we are going to be discussing your horizontal. So the first one which we are going to be discussing is your horizontal partitioning. So let us say that I have a big table which is having million of records. All right. So let us say I have some table here which is having some fields like zip code. I have some column X, I have some column Y, I have some column Z. And let us say that here we have millions of records. Okay. Now, when you talk about horizontal partitioning, so we also call it as sharding. So if anyone is asking you sharding, you should be knowing that this is horizontal partitioning only. And we also call it as range-based partitioning. So it is actually known by all of these three names. So in the interview, if anybody is asking you about these things, you don't have to get confused. You know, be it your horizontal partitioning, range-based or sharding, you have to talk about the same. So here what we do, when we have a large tables in the database. So what we do, we split them across multiple machines. So if you have a table which is having the columns like your zip code, some fields X, Y, Z, something. Okay. So this table is like, let us say this table is actually having million of records and this is too large to fit on a single machine. So what we will be doing, we are going to be splitting it down. So with horizontal partitioning, this table is divided into smaller chunks and that can be distributed across multiple machines. So let us say that for the zip code, like, I'm taking some range that from 1 to 500, I am going to be storing it on machine 1. I'll say that the range starting from 501 to 5000, I am going to be storing it on machine 2. If I'll talk about the range 5001 to 10,000, that I am going to be storing on machine 3. So like let us say what I have done, I have taken some of the ranges. So by slicing the table horizontally and distributing these slices across different machine, in such case, each machine can handle only one subset of data. So they are not dealing with entire values. They are only dealing with a range from 1 to 500. So if I follow some range number like I have done here, so I know that, okay, up to value 500, that will go on machine 1, 5000, machine 2, and so on, right? So if you do partitioning of the database from some range of the numbers, what you do, you go ahead and call it as a range-based partitioning, because based upon a range, you are deciding where you are going to be putting your values, correct? Also, it will be easy for you to read the values. Like let us say I'm asking uh, for a pin code which is having a number 400. So you know it will be there on your machine 1, correct? Now, what is the advantage of doing this? The advantage is scalability. And how? So like you can store large amount of data across multiple machines. And by doing that, you are also reducing the load on the single machine. So instead of putting every load on one machine, now you are splitting it down. All right. So instead of making one machine heavy, we are splitting it down. And that's how you are also reducing the load. So this is the advantage which we discussed about it. Now let's see what is the disadvantage of doing the same. So like, what could be the challenge? Like, do you see any of the challenge here? Do you see this is a great way of partitioning? Now this approach also has some challenge. And what is that? We have some network latency in your joins or unions. So what happened when you are performing some operation like join or union across your data on the different machine? So there is some added network latency there. And what it can do, it can slow down the queries since most of your data is going to be fetching up from the multiple machines. So what happens in join unions or join? You will try to do that like, you have some value of one table which is scattered across different tables on different machines. Now, if all of these tables are on different machines, then we will be getting some network issue. Because of that, we can face some of the delays. Because like, here what we have done, we have split it down. And when we will split it down on different machines, we will be having a dependency on the network. So when you do horizontal scaling or sharding, you don't face the problem of like, you are actually going to be facing the problem there. So here, like, although we say that it's a good way of putting it on the different machines, but this is going to be resulting into the network latency. Your machine is going to get delayed. All right. Now, there is one more consideration which you should be keeping in your mind. And what is that? Although I have said that I am going to be putting my values like this. What if, I'll just take from here. Yeah. Now, let us say that in this range, what is happening? It can happen that one machine, machine 1 can actually have lesser number of fields. Machine 2 can have lesser number because we are splitting the range. But we are not having a count, like how many values are going to be there. Correct? Now, if such thing is happening, so what will happen? Like, let us say this one is having something like 500 records. This one is having something like 5 million records. And this one is having something like 5,000 records. So if you will see what is happening here, this machine is still having more data, right? More data in this range, correct? If such a case is there, it is possible that the machine which is handling large range of data might not have enough resources, might not have enough storage or memory to accommodate all the data. So when this happens, you may need to partition the data further so that you can maintain a balance of the load across the machines, because handling such amount of data on one machine is again going to be difficult, right? So although this splitting based upon the range is a good option, but this is one of the challenge which your horizontal partitioning is going to face when you are going to split it down and then one of the range is getting more values. And in order to address this, we have another solution which we go ahead and call as vertical partitioning. So what happens, like let us say you are I'll be taking one example, like let us say you are working for Amazon. Now this is having some several users. So let us say I have a table something like your orders table. I have something like sales table. I have something called as customers table. So these are the different tables which I have. Now, if the data in each of these tables is large enough to not fit on single machine, what we will do? We are going to be partitioning the tables vertically, right? So what we can do, we can store this orders table on machine 1. We can store this sales table on another machine 2. We can store this customers table on, let us say, machine 3. So this is a form of vertical partitioning where each table is stored on a different machine. So when you are dividing your database into separate tables, and if you are hosting each table on a different machine, so this process we call as vertical partitioning. So this method is easy to implement because you are simply assigning each table to a different machine. However, you don't horizontally scale each table in the database. And if you are not going to do that, you might end up with the combination of horizontal and vertical partitioning. Example, here, let us say that if you talk about example orders table, that is too large to fit on M1. So what you can do, you can apply some combinational approach here. You can apply horizontal scaling here, partitioning here, plus you can go ahead and apply vertical partitioning here. So you can go ahead and apply both of these. So when you are going to be using a combination, in that case, it will be easier for you to deal with a large amount of data. Okay. Now we will see what are the challenges which we face with the vertical partitioning. So what are going to be the challenges for that? It will have uneven table size. Now, if I'm splitting three tables on three different machines, it can happen that one table has more data as compared to another. In that case, that machine is going to get overloaded, and then we will be needing further partitioning. This example, which I have just discussed, right? Second one is if you have data which is scattered on the different machines, you will be like, when you are going to be returning the result, you will be performing some joins there. And if you talk about joins, so those are expensive operation. And when we talk about expensive, it means it is going to be like, taking some network delays, and that can be impacting the partitioning. All right. Now we have another type of partitioning, which is your directory based partitioning. All right. So when you talk about directory based partitioning, basically what we do here, we will be making use of a lookup directory. Based upon that, like, what this lookup directory is actually going to be doing. So this lookup directory is actually going to be storing the location of the data across your cluster. Correct? So what exactly it is going to be doing? So like, let us say you have a dictionary, right? So what exactly happened there? It will be telling you that on which page number, which letter is going to be there, right? So what exactly that lookup is going to be doing? So if you have your data, which is there on the different machines, and if you want to look up for that, so this lookup directory is going to be helping you out by providing you that where the data is going to be there. And this will ensure that whenever you need to retrieve that data, the system can quickly tell you which machine holds the data which you are looking for. So if you have some cluster here, all of this is going to be storing some information. These ones are connected over the network with each other, right? Now this cluster, like, here we are going to be having some of our data which is spread it across. If you are going to be looking for some information, it will be difficult for you to locate it just by looking at the cluster. But what if for this cluster you have something which we call as lookup directory? If I am going to be providing some indexing here, which is going to be telling you where your data is going to be there. So this is going to be speeding up the search process, right? So whenever your data is written on or distributed across multiple machine, so we are going to be storing the information about its location in the lookup directory. So whenever somebody is going to be searching for a data, they are going to be looking for the same in that lookup directory. And this approach we call as directory based partitioning. So this is something which we like, this is something which we do not use on our traditional database, because there we know everything is going to be there across one machine. Like, in the traditional system, this is going to be only going to be making sense if you talk about a distributed system. Because if you talk about a regular system, there everything is going to be there at one place, right? But if you talk about distributed, there only you will be having the data which is split it across different machines. So in that case, it will make sense to use it only when you have a distributed system. Now, one of the major advantage of using directory based partitioning is the flexibility. So if you ever need to change your partitioning strategy in the future, you are not going to be modifying the data. Instead, what you will be doing, you're only going to be modifying the lookup directory, so that now you can tell where the new data is going to be lying. So this one is going to be making the change in partitioning scheme easier. So we are not changing the data storage or the retrieval process. We are only going to be making change in this lookup table. Okay. I hope this must be clear to you. Now, what are the challenges which we are going to be following with the directory based partitioning? So the major challenge, like, which we are going to be facing here is going to be the extra maintenance. Why the extra maintenance is going to be there? That is because if you will see, previously we were only maintaining our data, but now we are also going to be maintaining the extra lookup directory. So that is going to be the extra maintenance which is going to be there, right? Also, if you will see, what is the another failure? That is single point of failure. So if you talk about this scenario, here what we are doing, we are taking a lookup table and there we are going to be putting all our mapping. If, like, again, this is one system. So if this will go down, so that is going to shut down the entire system. So this is the single point of failure. Okay. Now, since we have discussed what are the disadvantages of this, so what is the alternative approach for the same? So the another strategy which we have is your ID based range partitioning. So what we do here, that is, like, all, like I said, what we are going to do, we are going to be taking our data based upon some IDs. So we will say something like that your data in the range 0 to 400 that will be stored on your machine M1. Your data 401 2000 is going to be stored on your machine M2. Your data which is there in the range 1001 to your 1500 that will be stored on your machine M3. Your data starting from 1501 to the 2000 that is going to get stored on the machine number 4 and so on. Like similarly, what we are doing, based upon the IDs, we are defining the range and then we are telling on which machine you are going to be storing your data. Clear? Now, in this scenario, the data is partitioned into the predefined ID ranges and each machine is responsible for a specific range. So when a piece of data comes in, you are going to be checking its ID and then you are going to be placing it to the corresponding machine. Now, if you will see, this is how we are going to be putting our data, but this one is also going to be having some of the limitations. What those limitations are? So the first one which we have is range boundaries. Now, what does it mean? So here we are saying that we are going to be taking care of the ranges, like this range will go in this machine and so on, right? So here the data must be range based, means your system needs to know how to partition the data in advance. You have to set these ranges which can be inflexible if the data distribution changes over the time. Like if you talk about numbers, you can go ahead and specify a range. If you talk about some string, maybe you can do it by storing something like all A's together, all B's together, something like that. Okay. What if I'm giving you certain colors? Like, here I'm going to be talking about color. So based upon color, you can go ahead and range it down. What if we are specific, like, we do not have any range? In that case, you cannot go ahead and store your data here, right? The second one is scaling issue. So if, like, if let us say, if you talk about your range, so let us say you are like, in that particular range, you are having a lot of data. So in that case, like what will happen, you are going to be running into some of the problem. Your system might not be able to handle the new data points if it is exceeding the initial planned range, right? Because we have already decided that, okay, we are having these ranges, like let us say 0 to 400, but if here we are having a lot of data, so as the data is going to grow, you may need to reconfigure your partitioning scheme, or you will have to add more machines so that if you are having some extra data, you can go ahead and add it there. Now, one solution which came for this problem is your hash based partitioning. So you guys must already be aware that how we calculate the hash, right? So what happens? we are going to be coming up with a formula, and based upon that we store our values, right? Now if we have to put that approach here, so what will happen, like let us say we are already having certain machines like some M1, M0, M1, M2, M3, M4, M5. Let us say we are having these set of machines, and each machine is going to be like holding some of the data. So when we are going to have some data, what we will do, we are going to be computing a hash function here. So we are going to be using some hash function so that we can get some value out of it. This hash function is going to be generating some random or some numerical value, right? And based upon that value, you can determine that on which machine this data is going to get stored. Like let us say if you are having a hash value which is pointing to your machine 1, so we will go ahead and store that data on machine 1. If it is pointing to machine 3, we will go ahead and store it there. So let us consider this is how we have our cluster. So here let us say 0, 1, 2, 3, 4, 5. Like this we have our cluster. They both are connected over internet. All right. Now what I will do, like let us say I am having a function to calculate the hash. Let us say that is something like hash. And here what I am doing, I am taking like, whatever the data I have, what I am doing, I am taking the total number of nodes. So let us say this is the hash function which I am using so that I can go ahead and store my data. Here n represents number of nodes. All right. So what we will do when we will have to store any piece of data. So with the help of this hash function, what we will be doing, we are going to be calculating a value. And based upon that value, we will be mapping that to one of the 6 machines available to us. Okay. All right. So now we'll take some examples so that you will be able to understand. Like let us say we are having some data available, which is ABC, and now we want to store this data on the machines which are available to us. So what we will do, we are going to be determining like, let me give it H here. So I'm going to be calculating a hash for that. So that is going to be hash, that is going to be of your data, that is ABC. And on the top of that, you are going to be applying your n. So how many machines do we have here? 6. So this is how you are going to be calculating it out. Of course, for this, like, we are going to be seeing how we want to calculate the hash. So that is something which is going to be purely dependent upon how we plan to consume it. Now let us say the result is coming 1. So we will know that this data ABC, where it will go, it is going to go on our machine 1. So this is how your hash based partitioning is working. Here we are going to be calculating the hash function, which is going to be deciding that on which, like, based upon the value which we will get out of it, based upon that we are going to be determining that where that data is going to be stored. Now, what are the advantages or the key benefits of using hash based partitioning? So the first one which we have is even distribution. So here what is happening? Here we are not working on some predefined ranges. Here we are calculating, and based upon that we are assigning the machines. So here if you will see, your data is distributed more evenly across the machines. Correct? The second advantage is scalability. So, if you want, you can add more machines here in the system without needing to repartition the data manually. So here for now, we have 6 machines. If you will have the need, you can go ahead and add one. So what will happen? Your hash function is going to get changed. Remaining things are going to remain same only, correct? Similarly, if you want to remove, So that option is also there. So whatever data you have, you are not repartitioning that data manually. You are just updating the hash function, and that is going to be, now you know whatever the machines are going to be available. So that hash function is going to be allocating the data accordingly. The next one which we have here is less maintenance. So since here, if you will see, we do not have to manage the ranges, or we do not even have to configure the partitions. So in this case, what we can say, this is requiring less maintenance because we are not at all putting a lot of efforts into deciding the ranges or anything. Correct? Now we are going to be discussing what are the challenges which we face with the hash-based partitioning. So, although this hash-based partitioning, this works well in many scenarios, but still there are some of the challenges which we need to consider. So, the first one is dynamic cluster size. So, let us say we have a function hash data mod n. Here, n is the number of nodes. So, this is going to work well when your number of nodes is fixed. Correct? However, if your cluster size is changing, so let us say if you want to add a new machine or if you want to remove a machine, so that is going to be creating a problem. I said, right? If that is the case, we will have to change the hash function. So that is the problem. So here, let us say that initially you have a cluster of 4 nodes. So the function is going to be hash d mod 4. Correct? That is how your function is going to be there. Now let us say you are adding one more machine. So that is going to make your n equals to 5. So your new hash function is going to be hash d percentage, mod 5. So now in this case, if you will be seeing what is happening, when you are going to be applying the hash function again, the result could have changed because the mod function which we are using here is now using a different divisor. So instead of 4, now we are using 5 here. This means that some of the data which was originally stored on machine 4 may be now mapping to a different machine because the hash values have shifted. So this is a problem, especially when we work in a dynamic system where the number of nodes can change over the period of time. So in such case, what we will have to do, we will have to repartition the system so that we can go ahead and so that we can go ahead and accommodate the new cluster size. And this entire process could be expensive. Also, it is also going to be taking some of the time. So that is also there. Now, the next downside of hash-based partitioning is node failure. So if one of the node in the system fails, then what will happen? The data that was mapped to that machine could be lost unless there is a backup strategy which we have thought about it, right? So this is a serious risk when you talk about such of the scenario in a distributed system, because in a distributed system we can have node failures, and if the failure is not handled correctly, your data retrieval is going to fail entirely. So how we can actually make this work? So when you talk about the hash based partitioning, so this works well when firstly you are going to be having a fixed cluster size. So if you have a fixed cluster size, in that case, this one is always going to map to the correct? Same machine only. So if your number of nodes are constant and if it is not changing over the period of time, in that case your hash based partitioning works perfectly. And this is actually used in a lot of big data systems as well, where nodes are static. All right, now we are going to see like what is the another scenario when it will work well. That is the low overhead. So hash-based partitioning, these are actually going to be working faster when we have less overhead as compared to the other methods, because here we are not requiring to maintain some complex directory or some lookup table or some range logic. So in that case, this is going to be working well. Now, if you will see, we actually have a issue which we could not address here, and that is dynamic cluster. Correct? What does it mean? If you have a situation where the number of nodes are going to add or subtract over the period of time, in the real world, if you will say, so when you talk about the cloud environment or the distributed system, in that case, the nodes can actually change over the time. So when you talk about elastic scaling, so what it will do, it is going to be helping you by adding or removing machines as required, so that if you have a high workload, you can add a machine. If you have a less workload, you can remove a machine. So if you have a varying workload, this elastic scaling is going to be working perfectly there. So this flexibility is like, although it is very beneficial for us, but this is going to be making your hash-based partitioning problematic, right? Because like I just explained, it is not at all going to be working fine. So in order to solve this issue, we came up with a concept which we call as consistent partitioning, or you can say consistent hashing. This will make proper sense, right? To solve the issue of dynamic cluster, we introduced consistent hashing. So like, this consistent hashing is a very hot topic right now in the market, and everybody's talking about it. So in the interview also, there could be a possibility that people will be asking you questions on this. All right. So in the consistent hashing, what we do, basically, whenever we have the varying size, like sometimes the size is going to be more, the number of nodes are going to be more or less. If you will have a varying cluster where the number of machines are going to be changing, in that case, your consistent hashing is the perfect solution. So you should be using best when, like, you have to deal with the varying nodes. Okay, so in this one, like, how it is actually going to be working. So here we are going to be making use of something which we call as hash ring. This hash ring is like, your virtual circle. So like, instead of having a fixed set of machines, you are going to be creating your cluster which can have a dynamic size. You can consider that your cluster is a virtual ring or a hash ring, where you can have, like, if required, you can add a machine, or if you require, you can even remove a machine. So accordingly, you can like, consider a scenario. So let us say this is how I have my virtual circle here. So here what I will be doing, I am going to be dividing it out in some range. So I'll say, okay, 0. Here let us say I am having 90. Here I am having 180. Here I am having 270, something like that. Okay. So here what I am doing, I am saying that I am having some, like, what I have done, I have taken a ring, and basically, like, I have highlighted the top points, but inside this also we are having some different points. Accordingly, like, we have split it into some 360 points we have here. And let me highlight these ones. Okay. Now, we can actually say that here we have a range from 0 to 360 degree, right? And here we have decided some significant points like, 0, 90, 180, 270. And there is some division in between, right? Now, let us say that I have a cluster of 4 machines, M1, M2, M3, M4. And all of these are having some IP addresses. Let us say IP1, IP2, IP3, IP4. So this is how these machines are going to be there. So what I will do, I am going to be calculating hash of each machine, right? And how I will be doing, instead of taking data, now I am going to be taking the IP address for that. So if I'll have to calculate the hash, I am going to be using your IP address, and you are going to be doing mod of the same with 360. Okay. Now, when you are going to do the mod, you are going to get the value which is going to be there in the range of 0 to 359. Okay. Now, let's assume that after, for this machine M1, we are getting a hash value of, let us say, 76. For M2, let us say we are getting a hash value of 116. For M3, let us say we are getting a hash value of 249. And for M4, we are getting a hash value 285. Now what I'll have to do, once I have determined the hash values, the next step is going to be defining how the data is going to be distributed across the machines based upon these hash values, right? So if you will see here, like how we are going to be determining. So we will say that any data point which is having a hash value greater than 285 or less than 76, that is going to be assigned to your machine 1. Is that making sense? So basically what we are doing, we are assigning a value, and how we are determining that value. So based upon the hash which we have gotten here. So we are saying for M1, we are going to be taking a range from 285 to 76. So all of that. So basically what this range is actually going to be there from 285 to 360. That point, and 0 to 76. So all of that will go to your machine M1. I have only taken this from the values which we have received here. Okay. Now for your machine M2, how we will be doing? For your machine M2, we have a value 160. Machine 1 is storing values up to 76. So here we are going to have the value from 76 to 160. The next one we will be having for M3. Here we will have value in the range 160 to 249. And for your M4, we are going to be having values in the range 249 to 285. So basically, if you will see, based upon whatever values we have gotten here, we have decided the range, that in which range your data is, if you are having a data in this range, on which machine it is going to go. Correct? So how we are going to be doing? Let me just take this. So after taking this, basically what I am saying, like I'll be just marking all the points which I have, and then I will be displaying the ranges here. Yeah. So the first value which we had, that is 76. The next value which we have, let me also mention here M1. The next value which I had, that is some 160, somewhere here. Now the next machine is having a value 249. So 249 will lie somewhere here. And next we have 285. So that is how we have created different ranges here, and how it will be there. Like how we will say any data which is there in this range. So that will be going to your machine M1. Any data in this range that will go to your machine M2. Any data in this range that will go to your machine M3. Any data in this range that will go to your M4. So that is how we are going to be determining. So when you talk about the same, like, the consistent hashing, so each point of data is mapped to the closest machine based upon its hash value. Now let's take the example that how new data points will be added to the machine. So if a new data point has a value that falls in the range of the existing machine, it will be assigned that value. Like let us say if I am getting something like 74, so I know where it will go, M4, oh sorry, M1, right? That is how it will be there. Now we will be considering the scenario like we are adding a machine. So what will happen, like, what is going to do, like let us say now I am adding another machine M5 which is having an IP address of IP5. Okay, now we will have to see where I will go ahead and add that machine. So now let us say the hash for M5 is, let us say 95. Okay, now what I will have to do, I will have to assign it somewhere. So how I will actually be doing, so this is how our initial partition was there, right? Yeah. So this is how your initial partition was there. Now if I'm adding another machine, which is let us say 95. So where it will be there? Somewhere here. So I have now M5, which is 95. So what I will do, this range is now going to get divided in different way. So previously what we were doing, we were taking all the values between the range 76 to 160 and that was going on your machine M2, right? But here now what will happen after adding this new machine, the data which is there in the range 76 to 95 that will go to your machine M5 and from 95 to 160 that will go on your machine M2. So that is how you are actually going to be splitting it down. So now you are going to be having new range distribution. How the new range distribution will be? So the only change which has occurred is now going to be there. Like, let me take these values so that I can show you where we are accommodating the new change. Yeah. So this is how previously your data was stored. Now if you will see, this change has happened here. So all the values, like, we are actually going to be adding. So we will say that all the value between 76 to 95 that will go to your machine M5. And all the remaining values from your 95 to 160, it will be going on your machine M2. So this is how your new range distribution is going to be there. So like, this is the key advantage of consistent hashing, that whenever a new machine is added, it is only going to be affecting a small subset of data. Only one machine needs to be updated. So like, whatever data, like previously this data was actually there, like the range was actually there in the M2. So we are only affecting that piece of data and we are shifting it to the different machine. So that is how your consistent hashing is going to be working. Now what are the advantages of using this? So the major advantage is minimized data movement. So like I said, here we are not touching the entire data. We are only touching a part of it. So that is why you do not have to move the entire data, just move a fraction of data, reduce, and that is also going to be reducing the cost which you will require for the rebalancing. The next one is your elastic scaling. Like previously, we were not getting the support of elastic scaling in any of the partitioning which we have discussed, but with the help of consistent hashing, you have the option of elastic scaling as well. And the last one which we have is the fault tolerance. So whenever there will be any node failures, only small amount of data needs to be reassigned to the other nodes. That is why your system is actually going to be surviving well, even if you will have any node failure. So that's all we had for your optimization. Now we will be meeting in the next module. Till then, happy learning. Bye-bye. Hello everyone. In this module, we are going to be talking about what are the different ways of improving the performance. So let us say that after we create any application, so the next thing that we will be doing, that is to deploy it to a machine. Okay, now every machine is having a limitation. For example, let's take that we have a machine which can support some 300 queries per second. All right, this means that if 300 concurrent requests are going to come, this machine is going to be able to handle them without having any issue. Now, initially, when we are having let us say when we are having only few customers, like let us say 3 customers, in that case, 300 concurrent requests are more than enough. However, if application is becoming popular and more than this, let us say now we are getting some 1,000 queries per second. So what will happen, like the system which was able to take care these many queries, 300 queries, now it is having a demand of 1,000 queries. So then we will have a problem. This is going to make the system fail if we are not going to address it properly. Now let us assume that you are working for a company. All right. Or let us say you are the owner of some application, because in both of the situation you are going to be taking care about all the problems which you are going to be facing with that system. So let us say now what is happening, your system is struggling to keep up with the load. So how you are going to be feeling? Are you going to feel good about it, or are you going to feel bad about it? Of course, you are going to be feeling good about it, because this is a good problem to have. This is a sign that your application is gaining popularity. That is the reason now we are having a load issue. So, for the startups and all, this is a dream scenario. So now what we should be doing? So in order to address such a problem, we have already discussed a solution, that is scaling. So we can go ahead and apply scaling there, right? So what we can do, we can deploy our we can go ahead and apply horizontal scaling here. And what we can do in such a situation, we can go ahead and deploy it over different machines. This approach we call as horizontal scaling. We have seen that for such a problem, horizontal scaling is the solution. But with this, now we will be having some new set of problems. What are those? So the first problem which we have is IP address management. So customers are actually going to be remembering the IP addresses of all the 4 machines, which is not at all easy. Even if I'm going to ask you, in the real life, if I'll give you four phone numbers, it's not possible for you to remember phone numbers of all the 4 people, right? Similarly, remembering the IP address of all the 4 machines is not easy. Second one is load imbalance. Because if all the customers, let us say they all pick up the same machine, so what will happen, that one machine will get overloaded, and handling the traffic, whatever the traffic we are going to get on that particular machine, that is going to lead to the performance issues. Right? Now, in order to address these problems, we came up with something which we go ahead and call as load balancing. So when we talk about load balancing, like what we do here. So like, when you talk about the customers, they only need to know about this one, load balancer. This is the only single point of contact for the customers. Now what happens, like, when you talk about load balancer here, what happens, we are like, for our different set of machines, we are going to be having a load balancer. And in this one, like, we are actually going to be running it on a separate machine. And that is actually going to be acting as a mediator between the client and the multiple backend machines. So if this is the client, and here we are actually having some set of machines. So instead of the client directly talking to them, they are going to be talking to the load balancer here. And from this, we are going to be interacting with the other set of machines. So here, your load balancer is actually going to be receiving all the incoming requests for the customers, and then it is going to be determining that which backend machine he should be forwarding that request to. And accordingly, when he will get the response, it is going to return it back. So this is the only purpose of the load balancer. What it will be doing, it is trying to be balancing the load. Okay. So with the load balancing, customers are only going to be needing to know the IP address of this load balancer. They do not need to know the IP addresses for remaining machines. Now, let's say we are having some web application. For that web application, we are actually going to be having three components. First, we are going to be having a front end. Then we are going to be having a back end. And then we are going to be having a data storage. These are going to be the different components, right? So what we can do, we can apply the same principle of distribution to each of these components. So what we are going to be doing in since we are going to be having traffic across the different platforms, right? So here we are going to be creating a, instead of having one database, what we will do, we are going to be having a distributed database. Even your backend is going to get divided across several machines. Similarly, your front end can also be distributed across different machines, right? So instead of having all of them at one, what we are going to do, we are going to be distributing them out. Now here, if let us say if you are talking about some of the distributed systems, so whether your resources are going to be located in a single place or if it is across multiple location, it often makes sense to add a load balancer so that we can effectively manage the traffic. A lot of times you are going to be seeing how load balancer is going to be coming into the picture in the distributed system. So here what we will do, let me just squeeze this inside. Yeah. So here we have a user. Now what we are going to do, we are going to have a load balancer before the front end. Then we will have a load balancer before the back end. Then we will have a load balancer before the data storage. So that is how we are going to be doing. We can actually use a load balancer anytime you are having multiple machines. In these situations, your load balancers are typically employed so that it can distribute the load and it can optimize the system performance. The load balancers can be used whenever there is going to be a need to distribute the traffic across multiple machines. Now we now we are going to be discussing about how we can use horizontal scalability here. So let's consider that we have deployed our application on multiple instances. Let us say your instance 1, instance 2, instance 3, instance 4. So these are the 4 instances where we have deployed. Let's take one more instance, 5 as well, for the better understanding. Okay. So by doing this, what we are doing, we are making our application horizontally scalable. Now what we are doing, like, with multiple instances running, we have also made it highly available. It means if one of the instance goes down, it will still be like, let us say your instance 1 is going down. So the others are still going to be up and running. So what is actually going to happen here? This is going to make your system fault tolerant. Okay. However, there is a mistake which we need to address here. So if you talk about the load balancer, so if we will have a single load balancer in the system, what will happen? If load balancer is one single instance, so what does it mean? It means we are going to be having single point of failure. So this load balancer is going to be distributing the load, right? If load balancer goes down, the entire application can become unavailable, right? In order to solve this problem, we came up with a solution which we call as replicated load balancer. So what happens? We are going to be having one active load balancer and one passive load balancer. So what will happen if, like, let us say your active load balancer fails. If this one is not responding, in that case, your passive load balancer is going to take over. So what it will be doing, this is going to be ensuring the high availability. Okay. Now we are going to be discussing what type of load balancers we have. So we typically have two types of load balancer. One is at the hardware level. So your hardware load balancer. The other one is software load balancer. Now, when you talk about hardware load balancers, so these are the physical devices which we use so that we can distribute the traffic. Now, with the hardware load balancer, we have better performance, we have better security, but at the same time, these are going to be more expensive. And these are going to be less flexible. These are very rigid. Okay, on the other side, when you talk about software load balancer, so these are the software. So some solutions on some software level, we are going to be running in order to balance the load. So these are going to be comparatively cheaper and they are going to be offering you the more flexibility. Okay, but they may not be offering the same level of performance. So here performance is also better. On the other side, for the software, the performance is going to be low. Now we are going to be talking about distributed load balancer. So what exactly happens? So when you talk about a complex system, so there we are going to be having thousands of machines. So in that case, your single load balancer is not going to be sufficient. So in that case, you should be using distributed load balancer. So here we are going to be having we are going to be having different layers. So at every layer, we are going to be deploying multiple load balancers so that we can ensure redundancy, and at the same time, we can balance the load across the large number of machines. So in this one, we are going to be having a layered structure where one load balancer is going to be managing the load of other load balancers. So basically, what exactly is going to be happening here? So we are going to be having a load balancer which is going to be taking care of the load of the other load balancers. All right, that is how it is going to be there. And here, what is going to be the best part that, if let us say this is you. So what we are doing, we are having a load balancer here. Now this load balancers are actually going to be taking care of the other load balancers. All right. And this one is going to be connected to several machines. So what is exactly happening here? If you will see, we are having distributed load balancer here. So if you will see exactly what is the benefit of achieving it in this way. So if any of the load balancer goes down, the other one is still going to be up, and that is going to be improving the system fault tolerance. So in such a situation, system is going to be less prone for the failure. Now, what are the key responsibilities of a load balancer? So what a load balancer is going to be doing? So like I said, we have to remember the IP address, right? So what it will do, it is going to be knowing the IP address of all the backend machines. Okay. What is the next one? It is also going to be monitoring the health of each machine. So this is going to see that when you are sending a request, so it is not going to unhealthy servers, because if it will go to unhealthy servers, chances are that they may not receive the request back. The second one is track the load. So it is going to see which load, which machine is actually getting more load. And accordingly, it is going to be sending the request to the other machine. So basically, we are trying to make sure that not one machine is getting overloaded. Okay. The other one is measuring the response time. So we will see when we are sending any request, at that time how much response time it is taking, and how it is helpful, so that if you have some priority task, if you have to some tasks are there which require some quicker response, so we can go ahead and prioritize them. Next one is considering the geographical distance. So what will happen? We will be having different machines, and we will have to see where all those machines are located so that we can optimize the routing. Okay. Also, what it will be doing, it is going to be storing the information about the last client server side communication so that it can ensure consistent routing. Okay. Now we are going to be taking one example, and with the help of that example, I'm going to be explaining you session persistence and sticky load balancing. So let us assume that you work for Amazon. All right. Now let us say that we are having a cart service. And this cart service is actually running on 4 different machines. Your M1, M2, M3, M4. All right. Now let's assume that all the 4 machines are of same size, they have same response time, and they all are performing equally well. Now we have a load balancer in place and we are using round robin algorithm. So what it will be doing, it is going to ensure that it is distributing the load evenly across all the machines. All right. Now let's consider a scenario that your load balancer is directing a request to the machine M1. Now, at that point, what you will do? You are adding 2 items to your cart. So what we have done, we have added some product 1 and product 2 to our cart. Now what will happen? Later, at a later point of time, you want to show these products to your family. Let us say you want to discuss with your family, you want to take their approval before placing the order. However, when you are opening the cart again, then the load balancer is redirecting you to machine M3 because of the round robin algorithm. Since you have added the items on M1 and now you are accessing your cart through M3, you may not be able to see the products which you have added earlier. This problem came because the session information is not stored across all the machines. Your cart data was not stored across all the machines. So there are the multiple ways to solve this problem and we are going to be discussing all of that. Okay. So to address this problem, we are going to be using sticky load balancing. Okay. We also call it as session persistence. So here what happens with sticky load balancing, the load balancer is going to remember that which machine handled the client's last request. So that will ensure that subsequent requests from the same client are routed to the same machine. This way your cart data is going to remain constant across all the requests. So this is going to be solving the problem of losing items in the cart. So you understood what it is doing, like as the name is suggesting, sticky. And what it will do, if you are having different machines, it will remember that, okay, on machine M1, you maintain that cart. And what it will do, if you will have, if this customer is there and if it is making some another request, so it will direct it to the same machine. It will stick to the same machine. So that is how your sticky load balancing works. All right. Now what we will do, we are going to be discussing the weighted load balancing. So when machines will have different configuration, they let us say all the machines are having different RAM or CPU power. In that case, if you are using round robin approach, so that is not going to be the ideal. In that case, you can use weighted load balancing. So what does it mean? Here you are going to be assigning weight to each machine based upon the load. All right. So here what we will be doing, machines which will be having high resources, like machines where, so here what we will be doing, those machines who are having more resources, more RAM, so we are going to be sending more requests to them. Whereas if we have certain machines where we have lower resources, so those ones are going to be handling few requests only. So let us say we have a machine M1 and that has 16 GB RAM. Okay. Next machine M2 that is having 8 GB RAM. Now what will happen, like, let's take one more machine M3, which is having 4 GB RAM. Now what will happen? The load balancer will have to send a request. So what it will be doing, it will be sending more traffic to the M1, less to M2, and comparatively least to the M3 according to their capacities. So that is how it is going to be working. Another optimization technique involves adjusting the load based upon the response time. Now assume that we have 4 machines, M1, M2, M3, M4. And like, let us say we know the performance of each of the machines. So let us say that M1 takes 5 seconds to respond. Your M2 takes 3 seconds. Your M3 take 2 seconds and your M4 take 16 or 12 seconds, anything. Okay. Now we know that the response time of all of the machine. So when a request is routed to M4, so the one which is taking the maximum time, in that case, the load balancer will try to avoid sending requests to M4 again for some time because it knows the response time for that is 12 seconds. So it is not going to send for some time. The load balancer will avoid sending requests to M4 if it will take a lot of time to respond. And it will be prioritizing M1, M2, M3 because they are taking lesser time. So this ensures that the requester doesn't have to keep waiting for a response from the slow machine. So this is very useful for those systems where we actually require real-time performance. So many advanced load balancers not only balance the load, but they also consider the response time or performance of the machine. So based upon this data, the load balancer is going to decide which machine to route a request to. All right, everyone clear? Now, the next one which we have here is your circuit breaker problem. So, like, this is one of the modern feature of the load balancer. So, if a machine is consistently slow or down, so your load balancer will stop sending requests to that machine temporarily. In this, like, if this machine is consistently slow, like we know from a long time it is slow, or if it is down. So what we will do, we will say that don't send a request to this machine. In this pattern, what happens? The load balancer waits for a threshold time. So during that time, it stops sending requests to that problematic machine. After a certain period, it will reattempt sending requests to the machine once it becomes healthy again. This approach helps us to prevent overloading a machine which is underperforming, and we also ensure a smoother performance throughout the system. When you talk about load balancer, so they play a crucial role in scaling a system. So when you scale your system so that it can handle more traffic, a load balancer is very important to ensure we have efficient traffic distribution, and at the same time we are maintaining system health. It improves your system performance and it tries to give the best user experience. All right. Now the next we are going to be seeing that how the load balancer is actually based upon load. So as a load balancer, you are also aware that which machines are under heavy load when we are performing computation. So when the load balancer detects a machine is overloaded, so it will avoid sending requests to that machine for a period of time. Instead, what it will do, it will be routing requests to the other machines that has less load. So that way we can prevent the overloading machine from becoming a problem. So this is one of the advanced feature of the load balancer, that it can intelligently identify which machine is under the high load, and accordingly it can make decisions based upon the information which we have, so that we can optimize our system performance. So this one is actually closely linked to the response time. If a machine has a high response time, we say that this machine is under heavy load. This machine is processing more requests than it can handle, right? So by monitoring response time, the load balancer can predict which machine can be overloaded, and accordingly we can take our decision. All right. After this, we are going to be discussing caching, and we will also see how we can use caching here. Now we are going to be discussing caching. So when you talk about caching, so this can actually improve your application performance. Now, how it is actually going to be doing? So, when you talk about caching, so this is a very powerful technique, but it needs to be used correctly. You can take example of salt. So when you talk about cooking, so if you are going to be adding salt, so you should always be adding it in the right amount. If you are adding it in the right amount, it is going to be enhancing the flavor. But if you are going to add too much, it is going to ruin the dish. So similarly, when you talk about caching, so this can actually boost the performance, but only when we are using it correctly. If we are not using it properly, it can lead to a lot of disasters. So when you are going to do it right, you can improve the performance by 100%. I'll actually take one small example here, okay, so that you can understand it better. So let us say this is me, and I love eating sweets, and there is some sweets shop which is some 10 kilometers from my place. So if I want to eat sweets, I have to travel 30 minutes. Now let us say I'm extremely fond of sweets. So I will go in the morning to buy the sweets. I'll go in the afternoon. I'll go in the evening as well. So I'm every day I'm actually going there 3 times. So you can see 30 minutes to go and come back, 1 hour, 1 hour, 1 hour. So you can see I have actually spent my 3 hours only to get the sweets. So what happened? One day I just got an idea that instead of getting it 3 times in a day, why don't I get it only once in a day? So what I started doing when I'm going in the morning, so at that time I'm getting sweets for the entire day. So this way, if you will see in 1 hour, I am able to get my things done. But I thought that, okay, this is an efficient way. Why can't I save more time? Why can't I make it more efficient? So what I did, I thought of buying weekly. So I thought that instead of spending 1 hour every day, so 7 hours in a week, why don't I reduce that time, and instead of getting every day, why don't I get it only like you know in a week by only getting it only for one day? So what exactly is going to happen? I can save my 6 hours, right? This is what I thought. But here what is happening in that case, your sweets are getting spoiled. So you can see this is what if you are not dealing with caching correctly here. So here also I'm using the concept of caching here. So if you talk about these things here, I'm not able to do it properly. If I'm doing it less, I am spending more time. If I'm doing it more, I am having chances of food getting spoiled. But if I am doing moderately, in that case it is going to work fine. Similar thing happens even with the caching as well. So you should not be overdoing it. You should not be doing it in a less form. So I hope it must be clear to you, right? Now we'll be discussing whenever you have to implement caching, but in all things you should always keep in your mind. So when you talk about caching, right, you always need to keep one thing in your mind, that your cache, you should be doing cache of that data which does not change frequently. So cache data that does not change frequently. Now, what does this mean? Let us say you are caching some piece of data, but if that data keeps moving, keeps updating, in that case, it's not at all worth it, right? Let's take the example of your Instagram feed. So what happens the moment you are going to be opening it, you are going to see some of the posts. What will happen if you will open it after 2 minutes? You are going to see some different set of posts. So that is the data which changes very rapidly, very frequently. So we cannot go ahead and cache that data. But what is that which you can cache? Let's talk about you are playing a movie. For that, the metadata, which is going to be related to that movie, where you are going to be having information like your title, genre, and all. So all of those data, that is something which is not going to get updated. So that is something which is wise for you to cache it, right? So this is something which you should always be avoiding. All right. Also, like, whenever you talk about caching, so you should always be doing it in a moderate way. All right. Now, I'll be taking an example of movie booking system here. So here what is happening, if I talk about a movie metadata, where you have like the cast of the movie, the duration of the movie. If you talk about the release date, if you talk about the genre. So if you talk about this metadata, so all of these things does not change frequently. So this data can be cached in the memory because retrieving it from the database every time a user searches for it can slow down because of the network latency. But for the same thing, if you talk about seats, so if you are booking your seats, so if you, let us say, you want to look at the available seats, so if you talk about the seat availability, you must have seen on the book my show application. So this is how you are going to be seeing, and they are going to be doing something like gray already booked. Then there will be something which is going to show that okay, these are the available seats. So this information is something which will which will change rapidly. So if you are going to be opening after 10 minutes, you may be seeing some different available seats. So do not cache this information, but this one is good to go. So this way, you can see that if you are caching the available seats, so that is not improving the performance. But if you're caching the movie metadata, that is improving the cache, right? Now we are going to be looking into the cache update strategy. So when you talk about the cache update strategy, so one of the strategy which we use for updating our cache is called as your write through cache. All right. So in this strategy, you are going to be having a database for the application, right? Database for your application, what it requires? It requires some stable storage, correct? And we are also going to be using some cache which can store the frequently accessed data. Right? So whenever you will have to write some data, it will first go to the cache. All right. And then it will be written to the database. So first it will go to the cache, and from there it will go to your DB. So this will ensure that your cache and database, they always remain synchronized. You are always having both of these things in sync with each other. All right. So you should always be visualizing it like, if this is you, if you have some data, so what you will be doing, and this is your data storage, which is having a stable storage. So if you want to write, you are always going to go to the cache first. So firstly, it will go to the cache. This is your step one. From cache, it will be going to your data storage. So this is how it will be going. And here we are going to be maintaining synchronization throughout. Okay. Now, what is the advantage of this approach? So, the first advantage of using this approach is firstly, the fresh data. So here, this cache is always going to have the fresh data. It means there is not going to be having any stale data since we are always getting it from the cache. So the chances of having stale data is not at all there, right? The second one is fast reads. Now, when you talk about fast read, so what is going to happen here? The read operations are going to be fast because they are actually coming from the cache. So it is going to be reducing the load on your database. So these are the advantages which we have. Now we will be quickly discussing what are the challenges which we face here. So the first challenge is risk of data loss. So if you talk about here, we are not like, if the data is not properly written to the stable storage, like let us say when it is in cache, there only it is getting lost. So we have the risk of data loss. The second one is limited cache size. So like, let us say that your database storage is actually storing a large amount of data. So like, let us say here we have something like 500 GB storage. On the other side, when you talk about cache, like let us say this is only of 2 GB. Just example. Okay. So here if you will see, only data which can accommodate in 2 GB can only be stored here, right? Because it cannot store even if we have a data of 3 GB. So as a result, we can only store the frequently accessed items here. So that is actually going like, if you talk about the items which are of bigger size, so we are going to be retrieving it from the database, and that is going to result in the uneven performance. So sometimes it is going to be fast, sometimes it is going to be slow, because if you are getting it from cache, it will be fast. If you are getting it from the database, it is going to be slow. So overall, we are going to be having some uneven performance here. All right. The next one is slower writes. So when you talk about writing, here we are saying that we are going to be writing our data to both, first to the cache and then to the database. So because of that, your write operation is going to become slower. So this is a problem for your write intensive application when we are going to be only performing the write. Okay. Now we have already discussed how we are going to be performing in the write through cache. Okay. The next one which we have here is your read through cache. And we will be seeing how your read through cache is going to be working. Okay. So like, when you talk about the read through cache, so here what we will be doing, here your cache is going to be updated during the read operation and not during the write operation. All right. So here what is exactly going to be there? So like, what the flow is exactly going to be there. Like, let us say this is you. And now you have a stable data storage here. And you are having some cache. So let us say you want to write in the database. So what exactly is going to do? You are going to be like, firstly, you are going to be writing it to the cache. Once you have written it to the cache, this cache is going to be writing it to your stable database. Then your database is going to be updating, like, what is exactly happening here. We are like, firstly, here we are performing our write operation. Okay. So when you perform the write operation, it will directly go to the database. So this is what we are doing here. Here your cache is not updated, right? Then the second one is a read operation. So when a read request is made, so the second one I'm talking about the read. So first system is first of all going to go to the cache. There it is going to be checking if the data is available or not. If it is not available, it will go to the database. If it is finding, like, if they are able to find a data, then it is okay. If they are not able to find a data, like, data not found in cache. So that is what we go ahead and call as cache miss. So here if it is not available, what we will be doing, we are going to write it to our cache, And from cache, it will be like, whenever we have to retrieve, we are going to be retrieving it from the cache. So here, if you will see, your cache is going to get updated. So this is basically what we are going to be doing here. Now, what are the advantages of this approach? So the first advantage is fast write. Since here we are directly writing it to our database, so that is going to be a fast operation. The second one is data integrity. So here, since your data is not getting lost because we are writing directly to the database, so we can say your data is going to get maintained. And also, like, this is best when you have write intensive application. So when you are going to be having such applications where you have to perform write operations more, so this is going to be the best one. Now, what are the disadvantages of this approach? So the first disadvantage is slower initial performance. So what happened, like, when you are going to be starting any application, the response time is going to be slow because your cache is not at all built that time. We are going to be retrieving it from the database. So initially it is going to be slower. Also, like, initially your slow operations are going to be, read operations are going to be slow. All right. Also, here we have the risk of stale data. Since here there is always a chance that we are going to be like, since we are reading it from the cache, there is a possibility that if that cache is not being updated correctly, so we can go ahead and read our stale data. So these are the disadvantages which we are going to be facing here. So that's all I had for this module. Now we are going to be meeting in the next one. Till then, happy learning. Bye bye. Hello everyone. In this module, we are going to be learning about NoSQL. So we have already learned about your RDBMS. And if you guys remember, I told you that in the RDBMS, like, we have the two main points with the, like, because of which this RDBMS is still be useful. And what is that? RDBMS works when we have fixed schema. Plus, RDBMS is helpful when we need transaction support. So if we want all the transactions to either complete or fail, like if we want all of the transactions to work in one go, if that is the requirement, in such case, we go ahead and still we will be using RDBMS. So that is the unique selling point for RDBMS. And because of this, like, no matter how many advancements we are making in the technology, no matter how many new databases are coming, still RDBMS continues to be widely used. And especially we are going to be using RDBMS in the banking system. So where we actually need all the active, like, all the transactions to get either completed or rejected. So because of that, we are still going to be using that. Okay. Now, like, if you talk about every company these days, so what they are actually doing, so they are trying to capture the data. Okay. So if you talk about, let's say, LinkedIn, so here what is happening, like, every action which you are taking, let us say you are liking a post, or if you are hovering over a content, or if you're messaging someone, or if you're applying for a job, so everything is getting tracked. This doesn't mean that they want to invade your privacy or they want to share your data with the third parties. But why they are doing? So that they can enhance your user experience by providing the personalized content based upon the interaction. So let us say you are interested in some software developer jobs. So they are going to be firstly collecting the data, and based upon that they are going to be showing you all the job posts which are related to your interest. So, like, when you talk about the companies like LinkedIn, so what they are doing, they are making data driven decision. So in this one, what they do, they collect a vast amount of data, and based upon that data they reply you, so that you will be getting some personalized results. Okay. Even if you talk about Google, so what it is doing, so Google is well known for tracking users all across the various platforms. What it does, it gathers all your information about all the activities, about your preference, about your interaction. Google tracks you everywhere you go, whatever you eat, which photo you have clicked, everything, like the Google has all the information. Even if we talk about banks, so they are also using this tracking. So when you are using a banking application, you may notice that shortly after certain actions, a representative will be calling you so that they can offer you certain loans or credit cards. So this is happening only because they monitor user behavior very closely. So what they do, they track every single click. And because of, they just observe what the user is looking for, and based upon that they are going to be providing the results. And because of all these things, what is exactly happening, since they are collecting all the data, so that is the reason there is going to be a huge amount of data. And that data is that huge that it cannot fit into a single machine. So the major challenge which we faced in the RDBMS is the performance. Your performance degrades when there will be increase in data. So as the data volume will increase, your performance will degrade. RDBMS has started seeing some of the challenges. And because of that, we are going to be having some scalability issues. We are also going to be having uh, like when you talk about the scalability, so what does it mean? So when your data is increasing, at that time your performance is decreasing. And because of that, RDBMS faces scalability issues. All right. So now we will see, and this is one of the biggest problem. Okay. Now we will see why is exactly happening. Okay. So let us say that this is you and you're working for a company like Amazon. Okay. Now in this case, if you will see, sales are constantly occurring, correct? So if you are going to be using RDBMS to store this amount of data, you are actually going to be performing some normalization on that, which will involve creating multiple tables, because every table is going to be representing a single entity. Like we will be having one table for user, one for sales, one for customers, like that. Okay. So if you talk about normalization, so if we have a table, like let us say orders table, so there will be a again, like what is exactly going to be there, that is going to be storing all the values there, right? So like let us say your customer, your manager is coming and they are asking you that, tell me in the last 24 hours, whatever sales has happened on our website, tell me what was the age group of the customers. All right. Based upon that, what you will have to do, first of all you need to gather the data. Like here, if let us say the major tables which you have, we have some sales table, we have some customer table, we have some orders table. So if they are going to be asking you, tell me about the sale which has happened in last 24 hours, what you will have to do, you need to gather the data from all these sources, correct? Now if you talk about 80% of the information whatever we require, in this case that is going to be coming from different tables. So in this case, what you will have to do, you will have to go ahead and apply some join operation, so that you can fetch the data from the multiple tables, join it together and present it to the manager in this case, right? Now when we talk about joins, so joins are expensive and they are slow as well, especially when your data is going to increase more. So in the early days of Amazon, we had less data. So all of these three tables, they could actually fit on a single machine. At that time, when everything was inside inside single machine, So running a query where even if we are involving some join operation, so that was manageable because everything was local. Correct? So there was minimal network latency. But as the data grew, we started distributing it across multiple machines. And then there was also a need to scale all of them together. And for scaling, what we did, we put the orders table on one machine, customer table on one machine, sales table on another machine. Now, whenever we will have to collect some data, we are also going to be involving some network hops because there will be some write queries which we will be needing to fetch the data. And this is going to take time because here we have some not network hops plus some join queries. So this distribution is going to be introducing some network latency, and that is going to slow down the performance. So when your system is going to scale, your performance is also going to suffer. And that is going to make your relational databases less scalable. So this scalability issue is one of the challenge which you are going to be facing with the RDBMS. So now, we'll be discussing what are the two primary scenarios where RDBMS is not the best choice. So when RDBMS is not a good choice. So what is the first scenario which we have? When your schema is dynamic. So let us say you were talking about some product which you have listed on some e-commerce website. So we can have multiple products, and all the multiple products are going to be having different attributes. So here, if let us say we are having attribute like warranty, we are having something like battery life, some power source. On the other side, because this is some electronic. And let us say on the other side, we have some clothing. So for that, we will have attributes like color, size, fabric type, and so on. So if you will see in both of the cases, we have different set of attributes. So if you are working on a project where requirements, if you are working on a project where you are going to be dealing with different set of attributes, in that case, you should not be going ahead with RDBMS. Also, if you have a project where you are in the initial phase, when you are not very clear with what are going to be the requirements, when these are not going to be complete, or if you have some frequently changing requirements, so in those cases as well, you should not go ahead with RDBMS. The second one is when you should not be using, when you have large data volume. So when you talk about large data volume, in that case, your performance issues are going to be there. And because of that, your RDBMS is not suitable. So in such cases, we should be looking for some other alternatives who can actually handle some large data set. So because of that, a new concept was brought to the people, which is so much influenced by the distributed system. And that is what we go ahead and call as NoSQL database. Okay. So when you talk about NoSQL database, it is very much important to understand that a lot of people think that this is opposite of your SQL, but it is not opposite of that. Rather, what we can say, it complements SQL database. What does it mean? It means that if some functionalities are missing in SQL, then NoSQL is going to be completing that. All right. So whenever any new technology comes, then it is always there on the top, correct? So the major issues with the traditional SQL database is rigid schema and the scalability limitation. So when you talk about NoSQL, so that introduced the concept of dynamic schema. All right, what does it mean? Here, if you are having different set of parameters, or if you have some changing requirements, then you can go ahead and make use of NoSQL. Plus, it allows native scaling. Now, what is the meaning of that? It means if you want to scale, then you should not be making any special efforts. It should be able to do it itself. So here, your system is actually built in such a way that it should be able to scale itself. All right. So, if you talk about NoSQL, so it is not a superset of SQL. NoSQL provides you the functionality which are missing in SQL. Now, when you talk about NoSQL, so here we have four major categories, or you can say the NoSQL types. So that is going to be of four types. All right. And based upon what our requirements are there, we are going to be taking up all that, what kind of database to use in that particular scenario. So the first one which we have is your key value database. The second one is your document type database, or you can say document based database. The third one is your columnar database, and the last one is your graph database. Now we are going to be learning about all of them one by one. Plus, I'm going to be taking some of the scenarios where you will be getting a fair understanding that if you are dealing with different situations, then what you should be going ahead and use in those cases. Because here each of the database has its own set of requirements and a set of use cases. And we can only use in the scenario where they are supposed to be used. So they should be used only in those scenarios which suits their strength. Everyone clear? So when you talk about some of the traditional databases like your MySQL, Oracle, so they all are great, but they were not able to scale themselves in effective manner. Also, when when the internet grew, at that time we actually had a lot of data, and it was difficult with the RDBMS that we can fit all of those things in one database, in the relational database. So that is the reason your NoSQL comes into the picture. Now let's discuss what is your key value database. Okay, so this is the first type of NoSQL database, and you might be familiar with the key value pairs from the data structure like dictionaries in the Python. So when you talk about key value database, so this is also very much similar to that. It is going to be storing your data in pairs. Here every date, every entry in this database is going to be having a key and a value. So you always go and structure your data in the pairs. Now, what kind of data it can be storing? So let us say we are talking about some salary component. Okay. So here, like I'll be taking some three people. So let us say there is a person A who is having a salary of 90,000. Then I am having a person B who is having a salary of 41,000. Then I'm having a person C who is having a salary of 1,20,000. So this is how we have three people with three salaries. So in this case, if you are seeing, we are able to organize our data in key value pair. So this is going to be the key and this is going to be the value. So when you can structure your data in key value pairs, so it is a good way to use the key value data structure when you are able to break down your data in that form. Now let's discuss what are the advantages of your key value database. Okay, so the first advantage which we have here is when you talk about the key value database. So these are very simple, right? So here we can say this is very simple. This is easy to implement. Also, when you talk about your key value database, so it is easy to scale. So this is scalable. And one of the most widely used example is Redis. So when you talk about Redis, so why do we go ahead and use this? This is actually well known for how, like, how fast it is. So it is well known for its speed as well as its efficiency. Okay. And when you talk about Redis, so here what we do, here we are going to be having a key value pair. So in this one, generally your key is going to be the string. And when you talk about your value, so value could be any type. So it can actually have any type. It can have some string, integer, JSON object, anything. Okay. Another example is Couchbase DB. So this, like, when you talk about this Couchbase Couchbase mem cached. So here also, like, what we are exactly going to be doing. This is also going to be storing your data in the key value database. So now we will take a look how your key value stores are generally going to be there in the industry. Like I told you, these are the examples, but you should also be able to understand that where from the industry point of view, where you are going to be exactly using it. Like on paper, I can say, okay, we are going to be storing key value, but you should be understanding the use case where it is generally going to be stored. So like, when you talk about key value database, so this is used in 90% of the cases. And we are going to be using this majorly when you want to provide caching. So here, like, this is when you are going to be applying it in the NoSQL world. A lot of people also refer it as distributed caching. So this one is actually going to be helpful because here what I am going to be doing, I am going to be storing all my, like, key value pairs here in the form of, like, here, like, we are going to be logging our data. So we are going to be having some key and some value here, right? So in the key, I am going to be storing something like, button clicked. And in the value, I can store the timestamp. So based upon this, if you will observe, we are able to store it there, right? So whenever you will have to perform caching, you should know that the key value database is something which you are going to be using it there. Plus, it will also provide you the option of native scaling. So whenever required, it is going to be scaling it itself. Okay. Now, the next one which we have here is document-based DB. So when you talk about document-based DB, what we will be exactly going to doing, whatever data we have, that we are going to be storing in the form of JSON. So why, like, what we are going to be doing. So like, let us say we are having some information about, let us say, some person. So how we are going to do? We can store something like ID. So for that person, I'm going to be providing an ID, let us say 123. Then I'm going to be providing another field, let us say name. I am going to be providing a name ABC. After that, if I want to enter age, let us say 40. Then if I want to enter a gender, I am going ahead and entering something like female. So if you will see whatever information we have, how we are storing it in the form of a document. So here, like, what is the biggest example of your document type based DB? That is the MongoDB. So like, this is one of the popular database, although a lot of people are using it. but they still do not know why we are going to be using it. So you should be understanding, whenever you have some information which is there in the form of document, go ahead and store it in MongoDB. Like, once I was taking, like I was actually judging a hackathon, and there are a lot of students who are using MongoDB. And I was just asking them that why are you going ahead with this kind of DB? Instead of knowing the answer, but they said, okay, because it is openly available. But no, if somebody is making this question to you, you should be saying that we are going to prefer MongoDB because here we want to store the information which is there in the form of document. And these documents can be there either in the form of some text, some XML, some JSON, anything, like, and when you talk about this MongoDB, out of all these formats, JSON is the most commonly used format. So you should be knowing that when you talk about JSON, here everything is going to be so much lightweighted, and it is very flexible. Whenever you will have to store data, you just have to store your data in this form. You are not adding any additional metadata here. So if we talk about MongoDB, so this is one of the most widely used document database which is available in the market. Also, like, why this is so famous, that is because it provides support of transaction as well. It provides best of both of the worlds. So, like, it doesn't it doesn't provide 100% support, but it does provide support to some extent, and it provides the push transaction support. So it is not as robust as your traditional database, but still, like, when you talk about MongoDB, so in this one you are going to be getting the advantage that, okay, here you can store dynamic data, and you're also able to provide scalability there. So here you are getting the benefits of RDBMS, some transaction support as well, and you are also getting the benefits of NoSQL world as well. And because of this thing only, a lot of people are going to be preferring it. Okay, now, like, let us say you want to store some information like Aadhaar card. Okay, so that is one of the most common use case where you can go ahead and use MongoDB because of its adaptability structure. So in a JSON document, what you can do, you can go ahead and provide some different fields at the runtime. And when you will be talking about all these records, you should be understanding that the complete JSON object represents a single record. So here, this one is entirely one single record. So that is what is like going to be the major point here when you talk about a document type based ID. So whatever entry you want to do, provide it in the form of JSON, and that is going to be entered there. Okay. So here what we will be having in the JSON, we will have some key value pair, but individual one entry is not going to be in record. The entire JSON file with all the key value pairs are going to be one record there. So that is what your um, document type based ID is going, document based DB is going to be there. Now let's discuss what are the advantages of this. So the first advantage is it provides best of both worlds. Like I discussed, here we are going to be having advantages of both your RDBMS and NoSQL. And because of that, this is a powerful choice for many of the application, and that is the reason this database is one of the hottest in the market right now. The second advantage is since it is using JSON, so it is actually having a lightweight JSON structure. So you are not providing a lot of metadata. Here what we are doing, we are just taking a JSON where only the concrete information is going to be there. So because of that, it will be easy to manipulate our data. It's easy to read our data. It's very light and very easy to use. The third advantage is native scaling. So whenever you will have to scale your data, it is going to be performing it automatically. It provides the support of automatic sharding. So if in the interview anybody is asking you that I want to use a database with the automatic sharding functionality, so you know which one to use, you can go ahead and use MongoDB in such of the cases. All right. Now let's discuss the next database, which is your Columnar database. So like, as the name is saying, so what we are going to be doing here, we are going to be organizing our data column wise. So generally, when we talk about some table, so how we generally do based upon the rows. But this is different from that. So it is different from your traditional databases like the MySQL, Oracle, MongoDB. So instead of organizing it row wise, here we are going to be performing it column wise. And we are generally going to be using it whenever you have some analytical queries. Like, if you have all the data, like let us say it is storing some salary and I am saying that tell me the average salary or tell me the total salary. So if you have to perform some analytics there, you will go ahead and use Columnar DB. Also, whenever you will be having some large data set, because they help us if you are going to be having, like, if you want to go ahead and perform, one second. Yeah. So whenever you have to perform some reading of some specific column, and if you do not want to scan the entire row, if you just want to do it on column basis, so what you will do, you will go ahead and read from there. And like, even if you have to talk about how you are going to be storing it. So like, let us say here you have a table with certain fields, let us say X, Y, Z. So generally, if you ever want to store it, let us say we have some hard disk and here I want to go ahead and store all my data. So how you are actually going to be storing it out? So you are going to be taking this entire row and store it here. You will take this entire row, store it here. Entire column, store it here. So that is how your traditional database is going to be working. But if you have to talk about columnar, so how it is going to be there? If you have a table with these three columns, and if I want to store it in some hard disk, so how I will go ahead and do, I'll take this column and store it here. I'll take this column, store it here. I'll take this column and store it here. So this is how it is going to be there. Instead of storing a row, we are going to be storing it in the form of column. So that is how we are going to be performing it down. And like I said, how it is exactly going to be used. Let us say I have a student table. So there I have something like roll number, name, marks. And what kind of queries I want to do. Let us say I want to get some average marks. So what you can do, you can just take this column and perform average there. So if you are doing it in that form, it is going to be like, even quicker for you. And even in the interviews, people are going to be asking you how you are going to be structuring it out. So you can go ahead and tell that we are going to be taking entire column and store it at one place. People are going to be generally asking you about the structure, like how it is different from the normal database. So you should be knowing that. One of the well-known data structure is Cassandra. Okay, so here what you can actually do, you can run your SQL like queries. You can go ahead and perform some average or some analytics you can perform there. But here you are going to be having the advantage that you are going to be dealing with dynamic data. So here your columns are going to be dynamic. Columns are not at all going to be fixed. Now let's discuss what are the advantages of this database. So like, what is the most primary advantage of this? That this is going to be performing fast aggregation. Since here we are taking one data and we are performing some analytics there. So it is going to be providing you the results in the faster manner. Plus here you are able to group your data. Like, we are taking one column and we are performing grouping there. So this is generally like, majorly it is used when you have to perform some analytical task, like calculating the maximum, calculating the minimum. Like, here I can go ahead and ask, okay, tell me the average marks or tell me the minimum marks, tell me the maximum marks. So if you have such kind of analytics, so it is like a very good approach to go ahead and use columnar database because it makes your aggregation analytics more efficient. Like, when you run your aggregation queries on the traditional database, so the operations can be expensive and it can also be time consuming. On the other side, when you talk about columnar database, so they optimize these queries by grouping values column wise. So here, like, when you execute the aggregation query, the database can quickly fetch all the data from the column. So that is how you can actually get the results in the lesser time. Okay. Now the next database, which is graph database. So, like, even if you guys know how a graph is exactly going to be structured, so kind of similar to that, we are going to be having a graph database as well. So these databases are still evolving, but the question is, why do we need it? So whenever you have some complex relationship, if you want to represent it in the form of a database, you will go ahead and use graph database there. So why it is used to represent complex relationships. So a very good example for this is social media. So if you talk about social media like Instagram or some professional network like LinkedIn, so both are going to be falling in this category only. So when you talk about a social media, you are going to be connected to certain people and those people are going to be connected to others. And that is how we are going to be creating a complex web of relationship. Like this is one person. Now this one is going to be connected to some people here, right? Now these ones are going to be further connected to some people. This can also happen that this person is also connected to this person. Now they can also go ahead and be connected to some different persons. So if you will see, we have some huge data here with us. If you will see, we have a complex web of relationships. Correct. So whenever you are going to be having such a use case, like, further also it is going to be connected. So if you will have such a requirement, you will go ahead and make use of graph database. So whenever you're going to be dealing with huge amount of data, and if it is going to be multi-directional, like I said, this guy can be a friend of this guy can be a friend of this guy. Like, it can actually have a web relationship, multi-directional relationship. So in such case, your traditional database is not at all going to be working. To solve such of the problem, we are going to be making use of graph database. And same, like, if you're talking about this in LinkedIn, so what exactly happens? So if somebody is your direct connection, So we call it as some first degree connection. If they are friend of a friend, we call it as a second degree connection. If there is no direct or if you have some indirect connection, so we call it as third degree connection. So that is how it is going to be there. So like, when you talk about graph database, so this is going to be letting you have such complex relationships to be like, easily represented in real time. Now, when you talk about a graph, how it is exactly going to be there? So if you guys remember, in a graph, we have something which we call as vertices and edges. So this one is going to be your vertices. This is your vertices, right? And if you have to talk about this, like the connection between the node is going to be the edge, right? So when you talk about a graph is going to be having connection of vertices and edges. So when you have to talk about storing a data, so in the vertices, you are going to be representing the entities. So there you are going to be storing some of the entities, like, it could be some person, friend, anything like based upon the use case. And when you talk about edges, so what you are going to be doing in the edges in a database, here you are going to be storing the representation, sorry, the relationship between entities. Like I said, first degree connection, second degree connection. So here if you talk about like, the graph representation, so edges are optional because not necessary, like, let us say you are creating your profile on Instagram, not necessary for you to follow anyone there. You can still be standing there, you can go ahead and search some data in the explore section, right? So not necessary for you to connect to the other person. But if you talk about you, like, you should be having a profile there. So when you talk about the entities, so these are the essentials. All right. So one of the example of your graph-based database is Neo4j. And this is one of the new market leader. So here what exactly happened, like, let's take the example of LinkedIn. So, every individual there is a node, that is the vertex. And when like, one person is going to be sending a connection request, and if they are accepting it, what will happen? That edge is going to get created between them. That edge is actually going to be representing the relationship between them. So now you must be able to understand when to use graph database whenever we will have to handle complex layer of relationship which are difficult for a traditional database to manage. So what you will do, you will go ahead and make use of graph based DB. Okay. Now I'll be taking some of the scenarios so that you can understand that based upon the different requirement, what you should be using there. Okay. So first scenario is something like you are working for a Flipkart product team, and for that you will have to select a database. Okay. So the first one is selecting a database. So if you talk about Flipkart, so here you are going to be working on different products, right? So you will have to decide that what data storage you are going to be picking for all those items in the product hierarchy. Like, let us say we have a product P. Now inside that you can actually have different products. Example, if I talk about the major category, that is mobile. Now inside mobile you can have different kinds of mobiles, right? So before selecting a database, you should be understanding few of the requirements. Okay, what are the requirements here? So the first one could be something like your data must be easily queried. Okay. What could be the another requirement? You should be able to build relationship. Third one could be here when you talk about the products, so they can actually have a dynamic schema. Not necessary always you will have a fixed schema. Even if you guys have noticed when you talk about phones, if you will go to the all the specifications, sometimes you will feel that not all the specifications are same across all the different phones. Some will mention some of the specifications where the other phones might be focusing upon the other set of specifications. So even those set of specifications are going to be different across different phones. Also, one more requirement I am having here, that your system should be able to scale. Now, along with that, here since we are talking about products, so we are also going to be providing some transaction support. So if you will see, these are the basic requirements. Now, for all of these needs, we are going to be making a combination. Since I am saying we are going to be needing a transaction support, so you need, you are going to be needing a combination of RDBMS plus your NoSQL. Correct? So for a solution like this, I told you what is exactly which is going to be working here. MongoDB. Because when we were discussing about MongoDB, I said what MongoDB is exactly going to be doing. It is going to be having a dynamic schema. We are going to be storing it in the form of a document, plus it will provide a transaction support. So when you will be choosing a solution like MongoDB, it is going to be offering you flexibility, scalability, plus support of dynamic schema. So it is going to be a good choice for all those things. Okay. Let's take another example here. Let us say that now you are actually working at the, one second. Yeah, now it is working. Yeah. So let us say that you are working for the business intelligence at Flipkart. So here, if you are going to be joining, like let us say you're joining the Flipkart business intelligence team. So here at the end of the day, you will actually have to generate a sales report, right? So here in this one, what you will have to do, in this particular one, some things you are going to be doing it for the daily sale. You are going to be ensuring all these things. For the daily sales, we are going to be tracking out how it is exactly going to be happening for your daily sales, for your monthly sales, for the annual sale. So this is what we are going to be monitoring there. Okay. Now let us say they are having something like big billion sale. So when you talk about big billion sales, so here we are going to be having lots of orders, right? And that is actually going to be resulting into huge amount of data. Correct? In that case, they will have to deal with such a huge amount of data, and they want to get some insights out of that data. Okay, and in order to manage this data, they have to derive some of the they are actually going to be determining that okay, if we are having a sale, So what is getting mostly selling from our website? Is it some electronics or some apparels? And what age group people are preferring that, so that they can actually go ahead and plan it for their upcoming sale. So if you guys remember, I told you in such a case, what is exactly going to be helpful? We are going to be making use of Cassandra here. Why? Because this one is actually going to be helping you when you will have to handle large amount of data. So if such is thing is going to be required, at the same time, if you are also looking for some performance, so Cassandra is the best choice. Now I'm going to be giving you different situations so that you can understand that based upon the scenario, which database you should be using. Okay. So let's discuss your scenario one. So in this scenario, let us say that we have large data set and on that we have to perform some analytics. So for your scenario one, if you have analytical use case for large data set. So what you should be doing in this case, we are going to be running aggregation. Run aggregation on large data sets. Correct? And for such a case, what we should be using, we have already discussed, right? So we are going to be making use of Columnar database. So in this one, we can make use of something like Cassandra or Amazon Redshift. So these are optimized for the analytical queries. So these are the best one for the analytical queries, and here you can run aggregation on the large set. So they also allow you for the faster read times for the columns, and that is why this is ideal for such of the use case. Okay. Now let's consider another scenario. So let us say we want to perform caching and we are also in taking care of the performance. So the use case is performance optimization for caching. So here, what is exactly happening? Okay, so let us say your system performance is slowing down and you want to implement caching so that you can improve it. So which NoSQL database you are going to be considering? If you guys remember, I told you whenever you have to perform caching, the moment this word is going to coming into your mind, you should know what database to use here. So we are going to be making use of key value based database. Okay, for this one you can make use of either Redis or memcached based DB. All right, these ones are efficient whenever you will have to perform caching because they can easily retrieve the values based upon the unique keys, and because of this they can also help you in improving the system performance. Let's consider another scenario. So let us say we want to perform scaling, and that is beyond your relational database. So if this is your use case, let us say you are working with relational database, but you are facing some scalability issue. And that is because you are experiencing some high volume data. So you want to transition from relational database to NoSQL. So what is going to be the best opinion in this case? So the best option is going to be the document based DB. And in this one, what is going to be the best solution? You can make use of MongoDB or couch-based DB. So here what we are going to be doing, like what these databases are going to be offering. So they are going to be offering you flexibility. Here you can go ahead and handle large data sets. At the same time, here you are also going to be getting the option of native scaling. So if these are the use cases, you know which database to use there. Now let's consider one more scenario. So let us say that you have some complex relationship. So if you want to manage complex relationship, and here you're also having some large data. So I told you in this case, what is going to be the first one, since here you are dealing with the large database, plus you are having something which is complex database. And this one, you know, you cannot manage by a traditional RDBMS. So what is going to be the database which you will use here? So the first most is going to be the graph-based DB. And is this one, what is going to be the solution? That is going to be your Neo4j. So these ones are actually handled whenever you have to deal with the complex data, complex relationships. Okay. Also here, basically here what is going to be there? We are going to be making use of graph where we will be having a node and you're going to be having a vertex. So with the node, we are going to be representing our entities, and with the vertex, we are going to be representing the relationship between them. So these are ideal for the applications like social networks, or sometimes if you are designing something like recommendation engine. So here you are going to be recommending that, okay, for this, these are the recommendation, for this, these are the recommendations. So that is how you're going to be having a complex relationship. So with the help of this, you must be able to understand that based upon the scenario, what kind of database to prefer. So that's all I had for the NoSQL databases. Now in the next one, we are going to be discussing a case study. Okay. So till then, happy learning guys, and I will be meeting you in the next module. So bye-bye. Hello everyone. So in this module, we are going to be discussing two case studies which are going to be helping you so that whenever there will be any question in the system design round, you will be able to answer it. So first of all, we are going to be seeing how can we design a chatting app. So when you talk about chatting, what kind of application I'm actually targeting here. So if I want to interact with my friends, if I want to talk to them, if I want to send messages to them, to my friends or acquaintances, anyone. So in that case, I am going to be needing a chatting application. So this is the question which is going to be coming to you in the interview. So just put yourself in the interview scenario. So assume that you are sitting in an interview and somebody is asking you this question. So as soon as chatting application is thrown to you, then you tell me what are the different applications that are going to be coming in your mind. So when you talk about chatting application, so what and all we are going to be having. So it can be something like WhatsApp. It can be something like Viber, right? It can be something like Messenger. It can be something like Instagram DM. And we even have Telegram. So we use in many other applications. So we use all of these applications so that we can able to send a message. Okay. So when anyone is going to be given you this question that you have to design a chatting application, so these are the names which will start flashing in your brain. So you should be thinking what we should be doing next. So how I should be proceeding with this, what should I do, what should be the ideal thing, what we should be doing here. So should I start designing, what should I do? So before anything we need to figure out what actually the interviewer intends us to build. So whatever he wants to build, we are going to be proceeding in that direction. So we will have to check them that are you looking for something like WhatsApp, or you just want to make an application like Messenger. Since both are chatting application, but there is a slight difference between both of them. And what is that difference? When you talk about WhatsApp, so that is always attached to a device. Everything is going to be stored on your local machine, your local mobile. On the other side, when you talk about Messenger, so that is a web-based application. It is not attached to your device. You can access it from multiple devices. So, why I'm actually telling you about this segregation, because whether I am building WhatsApp or whether I'm building Messenger, my whole design of storing messages is going to be changing. So, if it is WhatsApp, I will focus on storing everything on the local device. But if it is a Messenger, then I would like to store it on a central server. So when somebody will ask you that, okay, you have to design a chatting application, so you should be thinking based upon the experience of using different kinds of chat applications. You should think about it that what is the difference between them, and also you need to make sure that what kind of chatting application they want you to create. Should it be a WhatsApp or should it be a Messenger? And then your interviewer will think, okay, this person is thinking beyond what I have given. So let us say he wants you to design a WhatsApp. So the very first step which you will have to do is to get the clarity on problem statement. All right, so you will have to gather the requirements accordingly. If you guys remember, I told you the first step is always going to be requirement gathering. All right, so you need to see what are going to be the we will be having different kinds of requirements. We will have some functional requirements and some non-functional requirements. So we can start with the functional requirements. Okay. So when you talk about functional requirements, so these are those set of requirements which will always define the functionality for which the customer is waiting. If you are going to do these functionalities, then the customer is going to get happy. So when you talk about functional requirements, so these are the actual functionality for which customers are waiting. So when you talk about a chatting application, so what should be the first functional requirement? That a person should be able to send a message to the another person. All right. What could be the another functional requirement? So that is like if you are sending a message and if the person is offline, so the message should not get lost, right? All right. What should be the another functional requirement? That I should be able to know who all are online. So what could be the next functional requirement? That I should be able to get all the pending messages when I get online. What does it mean? If you are offline, other persons must be sending you some messages, right? So if you are going online, so you should get pending messages. What could be the another functional requirement? That if you want, you should be able to share media. So you should be able to share media, you should be able to send a location, you should be able to send a contact. Also, like, if somebody is misbehaving with you, and if you want, you should be able to block a user. What else could be the functional requirement? Like if you are sending a message, in that case, your message encryption should be there. So you should be getting privacy and message encryption. What else can be there? You should be able to get, you should be able to create groups. You should be able to send messages in that group. So should be able to create groups. Should be able to send messages in groups. So like, we can actually have even more than these functional requirements, but these are some basic requirements which we are going to be having, right? So like, first of all, you should be just listing down what could be the functional requirements, and the another one is going to be the non-functional requirements. So after we have seen the functional requirements, the next we are going to be discussing that what are the non-functional requirements for this kind of application. So, but like, when you talk about the non-functional requirements, so here we are going to be discussing those concepts which we have discussed as a part of your system design. So, what could be the non-functional requirement here? Like, if two-person are online and if you are chatting with a person, so if you send a message, then you will like a message that, okay, if I'm sending somebody a message. So what I was exactly trying to say that if this is a user A, if this is a user B, and if they are sending messages to each other, what we would be liking that they should be able to send messages in real time. All right. So that is something which we should always be considering. So if you talk about like, here how the interface is exactly going to be there. So you are going to be having some screen like this where you are going to be seeing some old chats. There you will be having a text box and then you will have a send button. So what you will expect the moment you are clicking on the send button, you will expect that the message will get sent at that time, and you should also like, the other person should also be like, that when the other person is exactly going to be seeing that message, so he should be able to see that message at the same time. So of course there is going to be a delta of t. So what is delta t here? So let us say you have sent a message at some timestamp, like, let us say 8 4, and let us say here you have sent it at 5 milliseconds. Okay. So if this is the sending time, what you will be expecting that it should get delivered around the same time. So if it is getting delivered at this time, so that is still going to be okay. If it is even taking like, let us say 2 seconds, that is also okay. So what we try that this delta in t, this should be as less as possible. So what we expect that your message should be sent on real time, and you will also expect that it should get delivered on time and faster. right? So this is what our expectation is going to be there from a chatting application. Now, what the next thing which we are going to be expecting out of it? So like, we have something which we call as cap theorem. So here, like, you should be considering it something like a triangle. So C means consistency. A means availability. And P means partition tolerance. So if you are going to be understanding this cap theorem from the theory perspective, so what they will say, they are going to say that out of these three things, you should be able to achieve only two at a time in any of the applications. So they say either you can achieve CA or you can achieve AP or you can achieve CP. So these two things, like, either you can achieve consistency and availability, or you can achieve consistency and partition tolerance, or you can achieve availability and partition tolerance. So this is what this theorem says from the theory perspective. But if you are going to be considering it from the practical perspective, so we say that partition tolerance should be there. Apart from that, based upon the requirement, you are going to be determining if you are going to need consistency or availability. What does it mean? So when you talk about the partition tolerance, so it means if for any reason your system goes down, in that case, your system should be, like, designed in a way that if any fault is coming, so it should be able to tolerate it. And how we can achieve it? We can maintain duplicate data. We can have some replication factor. So generally, we create copies of our data, and by maintaining copies, we ensure that if because of any reason, if one of our node goes down, since your system should be up and running. Now there is consistency and availability. So consistency means, like, you talk about banking application. So if you are sending somebody some money, so what you will want before sending the money and after sending the money, it should be consistent, correct? Like no other changes should be there. But when you talk about availability, so that means the application should be available for you. So like, let me take some quick example. If I talk about WhatsApp, so what I'll expect out of WhatsApp, that it should be available. So like, that is something which should be there, because if your application is not up, you are not going to be okay with that, right? So when you talk about WhatsApp, so the two things which you are going to be having is going to be your partition tolerance and A. So these two things should be there. Like, I'll take one more example here. Let's talk about IRCTC. So for that, you should be having partition tolerance and consistency, because if you are booking a ticket now, even after 2 hours, if you are logging in, you will still expect that ticket to be booked. That seat should be allocated to you. So that is how it is going to be working. So this is your non-functional requirement. Other one is, if you have some low bandwidth, you should still be able to make it work. So should work on low bandwidth. Also, like, if tomorrow you are getting some load on that device, so you should be able to scale it. Should be scalable. Also, when you talk about resources, so it should take less resources. We can actually have more than this requirements as well, but what I have done, I have came up with some initial set of requirements for both your functional ways and the non-functional ways. So once, like, once your requirement thing is freezed, once you have decided, so what the next thing is going to be there, you are going to talk to your interviewer that what he is targeting in the next 30 minutes. Because if you talk about it practically, it's not at all possible that you can go ahead and proceed with all the requirements in the stipulated way. So what is the best thing, that you go ahead and ask him that, okay, tell me what and all things he wants you to perform. So that step we call as scoping. So decide which requirement to implement. Make sense? Now, once you have once you have scoped down, so what you are going to be doing, you will go ahead and you are going to perform implementation for that. And when you talk about implementation, you are going to be using all the concepts of your low level design. So here you are going to be using your design principles. You're going to be using the design pattern. Okay, so these are the things which are going to be there. So when you talk about the system design round, so this is just a reflection how when you're going to be working in any industry, so how things are actually going to be working there. So whenever you will have to implement anything, you are going to be first of all doing the requirement analysis. Then you are going to scope out the phases, that what and all we are going to be delivering in which quarter. And after that, we are going to see that we are going to perform some computation also there. So in the compute, we are going to be seeing how much data we are having, and based upon that we will plan how we are going to go ahead and store it. At the same time, we are also going to see that if you are going to be performing some computation on your data, so how you are going to perform estimation. Actually, this estimation you do even before implementation. So that is how it is going to be there. In this one, you are going to be seeing that how much RAM you are going to be needing. So here we are actually going to be talking about how much bandwidth you are going to be using in your application. So basically here what we do the infrastructure estimation on high level. So when you talk about infrastructure estimation, so the first thing what we are going to be considering here, that now we are going to be talking about this infrastructure estimation on a broader level. All right. So when we talk about the infrastructure estimation, so here the first thing which we will have to focus upon is when you talk about any application, so when that is actually going to break down, or when that application is going to boil down, so all of that thing depends upon the total number of users who are actually going to be using that application. So when you talk about WhatsApp, so there are going to be plenty of users all across the world, right? So let's say that we have some 2 billion users. Now, it can happen that not every user of WhatsApp is going to be sending messages every day. So let us say that we have 50% active users only. All right. So let us say that they are actually sending some average messages per day. So if you talk about 50% active users, so you can say that it is actually approximately going to be 1 billion. So let us say active users are actually sending some average of 10 messages per day. Like I'm just taking some rough figures, okay? Even in the interviews, you will have to take some rough figures only in order to explain the concept, because they see how well you are able to understand the problem and able to resolve it. It doesn't matter what figures you are taking there, okay? So if you are average, on an average, you are sending 10 messages. So how many total messages you are going to be having per day? That is going to be some 10 billion, right? Now we have to consider the size of each message. So let us say that size of one message is, let us say, some 100 bytes. Okay, if we are sending 10 billion messages, so how many total size we are going to be needing? That is going to be 10 billion into 100 bytes, correct? Now, if you talk about 1 GB, So how many bytes 1 GB is going to be having? So that is going to be having roughly 1 billion bytes. So if you talk about the same here, so we can go ahead and convert this total bytes into GB as well, right? Because here if you will see, what do we have? 10 power 3 billion bytes, right? So similarly, if you talk about this case, so what we are going to be having, if you talk about this amount of data, so how much it is, like, roughly how much data we are having here? So 10 terabytes of data, and this data we are actually going to be needing every day. I have actually taken an approximated value. Okay, you can go ahead and compute it. So you can see that this much amount of data we are actually storing in a day. And like, when we talk about storing our data, so it is incrementally stored. It is actually going to be stored in the server for 3 months. So like, when you talk about your storage part here, so we are going to be storing that data for 3 months. So if you talk about the total size, how it is going to be there. So here we are talking about 1 TB, and then we are saying we are going to be needing it for 3 months. So how much it is going to be? 1 TB into 3 into 30 days. Correct. So we are going to be needing some 90 TB of data. Correct. So this much data we are going to be needing for 3 months. Now, if you talk about this data, this is too huge, right? So I'll have to consider something. I definitely cannot store this in a single machine, right? Because this is 90 TB of data, right? And at any point of time, like, this, like when you talk about any data storage, so that should not be actually taking 70 more than 75% of the capacity, because if it is going to consume more than that, in that case what will happen? Your performance is going to get impacted. So how much data we are actually going to be needing? So 75% of x, here we are going to be having 90 TB. So this is how we are going to be computing. So what does it mean? You should be actually having a size of 120 TB. Like, this much of data should be there. Then only you are going to be able to store 90 TB of data on that. All right. So like, let's talk about, I have 1000 GB per day. So what does it mean? How much I am actually data I'm exactly going to be having? So you will have some 1000 uh, GB of data. You are going to be needing it for 1 day. Now, if I have to convert it into second, how much it is going to be there? So 25 into 60 and 60. So this is going to be GB per second. Roughly, you are going to be getting like 0.01 GB per second. Now what you can do, like, you can actually convert it into some MB. So you can actually have something like 11 Mbps. So this is the data, like, if I'll have to design a system, so it should be able to have a read and write operation at the speed of 11 Mbps. Okay, so it should be able to provide the throughput of 11 Mbps. If you talk about the read traffic, so that should also be equal to 11 Mbps. So what I have done here, I have performed some computation, and we have realized that in my system we cannot keep it at one place. So what are we are going to be doing? We are going to be preferring distributed system. So we are going to distribute it across different machines. So like, this is how you should be able to perform the estimations on the high level design, that okay, if this much amount of data I'm going to be having, I can definitely cannot keep it on one machine. You are going to be putting it on different machines. Now the next one which we will cover is, like, if you are getting some question like design TikTok, or if they will ask you that you design some Instagram reels, or YouTube shorts. So let us say this is what is the question. So the first thing you need to understand that what is the application. What is TikTok? Like if let us say you do not know what is that application, so you should always be checking with the interviewer that, okay, could you please tell me what this application is, what this application does, so that you will have the fair understanding across how you should be answering to that particular problem. So here, when you talk about TikTok, so what TikTok is? So this is the place where people like me or like you can either upload the video or view the video. All right. So now, if you have to talk about designing the same. So I told you the first step which you should be doing here is to gather the requirements. You should be able to know that what and all are the requirements, and you should be checking it with your interviewer that out of these requirements, what do you want me to implement? Okay. So when you talk about requirements, we have two types of requirements. You have functional requirements and the non-functional requirements. So let's see what are the functional requirements for this. So the first functional requirement is going to be that user should be able to upload the video. The other one is a user should be able to view the video. What the other one could be that a user should be able to search the creators. Like, we are going to be like having certain creators, or you can say that we have going to be having certain profiles and we should be able to search them, so that if we like it, we can go ahead and follow their videos. So able to search the creators. What else? We should be able to be filter out the videos who are not following the guidelines. Like we have the option of reporting a user. So here you can put report user. Okay. What else could be there? If there are if you want to upload a video, before that, if you want to edit it, so you should be able to edit the video. Other one could be like if there is some trending video, so you should be able to see what and all are the trending videos. You must have seen when you talk about YouTube, so there you have some option of trending videos. So similarly here also you should be able to display the trending videos. Apart from that, you should be able to like and subscribe the video. So you should be able to like and comment the video, and uh, the user should be able to subscribe the user. So here I have listed down some of the functional requirements. Like I said, from all these requirements, we need to first of all see that when you will be having system design round, you will be getting some 40 to 45 minutes. So from all of these requirements, we need to first of all see that in next 40 to 45 minutes, you are going to be explaining one of these problems. So you should not be assuming that I should be able to answer each and everything here. Instead, you should be discussing with the interviewer that what and all things you should be presenting it out, what and all things you should be considering. And that is what we call as scoping. So you should be scoping down what and all requirements you are going to be implementing. Okay. So first I'm scoping it down. Later we will also be seeing what and all are the non-functional requirements for the same. So out of this, let us say that I am going to be implementing the ability to upload the video. The other one, like, out of these requirements, like let us say I should be able to watch the video. So you are going to be implementing this. Now, what else we should be doing here? Like, let us say I want to have the option of reporting the user, because if you're not liking somebody's video, you should be able to report the user. Apart from that, let us say you are thinking that let me implement this part to like and comment the video. So what you have done, firstly, you have listed down your functional requirements, and then you have scoped down that out of these requirements, what and all you are going to be implementing. Correct? Now let's also see what are going to be the non-functional requirements. So let us say the first non-functional requirement which I want here is going to be the scalability. So what I mean by scalability here is that if I am able to use this application today, then I should also be able to use this application from after 6 months. Even if you talk about 2 years, if we are able to use the requirement today, so I want that even after 6 months I should be able to use it. Even after uh, 1 year I should be able to use it, and so on. So what I'm trying to say that my performance here, whatever the performance which I'm getting here today, so that should be equal to the performance which I'm getting after 6 months. Similarly, even if I'm going to be using it after 1 year. So overall, what I want that I should be able to maintain its performance no matter at what point of time I am using it. Okay. The next one, if you guys remember the cap theorem. So like I said, partition tolerance is going to be there. But apart from that, what is the next thing which I would want from this application? As a user, what I will want, I want some entertainment. And if I want some entertainment, if I want to spend my time somewhere, I would like that application should be available. I'll not be okay if I'm opening the application and it says come after 2 hours, correct? Or we are down in this and that time period. So this is something which I'm not going to be preferring for such kind of application. So we should be considering availability and partition tolerance. So here we are talking about availability and partition tolerance. So whenever we design any of these applications, so you should always be maintaining a discussion that out of that app, what you are looking for. Are you looking for consistency or are you looking for availability? So based upon the application, we are going to be making that call. It's not that all the applications should be available. Of course, as a user, we would want all the applications should be available at all the time, but we should be looking at the use case of that application. If you talk about some banking applications, so if you talk about some banking applications or some booking applications, like let us say the checkout page of Amazon or any other e-commerce website or any other place. So all of those things I would like consistent. If I'm placing some order today, tomorrow I do not want that order is not available. Correct? I would want to be able to see all of those things. So based upon the application, you are going to be taking a call that what are you going to be expecting out of it. All right. Now we are going to be looking into the next non-functional requirement, and that is going to be the security. So when you talk about any application, so what is that which you would want? That none of the hacker should be able to hack the system and compromise account of all of the users, because if any such thing is happening, people are not at all going to be trusting those platforms, and if they are not going to trust those platforms, they are not at all going to be using them. Understand? Because when you talk about any of these platforms, like you talk about Instagram, YouTube, or anything, so there people are uploading their faces, so they are not going to be okay that their videos are getting misused or their data is getting stolen from there. So all of those things nobody is going to be expecting. So whenever you design such an application, security should be your utmost priority. Also, what you would be wanting, like, of course, whenever we are going to be designing any of the application, we would want it to work even on low network bandwidth. If some application is going to be demanding you to use it only on high speed, then it will be actually gathering, it is going to be gathering less number of users, because a lot of people are actually staying in different regions. Sometimes they are traveling. So considering all of those things, we should be coming up with those applications. Those can work even in the low internet conditions. In that case, they can gather more users across the time. Correct? The next one is, if you are designing any of the application, so you should be able to use it across different operating system. Now, a lot of you can actually think that when I am talking operating system, then it should be only depending upon the laptop. But no, when I'm talking about operating system, so it could be like, it could be even on the mobile as well as on the laptop. So on the laptop, if you are using, let us say, Mac or Windows or Linux, it should be working on all of those operating system. Similarly, if you're using a mobile phone, so let us say it is a Windows phone or Android phone or iPhone, any of the phones, you would be preferring that on all of the operating systems it is working fine. Otherwise, it is not going to gain a lot of users. If some application is going to become operating system specific, then you cannot actually have a global presence, because not everyone is going to be upgrading their operating system just because they want to use some application, right? So whenever we target a bigger user base, we should always be considering that it should be able to work on different operating system. Now, the next one is latency should be low. Now, what does it mean? So, like, let us say you have seen a video, like, let us say somebody is sending you some video link, or you are seeing some video link, like, if you will opening some of the website, like some YouTube shorts or not. So, initially, you're going to be seeing some of the thumbnails. So, once you have seen some of the thumbnails, what you will do? You will click on it, and then it is going to be taking some time to play that video. So that particular time here, we are referring that as latency. So whenever any such thing is going to happen, in that case, we would be preferring that it should take lesser time. So when you talk about latency here, so that should be as less as possible. Okay. So if you want to improve this latency, what you will have to do, you will have to do multiple things. so that you can solve this latency problem. So one of that problem can be solved by improving the network. And there will be other strategies also that we need to do in order to keep this latency high. Everyone clear? So I have just listed down few of the non-functional requirements. Of course, there are going to be many, but I have only considered few here. All right. Now let's talk about the application feed, how the timeline is generated. So by the timeline, what I mean that when you are going to open the page, so what you should be seeing there, when you will see video 1 first, then what should happen? The video 2 link should be there, right? If you talk about Instagram reels or anything, so what happens if this is your feed page, if some video is playing, let us say video 1, what generally happen after that, you have the option of scrolling it, and then your video 2 will get played. Basically that is what is happening, right? And this is non-stop, so that is what people do, they just scroll there. Also, when you are going to close that application, when you are again going to be using this app again, so you would like that the video you have seen, after this, whenever you're going to be resuming, let us say you have left it on video 4, so when you are minimizing and resuming, you would want video 4, or let us say the application doesn't storing this information, they will just open some other video, let us say some VN, some other video is getting opened. All right. So what I'm explaining here is that whenever you will be opening that application, you are going to be seeing some interface. So how that is going to be designed. Also, if you talk about some individual users, so they are actually going to be seeing a lot of videos over a period of time. So how those videos are going to get fetched. So based up, and if you will see that, okay, I'll tell you, the Instagram, if you are seeing a lot of uh, cooking related videos, so after a while, even if you will see some 2 or 3 cooking related video, then they will start suggesting you new videos. So here what we are making use of, we are making use of recommendation system. And what this one is going to do, this one is going to be suggesting videos, right? So if you are going to be creating such platform, you are going to be having a recommendation system there. This recommendation system is going to be built through various ways. You can either do it with the help of machine learning, or you can do it by applying some kind of statistical analysis. So basically you are just trying to see that there should be a way through which you can suggest some video to the user. All right, everyone clear? So this is something which we should be implementing here. Now, the next thing which we need to do here is we should make sure that we are ready with the infrastructure so that we can bring our TikTok to production. Because once my application is ready, I need to bring it to the live, right? And for doing that, I will be needing some kind of estimation that what are the factors I need, how much storage I will be needing, how much compute will I need, how much network bandwidth I will need. So I'm going to be focusing on all of these stuff. So for this, every time you will be sitting in the industry when you will be working. So for all these estimation, you are going to be sitting with your team members. You are going to be deciding that how many machines you are going to be acquiring, how much storage, how much database, how much machines that you are actually going to be needing in order to implement the same. So you are going to be performing all of these calculations. Similarly, when you are approaching to any company interviewer, you are going to demonstrate that same with your interviewer. To that guy, you are going to be making these questions that, okay, this is what I am estimating. You let me know what are your inputs on that. So you will initially you will have to come up with complete numbers so that you can actually put it in front of that interviewer. So for that, you are going to be estimating the total load. Yeah, so you will have to estimate the total storage. You will have to estimate the total read traffic, the total write traffic on that application. So first of all, let us say that how many total number of users you are going to be having. So let us say the total number of users are, let us say 1 billion. And now let us say that, even if everyone is going to be installing that application, they are going to be registering for that application, but not everyone is going to be actively using it. So let us say that 50% of users are active. All right. So what does it mean? That you are roughly going to be having 0.5 billion users. And after this, you will have to see that when you talk about users, so what kind of users you are going to be having. So we are broadly going to be having two type of users. So the first one is going to be your content creators, and the second one is going to be the content consumers. So if you will see today, a lot of influencers are there, and they broadly come in the category of content creators because they are creating the content which we are consuming. So we are the content consumers. Okay. Now, one more thing is there. The number of content creators are going to be less than the total number of people who are watching the video. All right. Let's talk about Instagram. Of course, we have a lot of influencers there. We have a lot of content creators are there. And this content is getting created in different areas. Some people are actually creating some fashion related content. Some are creating cooking related and whatnot. But even if you will see, the ratio is still going to be different. We will be having more content consumers and less content creators. So let us say the ratio between content creators versus content consumers is, let us say, 1 is to 100. So for every 100 content consumers, we are going to be having one content creator. For every 100 person who are interested in watching that Instagram reel or the TikTok video, there is going to be one person who is actually creating that content for you. So now we will determine how many total number of content creators will be. So like I said, how many total users we have? 5 billion, 0.5 billion, right? And after this, I'm saying for one, we are having we have this 1 is to 100 ratio, right? So this is roughly going to be bringing to a 5 into 10 power minus 3 billion, right? So why I am interested in the content creator count? So I am looking at this number, because when you talk about the same question in the interview, so everything, whatever you are going to be doing, everything is going to depend upon your interviewer, what that guy is going to be asking. So that is the reason I'm also considering this content creator, because why we actually need them, that is because these are the guys who will actually upload the video. So if you talk about the read write rate, so that is something which you are going to be getting through these content creators only. Being a consumer, you are only reading, but if you talk about the writing part, so these content creators are basically going to be writing down there. Correct? So let us say that we have to consider that some creators are going to be creating videos, right? So let us say that on an average, videos which are getting created per day. So let us say we are having 10 videos in a day. Now, some creators, I'm not exactly taking a proper count, but it could be anything. Some people can actually be creating more videos, some creators can be creating less videos, but I'm taking only the average count here. And we're also going to be considering duration of each video. For these reels and all, we are getting a time of 60 seconds. So on an average, we can say that every creator creates one video, like, 1 minute video, right? So let us say that for all of this, let us say how much total size is going to be there. So let us say that average size, I'm just assuming, okay? So the average size of one video, let us say that is 1 MB. So how much total storage we are going to be needing? So the total storage is going to become 5 into 10 power minus 3 into 1 MB. So this is the size, and here actually we have billion. So this is the size which we are going to be needing, correct? So if you talk about this 1 MB, you can also convert it into bytes. So this will be becoming, correct? And if you have to talk about 1 GB, so 1 GB is approximately equal to 1 billion bytes, correct? So what we will be doing, we can say that this is roughly equal to your 5 into 10 power 3 GB per day. So this is your 5000 GB per day. And if you have to convert it into TB, so this is going to be roughly becoming 5 TB per day. So this is the total amount of data which we are creating per day. And if you talk about this data, 5 TB, this is a huge amount of data. So every day I will be needing 5 TB of data. So for that, if you will have to see that how much space you will require after 2 years. Because when you talk about scalability, what we want, this application should be able to run after 6 months, after 2 years. Like whenever you are going to be looking at it, you should be able to use it properly, right? So how much storage we are going to be needing? If I'm saying it requires 5 TB of data in a year, we have 365 days. And if you're talking about 2 years, so you are going to be multiplying it by 2. So this is going to be like, 5 into 2 is 10. So it is going to be equal to 3650. So you can just convert it to petabytes. So this is going to be 3.65 petabytes. So this is the amount of data which we are going to be storing in 2 years from now. If you talk about 3.5 petabytes of data, so this is a huge data itself. Now, what I mentioned in one of my non-functional requirement, that it should be fault tolerant. So for a system to be fault tolerant, what I told you, what you should be doing, you should be replicating your data. So now, if you are going to be replicating this data, if you are replicating this data at 2 other places as well, so you can say multiply by 2, or let me say about the replication factor. Like generally we say we should be having a replication factor of 3, like your entire data should be available at 3 other locations as well. So what is going to be the total size for that? That is going to be 3.65 into 3. So this much amount of data we are going to be requiring. Also, I had one more requirement where I was saying that it should be able to run on different operating system. Now, every operating system is going to be having a different file format. For a video, for a picture, anything, all of the operating systems are having different file formats. So what we are going to be doing, generally how it happens for any of the videos. So if you have any video, let us say we are considering one format which is MP4, one format which is MKV. I'm just considering these two formats. Now for this video, we are also if you talk about YouTube and all, you know that we have different resolutions for that. So 360,